In today's video, you're going to get a 7-part series of the Endpoint Security Monitoring module inside of the SOC Level 1 pathway of TryHackMe. And the breakdown of that looks like this. So we have the intro to endpoint security, core Windows processes, SysInternals, Windows event logs, SysMon, OSQuery, and Wazuh. This video is sponsored by SurfShark. It is an all-in-one antivirus and VPN solution that you can apply to unlimited devices and make sure that you secure your devices and your data. You can get access to SurfShark for 7 cents a day, which ends up to being $2.20 per month. And you can find the link to that promotional price in the description below. To get more cool videos on cybersecurity, ethical hacking, and pen testing, go ahead and like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out. Now, without further ado, let's jump into the contents of our video today. All right, hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite system and network attacker. And today we are going through the Intro to Endpoint Security module that is available at TryHackMe at their SOC Level 1 pathway. So we've done a lot of these videos already, and all of these exist on the channel, so you're more than welcome to go through all these things. But today we're going into the endpoint security module and all of these different individual sub-modules. And as of right now, we're doing the intro to endpoint security. Real quick, before I get started, just wanted to kindly and humbly request that if you like anything from this channel, or if you've gotten any value from me at all whatsoever, it would be more than honor and a privilege for me if you could like and subscribe and turn on the notification bell and even drop a comment, because all of that helps so much with the YouTube algorithm. And that's really the only thing that I want from you. I'm doing all of this stuff for free. I will post multiple times a day, at the very least once a day. And all of this is available to you for free. And you're more than welcome to go through this content. And it would just help me out a lot, because I'm trying to build this channel up and grow the community and add value to as many people as I possibly can. So it would be very, very lovely, and it would honor me, and it would be a privilege for me if you would end up following and subscribing and even sharing, telling your friends about it, so on and so forth. So all of that helps the algorithm and helps us grow. So that's basically it. That's all I'm going to say. Now let's actually, without further ado, let's jump into the introduction of the room. Okay, so the room, we're going to be going through the fundamentals of endpoint security monitoring, the tools that are involved, and the high-level kind of an overview of finding a malicious activity from an endpoint. And your computer could be an endpoint, an IoT device could be an endpoint, a server could be an endpoint, and then mapping the related events to that endpoint. To start, we're going to tackle 3 specific topics. And learn how to kind of deal with the endpoint security monitoring task in general. One of them is going to be the fundamentals of endpoint security. The other one is logging and monitoring. And the last is log analysis. So by the end of this, we should have a threat simulation where we can actually investigate and remediate some of the infected machines. And it may require first to understand the fundamentals. So obviously, we're gonna go ahead and do that. So let's actually run into it and let's see what we can learn here. All right, the endpoint security fundamentals. So first thing, there's the core Windows processes. Before doing anything else, we need to understand of how Windows operating system works without any kind of knowledge. Differentiating an outlier from a haystack of events could be problematic. So trying to find a needle in the haystack is basically what they're talking about. A built-in network tool named Task Manager can help us understand what goes on inside that. And Task Manager, I used to use it just to end certain things that weren't operating, but it actually is very useful. So it's a GUI, graphic user interface tool that allows us to see what's running. And it provides information on the usage, such as how much each CPU each one is using, how much RAM each one is using. And if it's not responding, you can use it to force the thing to end. And that's what I used to use it for all the time. When a program stopped responding, I would do Control Alt Delete, Task Manager pops up, and then I would force the thing to stop running. So it provides some of the core processes running in the background, and a lot of these are considered normal behavior. So this little forward slash or the greater than symbol represents a parent-child relationship. So if you see system and SMS exe, the system is the parent, the SMS is the child of it. So we have the system and a system SMS. Then we have CSRSS, win init, and then services under that, and then SVC host under that, LSAS, win logon, explorer, so on and so forth. So the processes with no depiction of a parent-child should not have a parent process under normal circumstances, except for the system process, which should have a system idle process as its parent process. And we can refer to the core Windows processor room to learn more about this. Let me see if I've even started this at all. I don't think I have. Yeah, I don't recognize it. So that's a whole other thing that I probably need to learn and go into just to get a better understanding of it. SysInternals, we can see what this does. It's a compilation of 70 plus Windows-based tools. Each of them fall into the following categories. So out of all of these 70 fall into one of these things. File and disk utilities, network utilities, process, security, system information, and miscellaneous, which probably covers a lot of things. We're going to go into two of the most used ones, which is TCP Overview, which is a networking tool, and Process Explorer, which is a process tool. TCP View, it shows detailed listings of all TCP and UDP endpoints on the system, including the local and remote IP addresses and the state of all the TCP connections. On 2008 Vista XP, TCP View also reports the name of the process that owns the endpoint, and it provides a more informative and better presented subset of the netstat program, which is kind of like a command line, but I think netstat also has a GUI. And the download, this TCP View download includes the TCP vcon, which is a command line version of the same thing. So this is what that looks like. And so this is the process, the ID, the protocol, the local address, the local port, so on and so forth. Every connection is listed by the tool, which may aid in correlating network events executed concurrently. Then we have the Process Explorer, and it has two sub windows. The top window always shows the list of everything that's active, including name of the owning accounts, and the information displayed in the bottom window depends on the mode that the Process Explorer is in. If it's in handle mode, we're going to see the handles that the process selected in the top window is actually opened. If it's in Explorer mode, if Explorer is in DLL mode, you'll see the DLLs and memory mapped files that it's loaded. And so in this particular case, we're looking at the services, the web client that's running, and that is DLL. So I'm guessing this is the DLL mode that we're looking at. So it enables to inspect the details of a running process, such as associated services, network traffic, handles like files or directories that have been opened, and memory mapped or DLL files that have been loaded. So to learn more about this, we can go into the SysInternals room, and all of these things I don't even recognize, so I probably need to actually go and do all of that just to get a better understanding of this. So what is the normal parent process of services.exe? That's our first question. And I believe that is wininit.exe. There we go. What is the name of the network utility tool that has been introduced in this task? And that would be TCP View. So now we got this task under our belt, and we can move from fundamentals into logging and monitoring. Endpoint logging and monitoring. So we just learned that the Windows OS has some baseline processes and tools to analyze events that are running on the machine. This only limits us from observing real-time events. With this, we're going to go into the importance of logging. So there's event logs, they're not text files and can be viewed inside a text editor, but the raw data can be translated into XML using the Windows API, and the events are stored in the proprietary binary with the EVT or EVTX extension, and it's typically inside this place right here. There are three main ways of accessing these logs: the event viewer, the WEV utility, and the get-win event, which is a PowerShell commandlet. So we can look at logs in one of three different ways. This is the event viewer, which is the graphic user interface. And so if we go under Windows logs, under security, and then we can just see all of these different logs that exist right here. And of course, there's an event logs room for Windows. And then there's SysMon, System Monitor, to monitor and log events on Windows. As a part of the SysInternals package, it's similar to Windows event logs with more detail and control. It gathers the detailed and high quality logs as well as tracing to try to identify anomalies. It's used with a SIM, so Security Information and Event Manager, or other log parsing solutions that aggregate, filter, and visualize events. It includes 27 types of event IDs, all of which can be used with the required configuration file to specify how they should be handled and analyzed. An excellent example of this is created by Swift on Security, and it's in this link. I think this is an external link. Yeah, it's a GitHub for Swift on Security SysMon configuration. So you can go look at that at your own leisure. The image below shows an example sample set of SysMon logs with the event viewer. And so these are all of our logs. Very unexciting. And of course, there's a SysMon room that's available to us. So OSQuery is an open source tool created by Facebook. Look at that. Security analysts and incident responders, threat hunters can query an endpoint or multiple endpoints using the SQL syntax. It can be installed on a bunch of different places. To interact with this, we use command line or PowerShell, and we just run OSQuery I, and you'll know that you successfully entered when it actually changes into OSQuery instead of what the normal line looks like. And so when you're in here, you can do select PID name path from the processes where the name has this in it. And so it will do that for you. So the PID from LSAS, and this is the path, right? So it only allows you to query events inside the machine, but with Collide Fleet, you can query multiple endpoints from the Collide Fleet UI instead of using OSQuery locally. A sample of Collide Fleet shows that the result of a query listing the machines with LSAS process running. So basically, we would just kind of look into it. It looks like it's a GUI type of a thing. So one host returning 95 records. So they searched for LSAS in the command line, and it brought it up. So there's that. And of course, we can go to the OSQuery room if we want to learn more. And this is either Wazuh or Wazuh. So it's an open source, free available EDR solution that security engineers can use. It operates on a management and agent model where a dedicated manager is responsible for managing agents installed on the device. As mentioned, Wazuh is an EDR, so endpoint detection. Let's briefly run through what EDR is. Endpoint detection and response are tools and applications that monitor services for an activity that could indicate a threat or security breach. These tools and applications have features that include auditing a device, proactively monitoring a device for unauthorized stuff, visualizing complex data, recording a device's normal operating behavior, and a sample of Wazuh looks like this. So you have what looks like the dashboard, and it kind of filters it further for you. And so if we just wait for it, so we can add a filter, and then the name of the filter would be logon, for example, and it chooses whichever one. And then from there, you add an operator, it exists, and then it brings us all of those things for you. To gain more experience, we can go into the Wazuh room. So where do the Windows event logs files typically reside? And that is right at the top right here
this thing. So we can just copy this and go all the way to the bottom, and it will be our answer. Provide the command used to enter OSQuery CLI. So it's OSQuery I. And what does EDR mean? So it's endpoint detection and what was it? What does the R stand for? Response. There is that. Okay, moving right along, we are now going to go into endpoint log analysis. All right, endpoint correlation, and there's a site that's attached to this, so that should be interesting. Event correlation is significant relationships from multiple log sources. It deals with identifying significant artifacts from different log sources and connecting them to each other if they're related. For example, a network connection log can have a lot of log sources such as SysMon, event ID 3 connection and firewall logs. The firewall log may provide the source and destination IP and port, protocol, action taken. In contrast, SysMon may give the process that invoked the connection and the user running the process. So we can connect the dots of each artifact from two sources. So source, destination IP, and port, action taken, protocol, process name, user account, machine name. Event correlation can build the puzzle, so it kind of connects everything. Now you have a baseline, is the process of knowing what is expected to be normal, right? So in endpoint security monitoring, it requires a vast amount of data gathering to establish the baseline. So what's standard? And using the baseline as a reference, we can quickly determine the outliers. So if you have a baseline, you can see what's out of the ordinary, basically. It's a sample list of baseline and unusual activities, right? So just as an example, a single workstation is assigned to each employee. A user has attempted to authenticate to multiple workstations. That's kind of one of them. In London, the regular working hours are between 9 a.m. to 6 p.m. User has authenticated via VPN in Singapore from 3 a.m. All of these things are kind of, this is the baseline, and then this is what's out of the ordinary, right? So this is the general approach, and I mean, you're more than welcome to pause this and kind of read that as an example. Any event could be a needle in a haystack without a good overview of what the baseline should be. So investigation activity, we've gone through some foundations, so now we're going to try to see what's going on. So we opened up that site on the side, and it says provide the flag for a simulated investigation activity. So let's see what we can actually find on the side right here. So this machine has been compromised. Identify and remediate. So identify the abnormal running process. You may open the baseline document to see what is normal. Can I move this to the side? I can. So I can't move this to the side. I can't shrink it, nothing. So we have CSRSS, SMS, WinInit, WinLogon, Explorer, and SVC host. So Explorer, SVC host, WinLogon, SMS, Beacon. That's the one. So that's the one. Okay, now what? Oh, I see. Now, based on the identified malicious process, determine the malicious network traffic. You may refer to the notes. So it says I mean, this is it right here. So Beacon, process ID, port 4444. 443 is the HTTPS port, so that seems pretty normal, and the process name has SVC host, so we can just take care of that. And now this is the IP address. So find all machines affected using that. So we're going to search for 2348.195 right there and search for that. And these are all of the ones that have been affected. So remediate, 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 remediate. And you have successfully eradicated the threat. You may now get the reward, which is the flag txt on the file right here. And there is our flag. Very straightforward, very, very simple, and kind of easy to understand, right? So there you go. And finally, let's jump into the conclusion of the room. All right, so we completed the room. Now we have an understanding of what a baseline is and why it's so important to kind of establish or try to find anomalies. Event correlation provides a deeper understanding of the concurrent events, so things that are happening all at the same time or connected to each other. Taking note of each significant artifact is crucial. Other potentially affected assets could be inspected and remediated. We covered security fundamentals, logging and monitoring, and log analysis. There's all of these other things that are available, and I feel like this is going to be a part of this path. So we have core Windows processes, which is next, SysInternals, Windows Event Logon, SysMon. All of these things are a part of all of the stuff that we're about to learn. So we are literally just going to be kind of going from one after another to just try to connect all of these things together. So there is that. We have an understanding of endpoint detection and endpoint security. And from here, we're going to jump into the next task, the next room. If you found this information useful, if you learned anything from this video, and if you want to show your support, I would very much love it if you could like, subscribe, turn on the notification bell, share the channel with the people that you know that might be interested in this, and leave a comment in the comment section, because all of those activities help us with the YouTube algorithm so that we can get more reach and try to expand the community and grow the channel, so on and so forth. It would mean a lot to me, and that's really all I ask from you. And hopefully, I'll see you in another video. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. And peace, love, and chicken grease. If no one else loves you, Hank loves you. I will see you in the next room. All right, hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite system and network attacker. And today we are going through the core Windows processes room inside the SOC level 1 pathway of TryHackMe, which is part of the Endpoint Security Monitoring module. And as you can see, this is kind of a pretty hefty room, and it's one of those things that I think there is a machine that is attached. Yeah, we do have a machine that's attached, so I'm going to start that. And we're just going to kind of run through the processes, and we're going to hopefully learn some really cool things about endpoint security and monitoring. Before jumping into the introduction right here, I just wanted to kindly and humbly request that if you learn anything from me, if you learn anything from this video, if you like the content, and if you want to show your support, it would mean the world to me if you could like, subscribe, comment, turn on the notification bell, share it with your friends that might be interested in this. Any of those activities will help the algorithm find our channel more and put our channel out so we can get more reach, and from there we can grow the community and expand our user and our accounts and our channel in general. So it would really genuinely mean the world to me. I don't ask for anything else. All of these things I do for free for you guys, so you can get as much information as possible on cybersecurity, penetration testing, ethical hacking, so on and so forth. So that's literally all I ask. That's the only thing that I would request, and that's basically it. It would mean the world if you could actually do that. Now that that's out of the way, without further ado, let's jump into the introduction of the room. Okay, so basically the intro of the room says that we're going to be going into all the core processes, as the name implies right here, that is on Windows. And there's a line right here. You know, it's the most used system in the world. Windows is, whether people like it or not. And the majority of the users don't fully understand the workings of it. And I used to be that. I still am that. I'm not even going to pretend like I know how Windows works in and out. There's a lot of stuff that's available in Windows machines. And believe it or not, it can be extremely powerful to know how this whole thing works. So basically, people are happy that it actually works, right? Just like you can use a car to drive from A to B. You don't necessarily know how, you don't need to know how the car runs and does what it does, as long as it gets you where you need to go. So if the same thing applies here, right? If you can surf the web, if you can do emails, whatever, it doesn't matter. But if you understand the inner workings of it as a cybersecurity analyst, as an ethical hacker, it just puts you head and shoulders above everybody else. So one of the essential everyday computer functions is disrupted when AntiVirus matter. So if antivirus was enough over 5 to 7 years ago, but time changes and malware and attacks have evolved, right? Hackers have evolved. Everything has gone uh, way past what the baseline was a long time ago. And 5 to 7 years is a long time in the world of technology. Like a lot can happen in a month in technology. So when you think about 7 years ago in tech, it's pretty crazy. So antivirus has struggled to keep up, obviously, based on how it's designed to catch, evil, quote unquote. It's just one layer of defense. It's one layer of a solution, and things like EDR, endpoint detection, and response have been created because antivirus can't keep up. So even with all of that, it's still not 100% effective because attackers are coming up with new things every single day. They're trying to find 0-day attacks and 0-day exploits on a daily. So when you're a SOC analyst, a security analyst, detection engineer, threat hunter, whatever, if any of the tools alerts of a suspicious activity, we have to investigate to try to see what's going on and take a course of action. And the machine that is attached is going to be a split view if we can. We're probably going to go into full screen with this thing, and we can even access it via RDP if we wanted to, but I'm probably just going to keep it in my browser and keep it simple because it seems to be, it seems to be just that we only need to do one thing with it. It doesn't seem like we need to do any kind of remote shell or any attacking directly. I think we're just going to be looking at the Windows processes themselves. So I'm going to open this up in my secondary monitor as well. And then from there, we're just going to go through each individual item that's inside this thing so that we can just kind of figure out how this whole thing works, right? So the first one, and I'll just open this in a full screen so we have this right here. The first one is the task manager, and the task manager can be opened from the view, the taskbar right here. So do we have something right here? I think it's inside this thing that we can actually go to the task manager, and let's see, I might even be able to search for it. But it says to open the task manager, right click on the taskbar, and then, so I could even do this. I could do that and then go from here, go to task manager right there. But there's a shortcut also that says Control-Alt-Delete. That's what we used to do all the time. So if there's nothing running, there's going to be nothing in here. It's going to be empty, right? So not seeing much is, I guess it's kind of weird. We can click on more details to see what else is going on. Look at that. Now we see a bunch of stuff that's actually happening in the background, right? These are the background processes. So you have that task manager itself. Let me zoom in a little bit for you, and then we'll just kind of move this to the side so we have access to it. So we have the task manager itself. We have all the background processes, and everything is under the default tab of processes. If we're running it on Windows, we might also see additional, if you're running it on your own Windows, you might see additional tabs and things like that going on. So we can notice that processes are, they are categorized as follows. So there's the apps process or apps category, which is the task manager itself. There's the background processes, and another category that we might be able to find if we go down are the Windows processes right here. And all of these things are just kind of running. The columns are minimal, as the course says. The column name, status, and CPU, which is name, status, CPU usage, are the only things that are visible. We can right click on the column section here and try to see if we can find more options, or maybe click on status and then see if we can more options. There we go. So we have the type, publisher, PID, process name, the command line, CPU, memory, all of those things are available. Then there's the resource values, which is either values or percentages that can show you how this whole thing runs. And to make it, that view looks a little bit better. So I guess we should be turning that on, huh? So let's just try that on just to kind of see what else is going on. We got the type, we got, let me see, I got the PID I'm gonna run, I'm gonna add the command line, and I'm gonna add process name, why not? And so now I can kind of expand this a little bit just to show you what all of that looks like. And it's a little bit, I mean, it's pretty cool. So if I kind of shrink the status down a little bit, we can maybe even shrink the process name a little bit just to bring everything onto the screen. And so that's kind of what it looks like. And I think we can even drag these. Yeah, we can drag these back and forth to organize them however we want to. So if I just go at the very beginning and drop the usage of this stuff at the beginning, all of the other things could be done secondary, so to speak, so that you can see a little bit more organized. So the type is each process files into one of three categories, which we already kind of saw: the background process, Windows process, or an application process that we see already. There's the publisher, which I didn't load, but it's basically the name of the author of the program, so whoever made the program. The PID is the process identifier, and it assigns a unique process to, or unique ID, excuse me, each time the program starts, so that you can modify it via the command line if you wanted to. The process name is the executable itself that's running, and the one that we're running is Task Manager exe, right? That's the thing that's actually running here. Then command line is the full command used to actually launch it, that you need to, if you wanted to run it from the command line, you would need to do the full thing, unless you're actually inside the System32 folder right here. Then you could just do Task Manager exe. But if you're inside the general root folder, then you would need to run the full thing to be able to open it up. CPU that we see now, we moved from here, is the amount of processing power from the CPU, the computer's processing unit, central processing unit. And that's the amount of power that it's using. And then the memory is the amount of physical working memory, the RAM, that it's actually using. So we don't have anything that's heavy that is using a lot of this stuff. If we go into the details tab, we might be able to see a little bit more interesting information. And we can kind of bring this up a little bit closer here. So you got running, there's one that is suspended, or a couple that are suspended. We have the username, which is assigned to it, which is system administrator, DWM1, network service, local service, all that, CPU usage, as always, memory usage, and UAC, user access control virtualization, either not allowed or disabled, is what we see as our options over here. So let's see what the text from the class says. Some additional columns to see more information. We can do the image path name and the command line. So I guess I can click on this one more time, or maybe click on this one more time. Nope. How do I add more details here? Here? Kind of doesn't really tell me. Doesn't show me how to do it. Good columns I can't add it, so I don't know how to add it. That's the issue right here. Maybe it's under view. Updated speed, nope. Options, nope. File, nope. And if I do fewer details, then it shrinks that back down, so that's definitely not it. So we can just go back to this. Can I add anything right here? Oh, select columns maybe? There we go, that's how you do that, okay. So from here, we can choose something called the command line and the image path name based on what they recommended to us. So image path name and command line, and do OK. And here we go, we got that too. So now this is where the path of whatever this thing is actually at the command line to run it. And there we go. So they can, these two columns can quickly alert an analyst of any outliers with a given process in the image PID 384. So in the one that's on the documentation of this room, is process with a name SVC host, a Windows process. But if the image path name or command is not what it's expected to be, then we can perform a deeper analysis. So that's what they're saying. So if I click on this, for example, and I guess we find, so for us, it's 496, it's not 384 for the PID. But then you go here, and then you see that the executable path is SVC host, and then the command line should also be SVC host, right? That's basically what it should be. So when you see that, that means everything is all good. But if this was pointing to a different path, or if this command was doing something different that it shouldn't be, then you know that you need to investigate a little bit further. You can add as many columns as you wish because, as you saw, there was a bunch of stuff. It's a powerful built-in network utility, but it lacks certain important information when analyzing processes, such as the parent process and another key column, which is then we can go back to SVC host and see that the parent process for this is not services exe. So I'm sorry, back to SVC host. If the parent process for it is not services exe, then we want further analysis. So I guess I could just go back here again, do select columns, and see if we can find something called the parent process. And from that, we can see if it's actually connected to the parent process that's supposed to be connected to it, right? There's actually no item called parent process on here. So I think it's actually something that we're supposed to locate from here, right? So if you see that under the image path name, for example. So, okay, now moving on from the task manager itself, we're going to go into something called the process hacker. The process hacker is a different item that I guess we can open from our search down here. So if I went to my search box right here, there is no actual search command down there, so I would need to manually do this. And then from here, if we look for process hacker, there it is, process hacker desktop app. So that's going to open itself up and it's going to show us a certain number of processes, and then there is the process explorer also. That is another thing that ends up helping us, and there is really not much with the process hacker and process explorer in this particular task. I think we're going to look at it a little bit later. So to see, as always, it's encouraged that you inspect and familiarize yourself with everything that's available in Task Manager. It's a built-in utility that's available for every Windows. You might need to find yourself in a situation where you can't bring your tools to the fight and rely on the tools native to the system. So these are the things that are native to the system. Aside from Task Manager, it would be good if we learn the command line equivalent of obtaining information about it on a Windows system, which is the task list, get process, or PS for PowerShell, and WMIC. So those are some of the other things. And since I've already loaded the process hacker, I'm just going to leave it on the screen right here. But we're actually done with the task for Task Manager. So the next thing that we're going to go into is the system. So we just finished Task Manager and we're going to go into system next. Okay, the system, this is the first Windows process on our list, apart from the Task Manager, I guess. It was mentioned in a previous section that a PID for any given process is assigned at random, but that is not the case for the system process. The PID for system is always 4. So we can actually see that right here. The system PID is 4. So that, I guess, means that it's always going to be 4. The official definition from Windows is the system process, process ID 4, is the home for a special kind of thread that runs only in kernel mode, a kernel mode system thread. The system threads have all the attributes and context of regular user mode threads, but are different in that they run only in kernel mode, executing code loaded in the system space, where that it is the NTO whatever something exe or any other loaded device driver. In addition, system threads don't have a user process address space and hence must allocate any dynamic storage for operating, such as a paged or non-paged pool. So what is user mode, kernel mode? They say visit the following link to understand each one. So we're not going to do that right now. So what is normal behavior for this process? We're going to use Process Explorer to try to view the properties of the system. So right now I am in Process Hacker. So I'm going to go back to search and I'm going to open up Process Explorer. Okay, so I think that's non-existent. It might be this thing right here that is inside that window. So there we go, Process Explorer, and we have different versions of this. It says, I don't think it matters which one I use, but we can kind of use whichever one really. So let's just use Process EXP, the first one, which is the full application. And it's gonna ask us if we want to agree to the license, and we should, and here we go. So it looks pretty similar to the Process Hacker that's right there. And so if we look at the system right here, the PID, it's on a different column, but the PID is number 4. And then there's a bunch of different information about it as well. And then if you notice, the difference between that and the Process Hacker is that at the top right here, we get these little graphs that actually show us how much of each things are being used. So this is the CPU, the system commitment, physical memory, I/O, the network, disk space, so on and so forth. So there's a difference, I would say, probably significantly. I don't know fully yet, but we're gonna learn as we go along this room right here. So when we open up Process Explorer, we can view the properties of system. So I guess I can double click this. Can I double click that? Yeah, I can. So now we have the system properties. And inside the system properties, there's a bunch of different tabs. And the very first one on the image tab at the beginning shows us the path, the command line, and the current directory, which is all empty. And then the parent is none because it is the system, and the user authority itself is system. So that's kind of important to know. The information is different if we use the system properties using the Process Hacker. So if I push this to the side and go to this and double click that, it's a little bit different. It's not an image tab as the general tab or as the main tab. It's the general tab. So it shows us the kernel and system, and it shows the version of it. It shows the file name where it exists, the path where it exists. There is no command line, so as we already saw, the current directory doesn't exist, and the parent is the system idle process. So those are, it shows some similar information and definitely some different information. Specifically, the parent process, system idle process, that part is different, and of course the path I think is also different. So if we go over here and try to look at the path comparing the two, this one right here doesn't even have a path. This one seems to have a path. Let's see if there's any other information down here. No, but this one that pretty much has blank everything, and then the user is whoever that is, but that's pretty much all the information that we get. And so we have a decent difference between Process Hacker and Process Explorer. So you may notice that Process Hacker confirms that it's legit, verifying Microsoft Windows. And then what is unusual for this process would be that the parent process, aside from system idle process, so if this parent process is different, then we could see that it might be kind of sketch. There might be multiple instances of the system inside any of these things. So if you see multiple systems right here, and maybe even the PID is different, right? So what if the PID was different? That also should be sketch. And then it says not running in session 0. So that's another thing that might be sketch. And so I think that was, oh no, you know what? That's when we actually open this up and it tells us where it's running. So it might be in this thing where it says it's running in session 0. Can't find that information right now. Yeah, I don't see it. So where would we find if it was in session 0? Cannot locate that right now. But I mean, that's pretty much it. That's kind of the Process Hacker as well as the Process Explorer, looking at specifically the system process. So now that we can do that, the question at the bottom, it says, what PID should the system always be? And we've already established that, and it needs to be PID 4 is what the system should always be. So now we're going to go look at one of the child processes for the system, which is the sms.exe executable. So we did the system, and I'll just reload this just so you can kind of see that we actually have done these things. So we did the system, and the next one is the sms.exe. So let's try to find that inside our Process Hacker and Process Explorer. Okay, the SMSS.exe is known as the Session Manager subsystem, and it's also known as the Windows Session Manager, and it's responsible for creating new sessions. It's the first user mode that is started by the kernel. It starts the kernel and user modes of the subsystem of the Windows, and it includes the Win32k sys, the WinSRV DLL, and the CSRSS. And so the Win32k sys is the kernel, WinSRV is the user mode, and then CSRSS is also the user mode. So it starts CSRSS, which is the Windows subsystem, and WinInit.exe in session 0, and it's isolated for the operating system. And it starts CSRSS and WinLogon for session 1, which is the user session, and it the first child instance creates child instances in new sessions done by SMSS, copying itself into the session and self-terminating. So we can read more about that probably when we actually get further along. And so session 0 is CSRSS and WinInit. And that's the thing that I'm really trying to find out, is like, how do we find out if we're in session 0 or not? That's the part that I'm really interested in. But specifically, we have this section right here. So we can look at the WinInit and CSRSS right here. So you have CSRSS and you have WinInit, and then under WinInit we have a bunch of other things that are currently running. And I guess we can click on one of these things to try to see where it's actually there. It is. Now I see it. So okay, it's not inside any of these views, but I just read the documentation and it showed it to me. So if I click on this, and if we go to the token, and it doesn't even have token as a tab, so maybe it's inside the Process Hacker. So if I click on CSRSS and then go inside token, voila, we should see session 0. And where would that be? It would be under the session parameter. Okay, so this one, actually there it is. So this one is actually in session 1. So let's see if the other one is in session 0. Yeah, this one is in session 0. So it says that on the system level, it'll be in session 0. On the user level, it'll be in session 1. So this one, since it's session 0, it would be on the system level. And then this one, since it's session 1, it would be on the user level. Session 1, so on and so forth. Another subsystem listed in the required value of the registry editor is also launched, and that is, I guess, called Debug Windows. And I don't know if this is available here. It would be interesting if we could search. We can search. So let's see if we can search for debug. Debug is not here. So, but it says, so let's kind of go look at the actual task instructions here. It says any other subsystem, not another. So any other subsystem listed in the required value of this section, which is the registry editor for that registry, is also launched. So if it's under the required section of this registry, that's also going to be launched. SMSS is also responsible for creating environmental variables, virtual memory paging files, and starts WinLogon. So what is normal? It's going to be any of these options right here. So we can go back here and try to look at that information, and it doesn't tell me which version of this they used to check this. So we can do SMSS. Let me see if I can find SMSS. Maybe it's under processes. Of course, I can just search for it, which is probably a good idea. Find file handle SMSS, search, and we have a bunch of these things. So process, so on and so forth. So there it is. And there's 4 instances of this, I guess, but let's just open one. So, I mean, so SMSS, I guess, is the system itself, right? So this is not the view that we're looking at in the exercise file. This is the view that we're looking at in the exercise file. And so the general looking at it, this is what's normal, and it should be inside all of this. We already kind of viewed this. The process should exactly be as it is right now, and the parent should be system, which is number 4. So that's all normal. And then there is the unusual, which would be the parent is different other than system 4. The image path is different, more than one running process, so children self-terminate and exit after each new session. The running user is not the system user, and expected and unexpected registry entries for that subsystem. So the question that we have here is, aside from CSRSS, what process does SMS spawn in session 1? And if you remember, session 1 is the user session. So it's going to start winlogon.exe, and that is the answer to our question for this section. So now we're going to move on from the current task that we're in, and we're going to go into the next one, which would be the CSRSS.exe. Okay, so as mentioned in the previous section, client server run process, whatever this is. Why can't I zoom in? There we go. It's in the user mode sign of the Windows subsystem, which would be in session 1. It's always running, and it's critical to system operation. If the process is terminated by any chance, the system fails, and it's responsible for Win32 console window and process thread creation and deletion. For instance, this DLL, that DLL, and that DLL are all loaded along with others. It's also responsible for making the Windows API available to other processes and mapping drivers, handling Windows shutdown, and we can read more about it over there. The recall, to recall that WinLogon and CSRSS are called for session 1, right? So this is what's going to be normal. So let's go and try to find the session 1, and this is the session 1 version of this. And in this particular one, we are looking at the process hacker view, and that's what they're also looking at inside the task instructions. And so this is what's normal, and this looks like normal. The command line is exactly what this should be, and that's also what's normal. The current directory is fine. The started time, we started this 30 minutes ago, so that's all good. The parent should be non-existent, which I guess that's also good. And that is the session 0. Is this session 0? So let's look at this. This is session 1. So this is session 1, and I mean, it all still looks good because it's pretty identical to everything else. So if we look at session 0, it should also be pretty identical. So general, all that stuff is here. The root is pretty much the same. The Windows 32 is the same. Start time 30 minutes ago. Non-existent process. All of this is identical to each other. There's just one that's happening for the system, and there's one that's happening for the user. So it's saying in the file that notice what is shown for the parent for these two processes. Remember that these processes are spawned by the system, the SMSS, which self-terminates itself, meaning that the parent should be created by an instance and there should be nothing else there. So image path is the same that we just saw. Number of instances should be fine. User account is the local system. Start time within seconds of boot time. So meaning we started this thing 30 minutes ago. We started this machine 30 minutes ago, and it's approximately 30 minutes. That's when it was started. So an actual parent process might be unusual. So if it has an actual parent process right here, this is kind of weird, right? It shouldn't have that. The image file, if it's anything other than the system32, that's also sketch. The subtle misspelling to hide rogue processes that might be wrong. So if this is subtle, so CRSS might be sketch, so it's like you just got to pay attention to the misspellings. And the user is not a system user. That's also pretty sketch as well. So that's basically it for this. Now it says, what was the process which had a PID of 384 and a PID of 488? So in this case, let's see if we can organize by 384 and 488. I don't have either one here. And what if we organize here? 384, 488, I don't have it here. So in this particular case, I'm guessing they're talking about their own, yeah, they're talking about the specific task file itself, right? So here, 384 and 488 are probably not, obviously they're not here because both of these have different PIDs. So if we go here and try to find the PIDs for these things, we could probably find something different. None of that stuff is available here either. So I wonder what they're referring to when they ask that. Okay, I mean, just taking a shot in the dark, and I wrote down smss.exe, and that happens to be the PID, or that's what was attached to this PID, which to me, it's very odd that that would even be listed because it's not in the machine that we're using, and it's not anywhere on the screenshots here. So it's kind of weird. Non-existent process. Oh, here we go. So it's in here, right? So that's where it is. So if they're saying that the parent of this is the SMSS, and right here it says non-existent process 488, that's what we can refer to. And non-existent process 384, that's what we can refer to. So that's what they were referring to in this particular exercise. And if it's the parent process of CSRSS, that means it is the SMSS parent. So that's what that means. So now moving into WinInit. All right, WinInit, the Windows initialization process, also known as WinInit, is responsible for launching services EXE, the Service Control Manager, LSAS, the Local Security Authority, and LSASO, whatever, with session 0. It is another critical window process that runs in the background along with all of its child processes. And LSASO is a process associated with credential guard and key guard, and you will only see it if the credential guard is enabled. So if it's not enabled, we shouldn't see it, right? So going into our process manager and process hacker here, let's try to look at what is normal and what is not normal. So going to look for the WinInit first and foremost, and I'm gonna change it by name again so we can try to find it that way. I forgot how it was originally organized, so I'm just going to go back to here. And so here we go. We got WinInit right here, and we're going to open this up. And what's supposed to be normal is that this is the path. So that's the normal path. The executable should be this. The current directory should be this, started exactly when we started the machine. And the process itself should be, it says a non-existent process, which means it needs to be the system itself, I guess. And so in this particular situation, it would be SMSS. And so for us, it's 560. So if we were to look at SMSS, it should be 560. Nope, it's not, it's 460. So let's see what's PID 560 in this situation. And maybe that'll help us kind of narrow this thing down. There is no PID 560. That's what's weird about this, man. It's like, what are we talking about here? Okay, fine, whatever. So WinInit is right here, and then if I find WinInit, oh, there we go, boom. It's like right there on the screen. If I find this and maximize that, so if I do by process, or can I do? I want to go back to the point where I could actually see everything that's under WinInit, and it won't show me. Oh no, is that it? I think that's what it is. Yeah, it doesn't seem like that is what it is. So if we click on WinInit right here, same command line, same current directory, same on the path. So all of this stuff is good. I just made the mistake of, I'm just going to close these out so it resets everything. But I made the mistake of organizing by PID to try to find that PID. And so here we go, WinInit. Is it organized by, oh, it's still organized the same way, son of a gun. and same thing with with the process hacker. So now we are in a little bit of a challenge, I guess, because I forget what the original organization was for this, but whatever, that part doesn't matter. So the that's kind of what it looks like, and we need to know that that's what it looks like. So that's the actual path. It should be created by an instance of SMS, which we already saw. There should be one instance of it. It should be on the local system, and it should start within seconds of us starting the machine. So what's unusual is that there's an actual parent, so calls this process and self terminates. So if there's an actual parent, that means it's not going to be no non-existent process. That's not going to be that. Image file is other than system32, subtle misspellings, multiple running instances, and it's not running as system. So which process might you not see running if credential guard is not enabled? And that process is right here, which is LSISO, whatever that, how you pronounce that. That is what would not be running if we don't have credential guard enabled. So that was a quick one, WinInit, and now we can move on to WinInit, the services exe underneath that. So the next process is the Service Control Manager, also known as SCM or Services exe. It is primarily responsible to handle the system services, loading services, interacting with services, and starting or ending services. It maintains a database that can be queried using sc.exe, and we've done this a lot. So we've actually used this to start and stop services on the Pentest Plus pathway, because you can do a lot of things with this to gain escalated privileges or to gain remote shells and stuff like that. So it is a very, very important process. It is in the registry under this path, and this is kind of what it looks like. These are all the services that would fall under that. It also loads device drivers marked as auto start into memory. When a user logs into a machine, the process is responsible for setting the value of the last known good control set, last known good configuration, which is also in the registry, and it sets the value for us. And then we have, what is this? So it's under here, system select, and then last known good would be under there. But you can also just go to that path directly by typing all of that up. And it is the process is the parent to several other key processes: the SVC host, spool, MSM, DLL host, just to name a few. And we can read more about it there. What is normal is for this to look the way that it does here, and what is not, and it should be a session 0, it says, and what is not normal would be anything other than that. So let's actually go and try to confirm that's actually what ours looks like, right? So we're going to go over here, and we are looking for services.exe, which would be under S in this particular situation, and there it is, services.exe. And so far it looks normal, so it's inside the system32. The path command is the same, it's inside system32 for the current directory. It started when we started. WinInit is the parent, and that's exactly how it should be, and that's it. And so if we went to the token just to look at the session, it is also session 0. So all of it is all good. And so now if we go here, how many instances of service exe should be running on a Windows system? And we can say that it should be only one instance. And that is all good. So now we can move on to WinInit services SVC host. The service host, the host process for Windows services is SVC host, is responsible for hosting and managing Windows services. Services running in the process are implemented as DLL, and the DLL to implement is stored in the registry under parameters in the service DLL. The full path is this, and it's whatever the service name would be, and then under its parameters. So for example, dcom launch would be under services, dcom launch parameters. And then to view this information from the process hacker, we can right click on the service host process, And in this case, it's PID 748 and whatever they're looking at over here. And then we can go services, decom launch, and go to service. Right click the service and select properties and look at the service DLL. And that's what it looks like over here. From the above, the binary path is listed. Also notice that it's structured. There's a key identifier, which is -K. So it's right here. This is how a legitimate process is called. The -K parameter is for grouping similar services to share the same process. The concept was based on the OS design to reduce to reduce resource consumption. From Windows 10 version 1703, services grouped into host processes changed. On machines running more than 3.5 gigabytes of memory, each service will run its own process, and you can learn more about that over there. So back to the key identifier from the binary path, the K value is decom launch. So other services running with the same binary in the virtual machine attached to this room. Each will have a different value for service DLL. And so let's take LSM. So again, right here, right, LSM as an example, and inspect the value, which is right here, system root, system LSM DLL, and then LSM properties, which should match exactly to that. So since service hosts will always have multiple running processes, the process has been a target for malicious use. Adversaries create malware to masquerade as this process and try to hide among the legitimate service host processes. They can name the malware service host exe or misspell it, such as service SCV host instead of SVC host. By doing so, the intention is to go under the radar. Another tactic is to install or call a malicious service DLL. Extra reading would be in the Hexacorn blog. So what is normal would be all of this right here, meaning the image path is at system32. The parent process is services exe. There's a lot of instances. User account varies, so it could be the system, network service, local service, depending on the instance. In Windows 10, some instances are logged in user, and start time is same, several seconds of boot time. What is unusual? Parent other than service, other path, subtle misspellings, and the absence of the K parameter. So what we're going to do is we're going to go and search for, what is it, svc.exe, service host.exe, excuse me. So we're going to go here, we're going to go down here and look at that. There's a bunch of different instances of service host.exe, and it all matters. It all could be pointing to different things. The one thing that needs to be is that -K that's there, and the parent is system32. The current directory is that, and it could be pointing to really anything. So if I right click on it and go to services, and then there's a bunch. So this is the one specifically, LM host, that's attached to this. We can also have the event log. We have DHCP that we can go to, time broker service we can go to. So there are a bunch of things that are under this particular one. So if we right click on another one, and if we go under, where is it? Services, there we go. These are all the services attached to this one. And so I guess they're, similar services, right? So if we go under services for this one, these are the two services attached to that one. And so this is kind of how it looks, right? So you go to services for this, DHCP, let's go IAM host, go to service, and it'll open it up under services, not processes. It'll open it up under services. And then we can see it here. If we double click on this, it'll open it up, and it'll say it's pointing to its individual DLL in there, and it has the K parameter, so all of that. So looks good. Looks like this system hasn't been hacked. So now what is the question here? It says, what single letter parameter should always be visible? And that is K, my friend. So moving on to LSAS.exe. Per Wikipedia, the Local Security Authority Subsystem Service is a process in Microsoft Windows operating systems that is responsible for enforcing the security policy of the system. It verifies users logging onto a Windows computer or server, handles password changes, and creates access tokens. It also writes to the Windows security log. It creates security tokens for the security account manager, Active Directory, and net logon. It uses authentication packages specified in this registry, and you can see all of the right here. These are the various things that are attached to it, and we have Kerberos in here. So it seems to be a very important one. It's another process adversaries target. Obviously, common tools as Mimikatz are used to dump credentials. We did that in the last video for, I want to say, lateral movement or something like that, to hide in plain sight. Again, we do this by either naming it different or by actually using the process name or just a simple misspelling, so on and so forth. Extra reading, how LSASS is maliciously used, and additional features that Microsoft has put into place to prevent these attacks. And now we have what is normal. So the pattern is the same, right? So it should be in the system folder. The parent process should be exactly what it is. There should only be one instance. It should be only on the user account, which is the local system, and within seconds of boot time is when it should be starting up. So a parent process other than winit.exe would be problematic. Image file other than what's under system32, subtle misspellings, multiple running instances, and not running as system. So what is the parent process for this? It's going to be winInit.exe, and that's the answer for that. So moving on to the next particular one, which is winlogon.exe. Windows Logon, or also WinLogon, is responsible for handling secure attention sequence. It is the Control-Alt-Delete key combination. People press to enter their username and password, right? So when you start the computer, it typically asks you to do that so that you can enter your username and password. It's also responsible for loading the profile. It loads the NT user database into HKCU and the HK current user, that's what that is, and user init loads the user's shell. And more about that could be on that link. And so this is what the registry looks like. If we go under WinLogon, we can see that the shell is running as explorer.exe. User init is running at user init under the system. It's also responsible for locking the screen and running the user's screensaver, among other functions. You can read more about it. And the earlier sections that we saw, SMSS launches this process along with a copy of CSRSS within session 1, which is the user. What is normal is for it to look like this, be in the system, have a command line winlogon. The current directory should be that. It should start exactly when we started, and there should be no existent processes because it belongs to SRSS. And since it is under the user and not the system, it would be session 1 instead of session 0. So all of these things are here. It could be one or more instances, local system, instance of SMSS. Analysis tools usually do not provide the parent process name. Within seconds of boot time, additional instances occur as new sessions are created. What's usual or what is unusual is an actual parent process. Image file could be something other than system32, subtle misspellings, not running as system, and the shell value is something other than explorer.exe. So what is the non-existent parent process for WinLogon? And it would be smss.exe. Okay, pretty straightforward. And just in the interest of time, that's the reason why I'm not going into this tab and looking at these things, because we're running a virtual machine inside of TryHackMe. So I am almost 100% sure that this thing is exactly how it should be. It's configured as it should be. So I'm not really concerned about that part. So we just need to really understand where it is, what it does, and what is normal and not normal for this thing to be running. So let's move on to our very last one, which is explorer.exe. All right, explorer.exe is the Windows Explorer. This process gives the user access to their folders. It also provides functionality for other features such as start menu and the taskbar. It should be under the user init, which launches the value inside of this registry. User init exits after spawning explorer exe. Because of this, the parent process is non-existent. So explorer.exe, you have task manager that's under it, and pretty much anything else that would be under that file explorer, right? The Windows Explorer. What's normal is for it to be under Windows itself and not system. So Windows Explorer, the command line is explorer.exe. The current directory, I guess, would be the system32 directory. It was started when we started, and there should be no parent process or no existent process. So that's the image path for it, the created by the user init, and it exits immediately. So one or more per interactively logged in user. The account would be whoever the user is. First instance is when we started logging in, right? It's an actual parent process would be unusual. So user init calls this and then exits immediately. Image path other than Windows, running as an unknown user, subtle misspellings to hide it, and outbound TCP IP connections. That's a new one. So if, let's see what this is right here. Resolve address protocol remote state TCP IP should be none right here. So if we actually went in that environment and checked that out, and I think this is for the process manager. So I do want to check this one out because I'm interested to see what that looks like. So if I go to Windows Explorer, is that what it was called? Oh man, what is it called? Explorer.exe. Okay, got it. Explorer.exe right here. Open this thing up, and TCP IP right here. It should be nada. There should be no connection to anything whatsoever. And so that's all good. So what is the non-existent process for Explorer.exe? And that would be the user init.exe. And that's correct. Okay. Sounds good. And we just went through all of the core Windows processes that we should be concerned with as a security analyst, a system analyst. So let's jump into the conclusion and then we'll wrap up the video. All right, so in conclusion, understanding how the operating system functions as a defender is vital. The Windows process discussed in this room are core processes, and understanding how they usually operate can aid us in identifying unusual activity on the endpoint. With the introduction of Windows 10, new processes have been added to the list of core processes to know and understand the normal behavior. Earlier, it was mentioned that if credential guard is enabled on the endpoint, then an additional process will be running, which will be a child process to win it, and it's called this, right? Say-so, whatever. The process works with LSAS to enhance password and protection. Other processes with Windows are Runtime Broker and Task Host, formerly Task Host EXE and Task Host XEXE. So if we research these things and understand anything and any other processes that you think we would be curious about, and this is something that I'm pretty sure is just, it could be a mastery class or a master class in itself, because there are so many things that are running on that list, and one by one you could just be learning about them. So the information from this room has been gotten from any of these things. So there's the Microsoft documentation, sans.org, which is a big one, and of course GitHub itself. So there's a lot of stuff that we can be learning about this, and I mean, I highly recommend that if you're interested in becoming a security analyst or system administrator, that you learn everything that there is to know about the core processes, just so you can understand how it all runs and what should look like and what it shouldn't look like, right? So that being said, we are now wrapped with this room. If there was anything that you learned from this room, or if you found any value from it, if you liked the way that I teach, whatever it is, I would highly, highly appreciate and kindly request that you could like, subscribe, turn on the notification bell, share the video with somebody that might be interested, leave a comment. Any of those things would help tremendously in gaining privilege and gaining what do they call it? Favor with the YouTube algorithm, so that we get more reach on the channel and get more people to see the stuff and grow the community. And that's really all I ask from you in return for putting these videos out, so that you can learn from them for absolutely free. So not to guilt trip you, but I'm kind of guilt tripping you. And that's really all I can ask. So that's all I need from you, and that's all I'm going to say about that. This is your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. If no one else loves you, Hank loves you. Peace, love, and chicken grease, and I will see you in the next room. Later. Alright, hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers. And we are continuing down the endpoint security and monitoring pathway of the SOC level 1 pathway. So I guess it's the SOC level 1 pathway, and we're in the endpoint security monitoring module. And as a part of that, today we're going to be doing the SysInternals room. And that's essentially the path that we're on. I do believe that this is, it's a subscriber only room, so it would require that you get an actual subscription to TryHackMe. And if you wanted to do that, there's a link in the description below for that. Before we jump into the intro of the room, just a quick friendly reminder that if you learned anything from me, or if you learned anything from this video, or have learned anything from this channel, if it makes your life easier as a cybersecurity analyst, any of those things, or if you just want to show support, it would mean the world to me if you could like, subscribe, and turn on the notification bell so that you get notified next time a video comes out. And of course, if you could drop a comment, doing any of those things would actually help the YouTube algorithm find our channel more and easier, and kind of give us a little bit more of a boost so that we can grow the community and expand our reach. That's really all I ask from you. I do all of these things for free, and I drop at least one video a day, sometimes two, sometimes three, and it's all along the pathway of the cybersecurity analyst and ethical hacker. So that's really all I can ask, and that's all I'm going to say about that. Without further ado, let's jump into the introduction of the room. Okay, so the introduction talks about what the tools known as SysInternals are. It's a compilation of over 70 Windows-based tools, and they all fall into one of these categories, which is the file disk utilities, network utilities, process, security, system information, and miscellaneous. We kind of talked about this in the last video. The SysInternals tools and their website were created by Mark Rusinovich in the late 90s, alongside Bryce Cogswell, and under the company SysInternals Software. In 2006, Microsoft acquired them, and Mark joined Microsoft. Today, he's the CTO of Azure, so he's been around for a while. He made headlines when he reported that Sony embedded rootkits into their music CDs back in 2005. This discovery, that's actually pretty crazy. I didn't know that. This was made known thanks to one of these SysInternals tools he was testing. And that's pretty cool. I had no idea. So he also discovered in 2006 that Symantec was using rootkit-like technology. And so this is pretty cool that SysInternals can detect these types of things. They're extremely popular among IT professionals who manage Windows systems. These tools are so popular that even red teamers and adversaries alike use them. Throughout this room, we're going to talk about the tools which MITRE has identified and has been used by adversaries, which is very cool, good to know. The goal is to introduce us to a handful of SysInternal tools, and then hopefully we'll just do a lot more further research about that. So we need to access this machine right here. This is what was done through pressing that green start machine. It takes about a minute, maybe 2 minutes for it to start up. And then this is kind of what it looks like when you just get into it. So I believe in order to access it, we need to do this real quick, and then we can extract all, I guess, into the desktop, and that is where it's going to get extracted, and it'll open up a new folder for us that we can access. And the certificate, it says accept the certificate when prompted, and you should be logged into the remote system. The virtual machine takes about 3 minutes to load. That is why I did it before I started the recording. And apart from that, I think that's pretty much all we need to get this done. So I'm gonna get this thing started real quick so that it can open up, and there's probably a SysInternals executable that we can click on to make this thing start running. And once we have that, we'll continue with the rest of the room. Before we do that, actually, so let's answer this quick little question right here. So it says, when did Microsoft acquire the SysInternals tool? And obviously it says it right here. So in 2006, Microsoft acquired the Win internal software that included SysInternals. All right, to install SysInternals, we could either do the there's the SysInternals utilities index that goes literally to the Microsoft page, and you can download the entire thing. And it looks like this, where you would just download it, and then individually you can kind of go to the categories that you want and choose to download whichever tool that you want to actually use instead of downloading the entire suite. And then you can do the same thing via a live URL, which is this thing. Instead of downloading this kind of not portal, but I guess the browser that would be as an application on the desktop. The live link looks like this though, so it doesn't separate anything by categories. And if you want to download the entire suite, then you could download the entire suite as a zip file, which is actually what this was on the right side over here that I clicked. So this is the zip file that they downloaded, and then I unzipped it, and it opened up this thing for me. And so this is all of the stuff that's inside the SysInternals suite. So every single one of these is a part of the suite, and we kind of have it handy on the desktop in the virtual machine right here. What is it? So the suite has a select number of SysInternal tools. Below is just a rundown of the tools included in the suite, which is, a lot of stuff. And after we download the zip file, we got to extract it, so on and so forth. And then what we can do is we can also add it to the environment variables of the computer that would be edited from system properties. And you could either open up system properties by searching for it, or you can open up a command prompt, search for sysdm.cpl. And then when it opens up, you would go to advanced, click on environment variables, and then pick the path, which is the environment variable that we want to edit. And then under that, we would edit it, and then we would click a new, and then choose what the actual path of the thing is that we want to use. And then from there, you can execute from the command line. So it actually says when you click on new, you got to enter the folder path where the SysInternal suite was extracted to. So make this as a mental note and just keep that in mind. And then obviously don't move it. So wherever you're going to place the SysInternal suite, make sure that it stays there and you don't move it. If you do move it, it's not going to work anymore, and you need to reset your path variable. Once that is done, then you can do an elevated command prompt, and then just do procmon, which I guess opens up the process monitor, which is one of the things that's available from SysInternals. And there's a lot of different things inside the process monitor, obviously. So a local copy of this has been installed for us. It's inside the C tools SysInternals on the virtual machine. And then there's a PowerShell module that we can download and install all of the SysInternals, which could be this. So you could just run this PowerShell, download SysInternals tools from that, and then it would run it for you. So the question here is, what is the last tool listed within the suite? So if we just go here and just scroll all the way to the bottom, what did I just do? I think I zoomed in too much. I think I zoomed in, and so it made the thumbnails a little bit bigger, the icons a little bit bigger. But it's I think it's Zoomit 64. I believe that's what it says. So Zoomit 64. Is that right? No, it's not right. So let's see. Zoomit maybe. There you go. So it's Zoomit, not Zoomit 64. And that's it for the question for the installation. Let us now move on to using SysInternals Live. So per their website, SysInternals Live is a service that enables you to execute the internals tools directly from the web without hunting for and manually downloading them. So you can simply enter the SysInternals live path into Windows Explorer or a command prompt as that, and then it'll just open it up. So if we wanted to do this, we can just launch Process Monitor from the web syntax using something like this, right? So it would be, I guess, live.sysinternals.com/tools/procmon. That could be a way that we do it. And so it says it fails. To resolve this, the WebDAV client must be installed and running on the machine. So WebDAV is a protocol that allows a local machine to access a remote machine running WebDAV share and perform actions in it. On Windows 10, the WebDAV client is installed, but the client is more likely not running. So if you try to run SysInternals, it will fail, which would be this thing right here. And so the next step would be to start a PowerShell, which is what they did, and then do get service web client, and it would show you that it's been stopped. So start service web client, and that would get it done. So get service web client, it says that it's running, and then verify that it's running before proceeding, I guess. So there it is. And then now we can go and do network discovery. It needs to also be enabled, so that's another thing. And this can be enabled in Network and Sharing Center. There are a few ways to open Network Sharing Center, and this is the particular example here. Control.exe, and this is inside the System32 file. So I think you need to be inside this folder in order for you to be able to just run Control.exe like that. So Control.exe, name Microsoft Network Sharing Center, and then click on Change Advanced Sharing Settings, turn on Network Discovery, and the VM is a Server 2019 edition of Windows, and it's not installed by default. The feature to install on Windows Server WebDAV Director is Redirector. The feature can be installed via Server Manager using PowerShell. To install with PowerShell, we could do install Windows feature WebDAV restart. The server needs to reboot for the installation to complete. After reboot, the installation can be verified using this command. The same process as with Windows 10 client applies from this point. So make sure the web client is running, make sure network discovery is enabled, and with all the necessary components, we can access it from the web. There are two ways that the tools can be run. So run the tool from the command line as shown above, create a network drive, so on and so forth. And method 1, to run it from the command line, there it is. To run it from a mapped drive, it could be net use and then it is, and drive Y is now connected to this, and it's successfully completed. And then when we go inside our connections, we should see a network, a Y network that's attached to live SysInternals that's actually running. And now the website is browsable within the local machine. So if you just go to users administrator Y:, it'll take you into Y, and then you do dir, which is the equivalent of ls, and it'll show you what's everything in there. And now you could do procmon, and it'll start process monitor. So now that we got all of that out of the way, we can get all of these things done. So it says what service needs to be enabled on the local host to interact with SysInternals, and the name of that was web client, I believe. It's either web client or WebDAV. I think it's one of the. I think it's WebDAV, but it seems like it's web client. So let's see if it's web client. That it is. Okay, that is indeed the case. Now, before I move on, I actually do want to do all the things that they're talking about over here, because we kind of want to make sure that we have this, because it feels like we're going to be using the live environment for it. So the way that we need to do this, it started from the Windows 2019 section of the instructions. So Windows 10 client, it looks like this, and then we move forward and we need to get to the portion right here. The attached VM is Windows 2019, is not installed by default. To install it, we need to go to it can be installed via Server Manager or using PowerShell, and let's use PowerShell just to make our lives a little bit easier. And so there is PowerShell, and so we're going to do install Windows feature WebDAV redirector and restart. So you do that, and it says it's done, true, So success true, restart needed, no, exit code, no change needed. So I guess it's been done. So now we can do get windows feature web dav redirector, and then format table auto size, and that seems to be done. So it says that it's installed and everything's all good. So now the same process needs to be done with Windows 10 clients. So the thing that we did previously to get access to this on Windows 10 is to do get service web client from, I guess we need to be in System 32 because they did that. So I can go to cdc Windows System 32, and we are now there, and do get service web client, and that's been stopped. So start service web client, and now we can double check. So get service again web client, just to make sure that it's been running. Okay, very good. So it's running, and once it is running, we need to enable network discovery. And so the way that we would do that is running the control.exe, name is Microsoft Network and Sharing Center. And that should open that up for us. And it indeed does. And so from here, we need to go to change advanced settings, which is right here, and select turn on network discovery. So turn on network discovery, save changes, and that's all good as well. So since we've done all of this, this is from Windows 2019, so we did all of that, and we did all this over here. Now with all of these things out of the way, we should be able to run the SysInternals live. So let's go back to cd users administrator, and we are now here. And if I just do live.sysinternals.com tools procmon, so process monitor.exe. Oh, wait it, give it a second. I think it's gonna run. Let's see if it's actually gonna run. All right, so after several attempts to run the live version of SysInternals, and essentially just hitting block after block after block, I learned that I can't, mainly because there is one feature that keeps turning off, and I'll show you what it is, just in case if you run across it, you don't lose your mind the way that I almost did. But where is it? So we go back to this tab right here, and it's this little feature right here that is inside the network sharing center. So if we go control and then name Microsoft Network and Sharing Center, it opens this thing up, right? And then so you go here, you're supposed to go to advanced settings, and then you're supposed to turn that thing on and save changes, and it'll close it. And then you go back here, and then it's turned off again. And you turn it on again, save it, and then go back here, and it's turned off again. And so this is the issue that keeps making this whole thing not run, because when I run all of the other commands to verify whether or not things are working, so for example, get service web client, and we see that the web client is running. And I even can check to see if the Windows feature webdav is installed. So we do get Windows feature webdav redirector, and then format table auto size. And then that says, hey, this is already installed and we're all good here. So everything about this, with the exception of turning on the network discovery works and it's all good. It just, that's the reason why I can't access the live version of this, and I keep getting this error message, and it takes about 10-20 seconds for it to load, so I'm just not going to do that right now. But if you, I mean, you just saw that it won't turn on the network sharing, so that's the issue. But there is something that's been very kind of useful about this whole thing, is that we have it installed in our path directory, or in our path variable, excuse me. So if I go into the path variable, or the sysdm cpl, which opens this up for us, and then we can go into advanced, and then we go into environment variables, and then click on path and edit, we'll see that we have tools SysInternals installed, and it's on that variable. So now when I go inside the command line and I do, process monitor, for example, it opens up process monitor via the command line. So we can do it this way. If you can actually turn on network sharing and it stays on for you, then you'll be able to do it through the live environment as well. Excuse me. And you can access whatever, all the rest of the tools that exist over here for us as well. But so it's one of these things where it says you can either install it and have it be on the path, so you can use it in the command line, or you can use SysInternals live. And for the sake of the instructions and for you to actually see how to kind of type all these commands and everything like that, I'm glad I did that part, and I'm just going to leave it in the recording. But for the actual use of it, unfortunately, it doesn't run for us. And I even tried to do the net use so that I can mount it onto a drive so that we can access it like this. But unfortunately, that didn't work either. And so just so you know, as we go through the rest of this, so for example, this one, when they give us screenshots of how we're supposed to use it, they're using it on the mounted drive, and it doesn't work like that. So I hope that as we go through the rest of this, it's not going to give us any kind of issues, and we can actually run all of these commands and still do the things that we need to do. Just wanted to give you a little bit of a heads up before we went into the rest of the tasks, so that just in case you're also running across this problem, it doesn't freak you out or bug you out or anything like that. It's just so the fact that the network sharing thing, or the network discovery, excuse me, doesn't stay enabled. That's like the big issue with running it as the live SysInternals. So that being said, I am now going to close this out, and now I'm going to go into the next one, which is file and disk utilities. Okay, the first of the file and disk utilities is SigCheck, and it's a command line utility that shows file version number, timestamp information, and digital signature details, including certificate chains. It also includes an option to check a file status on VirusTotal, a site that performs automated file scanning against over 40 antivirus engines. I've done this a lot, actually. I forget in which videos, but we have several videos on the channel right now that I've used VirusTotal in, and it actually is a very, very useful website. It's a free website. You don't even need to register or anything like that. You could just go there and either search by a hash value or a name of a specific malware if you know the name, although the name changes a lot of times, so it's best to search by hash value, or maybe even an IP address. You can even search by an IP address, and then it'll show you against 40 different antivirus engines if it's shown up as any kind of a malicious or red flag, right? And an option to obviously upload for scanning. So that's the official definition that comes from Microsoft for SigCheck. And so the official SigCheck page, a use case is identified towards the bottom of the page on this page, I'm guessing. And if you completed core Windows processes, which you should have done because I just did a video on it, and I think by the time this video comes out, that video is going to be live already. So you should be aware that the location of all executables is inside Windows System 32, except for Explorer, which is inside Windows. So the use case would be like this. So checking for unsigned files in Windows System 32. The command would be sigcheck UE and then like that. And then accept EULA. Not sure exactly what that does, but it should show us what that does. So U is if virus total check is enabled, show files that are unknown by virus total or have non-zero detection, otherwise show only unsigned files. And E is scan executable images only regardless of their extension. So if the results are different, it would warrant an investigation into any listed executables. So we can go into our command prompt and real quick just run sig check except EULA. And there's a bunch of stuff right here. And so let's see what this actually says. I'm going to expand this a little bit. So this says, sig check obviously is running, which is great. And I'm guessing we're checking for signatures. That's what that kind of stands for. And so the sig check use is all of this stuff. So that's, I think, basically what this command does. The accept EULA, not sure what it does. I'm going to search through this just to see what I can find. But when you just type in sig check, it'll bring you all of the prompts of what you can and cannot do with it. And so the next one that we had was to check to see if anything inside the Windows System 32 directory there's something wrong with it, right? So if I do sig check UE and then do C Windows and System 32, we can now see that it's gonna run. It's processing all that stuff, and then hopefully it'll come back and say there's nothing, right? Which is the command right here where it says no matching files were found. So we're checking against virus total if it's been enabled, and then we're only checking executable files. And there's a lot of executable files inside System 32, which is why it's taking a little bit of a minute. But as soon as that's done, we'll verify that everything in our virtual machine is all good, and then we'll move on to the next piece, which is streams. Okay, so this thing is taking a very, very long time, this first scan of sig check. And while that's running, I'm just gonna move on to the next one because that I feel like it's gonna take a while. It's been, since I turned it on, I think it's been easily 5 minutes. We might even be pushing on the 10-minute mark. I had to stop the recording, and then I just said, you know what, I'm just gonna restart and move on to the next thing. So that's gonna take however long it takes, and until then we are going to move on to streams. The official definition of streams is the NTFS file system provides applications the ability to create alternate data streams of information. By default, all data is stored in a file's main unnamed data stream, but by using the syntax file stream, you are able to read and write two alternates. Alternate data streams, ADS, is a file attribute specific to Windows NTFS, the new technology file system. Every file has at least one data stream under the data variable, and ADS allows files to contain more than one stream of data. Natively, Window Explorer doesn't display ADS to the user. There are third-party executables that can be used to view this data, but PowerShell gives you the ability to view ADS for files. Malware writers have used ADS to hide data in an endpoint, but not all its uses are malicious. When you download a file from the internet onto an endpoint, there are identifiers written to ADS to identify that it was downloaded from the internet. So if we do streams, it'll show us the usage of it. And then there is the actual thing where it says streams, and then you just put whatever the file or directory is that you want to check, and then the accept EULA. I think it means like something use license, maybe agreement. Yeah, I think it's the something use license agreement. That might be what that is, because it's going to ask you to accept a license agreement. So this example shows that they did it against the SysInternals zip file that was on the desktop, and right here zone identifier data 185 for that. Since the file has this identifier, additional security measures are added to the properties. And so if we go to SysInternals zip file and click on properties, we will see that this file came from another computer and might be blocked to help protect this computer. And then you can unblock it if you want to by checking that unblock mark. And that's essentially it for streams. So I'm gonna run streams against the zip file on the desktop, and hopefully it won't take forever like the other one did. So let's do clear screen, and that's CLS for Windows, by the way. It's not clear, it's CLS if you want to clear it. So now I'm going to do streams, and I'm going to choose the path for the zip file. So it's going to be on the desktop, and SysInternals suite.zip, and then accept user agreement. And let's see how long that takes. Okay, thankfully that was instantaneous. So there you go. This is the zone identifier, the data variable, and it says 139, and this one was 185. So that's, I guess there's a little bit of a difference, right? So it says alternate data streams. That's basically what it's doing for us. It's searching for the alternate data streams. It's an attribute to the file. Every file has at least one data stream, which is under that variable, and ADS allows files to contain more than one stream of data. So ours is 139 on this particular one, and that's it for streams. And this whole thing is still running in the background. The sig check is still running in the background. So I will see how long that takes. You know, you're gonna watch this recording, and I'm gonna track it as I'm doing it, and then we'll see how long that actually takes to finish checking and finish running. So okay, now moving on to sdelete. Sdelete is a command line utility that takes a number of options. In any given case, it allows you to delete one or more files and or directories, or to cleanse the free space on a logical disk. That's actually very useful. As per the official documentation, sdelete secure delete implemented the Department of Defense 5220-22M clearing and sanitizing protocol. And this is the specific protocol. So it says it's a wipe method. Data sanitization method is usually implemented in the following way. Pass 1 writes a 0 and verifies the write. Pass 2 writes a 1 and verifies the write. And pass 3 writes a random character and verifies the write. The source is from LifeWire, and you're more than welcome to read on this if you wanted to look into that and read the rest of it. Sdelete has been used by adversaries and is associated with MITRE techniques T1485 for data destruction and 1070.004 for indicator removal on host file deletion. The MITRE ID is S0195, and we can view it more in detail by going to the sdelete page for SysInternals. Other tools fall under the file and disk utilities category. I encourage you to explore these at your own leisure. And so that's the doc for SysInternals downloads, file and disk utilities, and then you can see other stuff for that. But I mean, I guess we can kind of see what sdelete will do, but I don't want to run it and accidentally delete anything. So we'll just leave it as just reading this portion and understanding where it came from and what it does specifically. So that is what we'll do. Yeah, that's pretty much what we're going to do for sdelete. Now we have the question for this task. It says there's a txt file on the desktop called file.txt. Using one of the 3 discussed tools in this task, what is the text within the ADS? The text within the ADS. And so it says first use the streams command to get the name of the hidden file, streams file.txt, then use Notepad to view the contents of the hidden file, Notepad file text example, and then replace example with the name of the file you discovered when you ran streams. Okay, so first what we're going to do is we're actually going to run streams, and I think we need to be on the desktop. So I'm going to go to the administrator's desktop, I'm going to do dir, and then yeah, we have the file.txt. So I'm going to do streams and do file.txt, and so it gives us this right here. And so users administrator file.txt, reveal NTFS alternate streams, so on and so forth. And it says, I mean, data 26, that's basically all it says. So unless I am mistaken, so the command is streams file.txt, then use Notepad to view the contents, file.txt example, replace example with the name of the file you discovered when you ran streams. and there is no, oh, maybe it's ads.txt. I think that's what that is. It's, let me zoom in right here. I think ads.txt is the name of the file that we discovered. And so if we go back to this other one that we ran up here, there's zone identifier that is attached to the SysInternals suite zip file. So that's probably how we read this, is that that's what's been attached to the data variable. And so in this case, ads.txt was attached to the data variable for that. And so the command again is notepad file.txt and then colon ads.txt. So notepad file.txt colon ads.txt, and that's going to open it for us. And here it is. This is actually very cool. This is useful. So it says, I am hiding in the stream. And so let me see if I could just copy this and paste it here. And there it is. We got our answer. That was actually very cool. I like that. I like the fact that we can find things in the data stream. It's like we're becoming full-fledged analysts here. How crazy is this? Okay, so that was it for the file and disk utilities. And now we're going to move into networking utilities. TCP View is our first networking utility. Based on the official definition, it's a Windows program that will show you detailed listings of all TCP and UDP endpoints on your system, including the local and remote addresses and state of TCP connections. On Windows Server 2008, Vista, and XP, TCP View also reports the name of the process that owns the endpoint. It provides a more informative and conveniently presented subset of the NetStat program that ships with Windows, and the download includes TCP vcon, a command line version of that basically does the same thing on command line. So this is a good time to mention that Windows has a built-in utility that provides the same functionality. It's called Resource Monitor. There are many ways to open this tool. From the command line, we could just use resmon and it'll open up Resource Monitor, and it looks like this. The expand TCP connections to view the remote address for each process with an outbound connection. And so that would be done under TCP connections for where? So I guess it's under view, right? Let's see. Process with network. Oh, you know what? It might actually be under this thing. So I'll run it in a little bit and then we'll actually get some stuff. So this tool can be called from the Performance tab within Task Manager. Look at the bottom left for the link to open Resource Monitor. So we could always do that. And that's under Task Manager. We did Task Manager in the core Windows processes video, so you can go learn much more about that. It's actually a very cool tool. It's not just to do Control-Alt-Delete and to force things to close. So now back to TCP View. So we do that, and this is the TCP View GUI, the graphical user interface, and we can apply additional filtering by turning off TCP4, V6, UDP4, V6 at the top toolbar, depending on which protocols we want to display, which is these things right here. We can also click on the green flag to use states filter, which is also very cool. Opens the states filter, which provides an extensive list of options to select which connection we want to display. Most of the connection states available apply to only TCP connections. UDP, being a connectionless protocol, cannot offer this flexibility. The list below shows all TCP v4 and v6 connections in any state except the listen state. For instance, we notice that we have one connection in an established state and another in a close wait state. In the below image, they unselected the listen and connection states from the states filter and turned off UDP v4 and v6, and this is what the output was. Now the output only displays processes with an established outbound connection. Other tools fall under networking utilities, and they encourage us to follow it. So using Whois tools, what is the ISP organization for the remote address in the screenshots above? So let's see what we can do. This is the screenshots above, and specifically, I mean, there's a few of the IP addresses, but we can just use the 52.154 right there. And is there any other IP address that we can use? No, that's pretty much it. So 52.154, 52.242. So there's two of them, and we can try to see what we can find over here. But we could just use whois and use the first IP address, which is the bulk of the IP addresses over here, and we can see even what the hint tells us to do. So it says you can use a website like whois to get the organization name. Unfortunately, the answer provided by Talos Intelligence is different and won't be accepted, although it is also correct. So I guess I could just do this. Since I can use this, I'm literally just going to open it up in my own browser, and we're going to look for 52, 154, 170, 73. 52, 154, 170, 73. By the way, it literally just started pouring rain. I don't know if the thunder came through. I don't know if the sound of the thunder came through, but that was gnarly. And now it's literally pouring rain. So I hope that it doesn't increase too much background noise, but if it does, I apologize in advance. So let's see, it says, what is the name of the ISP organization for the remote address? So ISP organization is Microsoft Corporation MSFT. That might not be it, or maybe it is. Maybe I just need to remove the MSFP. So boom, boom, and there it is. We got the right answer for this. We can always actually do TCP view just to open it up, just to test it out. So let's do TCP view. And of course, accept the user license agreement. And there it is. There's TCP view. We got all these things, and we can turn off UDP v4, v6, and then what else did they turn off? So we can get hopefully the same result or a similar result. They did, what is it? In the image below, I unselected listen in the connection states and turned off UDP v4 and v6. So we're going to go here, unselected listen, and it's right there, and do OK. And we only got one. We only got one IP address. So they got way more than that. But that's it. That's it for TCP view that was inside the networking utilities task. And it's actually only one. So now we can move on to the next one, which is process utilities. All right, process utilities. The first one is auto runs. Some of these require us to run as an administrator, so I will restart the command prompt as an admin. So auto runs, the official definition is this utility which has the most comprehensive knowledge of auto starting locations of any startup monitor, shows you what programs are configured to run during system boot up or login. And when you start various built-in Windows applications like Internet Explorer, media players, these programs and drivers include ones in your startup folder, run once, and other registry keys, auto runs reports, Explorer shells extension, toolbars, browser help objects, yada yada yada. So it has anything to do with auto runs and running things, I guess. So this is a good tool to search for any malicious entries created in the local machine to establish persistence. That's always good, because as a hacker, we want to be establishing persistence, but as a security analyst, you want to make sure that you catch all that stuff and kick them out. So below is a snapshot of auto runs showing the first couple of items from the Everything tab. And so there's a lot of tabs, as you can see right here. Normally, there are a lot of entries in this tab because it's everything. All the tabs within the application. Click on each tab to inspect the items associated with each. The below image is a snapshot of the Image Hijacks tab. And there's only one item under Image Hijacks. That doesn't sound good. There shouldn't even be one item, I feel like, right? And so that's it before we move on to the next one. So I am going to check that out, actually. So let's see if we can run this with the current command line. So auto runs. Yep, okay, it works. And so what do we got here? We got three things. So app init, WMI, and Office. Those things are auto runs. Let's see if we can find that. What is it? In Image Hijacks? Where's that? Right here. Image Hijacks. And there's nothing here. That's good. Going back to everything, something else just came in. Internet Explorer, boot, execute, app init, WMI, and Office. Very interesting. Okay, good to know. There's a lot of other things in here too, right? So we could app init, that's one of the things that was listed. And there isn't anything that auto runs under that. There's drivers. There's nothing under here. What else do we got that might be interesting? When log on. So, I mean, it's a virtual machine, so I really don't expect much to be in here. But this is one of those tools that's actually very, very useful. It sounds really useful. So I can imagine that it might be. Oh, and it's going to take a minute to cancel. Goodness gracious. Let's see. Let's see, we can go immediately to our task manager right there. And from there, we can choose the auto runs, probably. Is it here? This is all the stuff. And I don't want to see all the stuff. I want to see just the ones that are running right now. So let's see if we can do auto runs. This is going by PID. I want to go by process name and go to auto runs. And I want to force quit. There has to be a force quit for this thing. Kill process. There we go. Yes, I want to kill that. There you go. Task manager is very sweet. I love that thing. Okay. That was auto runs. Let's now go into proc dump, which sounds like process dump. So let's see what that does. Official definition of proc dump is that it's a command line utility whose primary purpose is monitoring an application for CPU spikes and generating crash dumps during a spike that an administrator or developer can use to determine the cause of the spike. So proc dump, we run it, and it looks like this. So monitors a process and writes a dump file when the process exceeds the specific or specified criteria or it has an exception. So alternatively, you can use the Process Explorer to do the same and right-click on the process to create a mini dump or full dump of the process. For some reason, I really love saying dump right now. And so we can right-click on the process in Process Explorer, create a dump, create a mini dump or a full dump, a dump truck. Please refer to the example listed on the proc dump page to learn about all the very available options with running this tool. Oh wow, there you go. That is thunder and lightning in the background. That was pretty gnarly. Okay, so what I'm going to do is I'm just going to run this real quick because I want to see what it looks like inside the command line. And there's that. And so it seems like it didn't. Oh, you know what? Because I need to actually choose something. So it just told us what the use case for this is. And there's a lot of different use cases. So it just told us what it is, which is basically the description that they showed at the top right here as well. So from here, we can go to what? They said Process Explorer. And from Process Explorer, we could probably create a little dump. So let me see. Process Hackers right here. Process Explorer. Let's see. Oh, you know what? Process Explorer should actually be inside this suite. So if I go to File Explorer, and inside that, there should be SysInternals suite, and then there should be something called Process Explorer right here. Yep, ProcExp. So ProcExp, run that. It should open up Process Explorer for us, and then from that, we should be able to right-click on something and create a dump. I thoroughly enjoy saying that. Probably enjoy too much saying that freaking thing, but it is what it is. I don't know. Judge me all you want. I don't care. I just like saying it. And so here we go. We got Process Explorer. There is a process here called Amazon SSM. And then we can go create dump and a mini dump or a full dump. That's all I wanted to see. That's all I wanted to see. That's it. Okay, so proc dump. That is it for proc dump. Now moving on to Process Explorer. I shouldn't have even closed it. It was literally right there. But okay, we are now moving into Process Explorer. All right, so since it took a second for it to start, I'm gonna do Process Explorer in the command line. Well, that was actually really fast compared to the last one. So Process Explorer was also one of the things that we did in the core processes video. So if you've seen that, then you should be very familiar with this. So it displays two sub-windows. The top window always shows a list of the currently active processes, whereas the information in the bottom window depends on the mode that the process is in. If it's in handle mode, you'll see the handles that the process selected. If it's in DLL mode, you'll see the DLLs and memory mapped files. And so we can just run that and it'll open up. Was touched on slightly with the core Windows processing room. Yep, it was. Process Hacker was intentionally used in that room to broaden your exposure to various tools. And since much of the basic foundation information was discussed in core Windows, will be briefly touched here. So in the following images, we'll look at the SVC host 3636 more closely, which is this thing right here. And there would be multiple instances of that, as you will see from the core Windows processes video. It can have multiple instances. So let's see, so this is what it looks like if we open up the properties of it. And so we have, for that particular example, it's using a web client service. It's associated with the web client that is needed to connect to live SysInternals. There should be a web traffic listed in the TCP/IP tab. Since we can't do live SysInternals and we're using the command line, this is not going to apply to us. It would be wise to check if the IP is what we actually assume it is, and that's the IP that we actually ran the who is query against. Various online tools can be utilized to verify the authenticity of an IP address. For this demonstration, we're going to use Talos, which I've also done a video on for the cyber threat intelligence video, excuse me. And we went into Talos, and that's also, very, very powerful tool, very useful, and it's on talosintelligence.com. As mentioned in the description, we can see that open handle is associated with process in the bottom window, which is all of these things right here. And as an open handle in the connection to the remote web app folder, there's an option with procxp to verify signatures. So verify signer right here. Once enabled, it shows up as a column with the process view, and other options include run at logon, replace task manager. You may have noticed that some of the processes within the Process Explorer have different colors. They have meaning. So this is the color coding. And I'm not going to read through all of this right now. You are more than welcome to pause it and read through this if you want. And then the next one is going to be Process Monitor. So that's what it is for Process Explorer. Let me zoom back out real quick. And then if we click on something, so kind of bring this up a little bit so we could see it, right? If we click on something, we can see the base, so con host or CSRSS. That was one that we covered inside the core processes video. We'll see the keys associated with it, the process associated with it specifically, and you can even click on something like it. So if we click on, and I can actually go to the SVC host. We could use one of these things and go on the properties of this, and there's nothing in TCP/IP for this. The image is exactly what it's supposed to look like, and it's in the Windows System 32 and all of that good-ish. So we didn't use this much, or I guess we're not covering it much because of the fact that we talked about it in the core processes video, but this is something that very much could just replace Task Manager, as they said, because if you just saw, I used the Task Manager to kill one of the things that we were working on, so you could do the same thing. So you could go here and you could literally kill that process. So this could replace the Task Manager if you wanted it to. Other options to note right here: run at logon and replace Task Manager. So all of those things can be applied to the Process Explorer. Process Monitor is an advanced monitoring tool for Windows that shows real-time file system registry and process thread activity. It combines the features of two legacy SysInternal utilities, File Monitor and Registry Monitor, and adds an extensive list of enhancements including rich and non-destructive filtering, comprehensive event properties such as the session IDs, usernames, reliable process information, full thread stacks with integrated symbol support for each, simultaneous logging to a file, and a lot more. Its powerful features will make Process Monitor a core utility in your system, troubleshooting and malware hunting toolkit. So to launch it, we're just going to run procmon, and this is what it would look like. So it says, let's see, I set a filter to capture all the events related to PID 3888, which is Notepad. You can see some of the file operations that were captured in the file path or registry that it occurred on and the operation result, right? So that's that, and I want to kind of run that just to see how you can do that. I will capture thousands upon thousands of events occurring within the operating system. The option to capture events can be toggled on and off, which is this thing. And in this procmon example, the session captured events only for a few seconds. Look at how many events were captured in that short space of time. 799,000 events. That's crazy. So to use procmon effectively, you must use the filter and must configure it properly. And so this is the process monitor filter. The process name is Notepad, and then include the PID, which is for that process specifically, and then apply, and that's what they got from the previous results, right? So if filter was already set to capture events associated with this. Alternatively, a filter could have been set to capture events with the process name Notepad. Here's a useful guide on configuring procmon. To fully understand the output from some of these tools, you need to understand some Windows concepts such as processes and threads and Windows API calls, which I have not done those rooms. I wonder if these are rooms. No, these are just articles that go to Microsoft. So I do want to open this. Oh, let me extend my machine timer so it doesn't die on me. And what was it? It was procmon, right? That's how we run it. And it opens this up right here. Very cool. And so here are our filters. This is the filter. So for example, process name is, and then we can do notepad.exe. You did not add the item you were editing. Add it now. Wait, hold on. Cancel. And then PID 3888. Now add it. Okay, apply. Nothing. I guess we can also do capture events real quick. And let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then turn that off. And the current filter includes 98,000 events. Wait, is it still running? Okay, now it's stopped. Okay, very good. So 99,404 events with the current filter, but it doesn't show me anything. So that's really annoying. Let's click on the filter again, and I just want to see something. Can I see this? Yeah, it's not going to show me anything. Okay, well, whatever. At least now we know how to open it and kind of how to use filters and capture events. So it will, to learn this further, we would need to go ahead and study more up on this, I feel like, because this seems like this is a very, very short introduction to all of these things, including the rest of the stuff that we just saw. So it's like it's not, yeah, not much has been shown here, and it's still capturing events. Oh my god. So let me stop capturing events. Very good. But show me the events at least. I want to see the events. This is what's annoying here, is that it didn't show me that stuff. So whatever. Either way, at the very least we got that. And in the interest of time, I'm not going to spend too much time on this. So if you figured out how to do this, and if you were able to actually see some results in your specific task when you were running this, then please tell me. because I'm very interested in seeing some kind of a result from this. This is kind of annoying that this did not happen here. But it's neither here nor there, because we must move on. The show must go on, as they say. Okay, so we are now going from process monitor to PS exec, and we've used PS exec for a lot of pen testing exercises. So let's look at it from the security analyst perspective. PS exec is a lightweight telnet replacement that lets you execute processes on other systems, complete with full interactivity for console applications without having to manually install client software. The most powerful uses include launching interactive command prompts on remote systems. That's why we used it in pen testing so often. And remote enabling tools like ipconfig that otherwise do not have the ability to show information about remote systems. And so if we run it, psexec, I guess this particular thing, the output just from what it shows right here is that it's just showing us what we can do with it, and I'm sure there's going to be several options. It's utilized by adversaries, yes it is, and we've done a lot of stuff with that. It's associated with the MITRE techniques T1570, lateral tool transfer, T1021 002, remote services T1569 002, and the MITRE ID for it is S0029. You can review this tool more in depth by visiting the SysInternals PSExec page. You can also check out this resource page. Other tools fall under process utilities category. Obviously there's a lot of stuff, but this is just a handful of them. And if I just run psexec just as a command so we can see what it shows us from the analyst side, because I've ran this under the hacker side plenty of times. This is kind of what we get over here. So these are just all the commands that are available, and the machine expired, which is annoying because I did extend the time. You saw me extend the time, so that's very annoying. I might have to restart this whole thing and kind of just run from, or pick up where we left off basically. So run auto runs and inspect what are the new entries in the image hijacks tab compared to the screenshots above. What entry was updated? So auto runs we did run, and there was nothing inside the image hijacks as far as what I saw. So if we run auto runs, and then so let's review it one more time. We can run it. First couple of items from the everything tab. Normally there's a bunch of stuff here. Each tab to inspect. Below is a screenshot of image hijacks. At this time there's only one item listed, which was the shell open command for Internet Explorer. And I mean that's pretty much it. So I'm gonna run auto runs one more time just so we can try to see if we can get any of that answer. So auto runs, there it is. We're gonna let it kind of load for a second. I guess maybe I didn't give it enough time for it to load, because I do remember that under the everything tab there was a bunch of stuff that did load. So we are going to see which entry was updated, and it's going to be under the image hijacks, and let's see what that does. I'm going to give it a couple of seconds to load, because there has to be something here. If they're asking us a question about it, there needs to be something that loads here. So we're going to give it a couple of seconds to load. And this was actually the one that we also had to, or I manually used Task Manager to end the process for, which means that it was probably still running, it was still operating, and there was there it is, finally. Okay, so it was running. That's why when I tried to close it, it took such a long time to close. So it says which entry was updated compared to the stuff that was up here, and the only thing that they show us here is Internet Explorer. So the answer can only be Internet Explorer, but there is several things. There's Task Manager, that's been here twice, and then we have iexplore.exe. So it says, what is the question? It says which one? What is it? Which entry was updated? Okay, so let's try this. iexplore.exe. Okay, that's not the answer. So task manager would be the only one. Maybe that's what they mean. It's like which entry was added. Maybe that's what they mean. Because updated means that it was an old entry that now has been updated. That's how I would decipher it. But it is saying which one was added, I guess. So which is task manager. And now it says, what is the updated value of task manager? So we go here, and the value seems to be this right here. So let's copy that and see if that is indeed it. And that is indeed it. So this is it right here. When you click on it, it populates down here. But I think there's probably, if we just kind of shrink this down, there's probably going to be something else under, under all of these things. Or we can just scroll down. And no, it's not down there. Oh, image path might be the value that they're referring to because it's the same answer. It just doesn't say, sometimes it says value as the actual column name, but in this particular case, it is image path that you're looking for, or you just click on it and it will be right down here as well. So that is it for auto runs, and that is it for the questions of this particular task, which was our process utilities task. So now we're going to move on to security utilities, but before that, I'm just going to refresh the page and hope that the machine that we're on didn't actually end and we don't have to restart it. So in either case, when you see this, everything's going to be all good, and we're going to be reading into security utilities next. All right, SysMon, also known as System Monitor, is a Windows system service and device driver that once installed on a system remains resident across system reboots to monitor and log system activity on the events log. It provides detailed information about process creations, network connections, and changes to file creation time by collecting the events it generates using the event collection or SIM agents, and subsequently analyzing them. You can identify malicious or anomalous activity and understand how intruders and malware operate on your network. And SysMon, System Monitor, is a comprehensive tool, and it can't be summarized in just one section. I don't think any of these things can be summarized in just one section, but there is a specific room for it, which is, let's see, I don't think I've done this. No, I haven't done it. So that's probably next in the pathway. Honestly, I feel like that's one of the big ones that we have to learn how to do, especially since we're going to be combining it with, event collection or SIM agents, just to try to find malicious activity and stuff like that. So there's a lot of other stuff that probably falls under security utilities, and this is just the scratch of the surface. So that is it for the security utilities task and system monitor. We are now going to jump into system information. WinObj, this is a very weird thing. I'm guessing it's Windows object, but WinObj is a 32-bit Windows NT program that uses the native Windows API provided by NTDLL DLL to access and display information on the NT Object Manager namespace. To showcase this tool, let's look into the concept of session 0 and session 1 that was mentioned in core Windows. So session 0 represents the system, session 1 represents the user. That session is the OS session, there you go, and session 1 is the user session. Also recall that there will be at least 2 CSRSS processes running, one for each session. Session 1 will be for the first user logged into the system. And so the below image shows the default view for WinObj. With session 0, within session 0, under DOS services, right here probably, there's an entry for the network drive I mounted in my local machine, which we don't have because we weren't able to do this, because we weren't able to do the live SysInternals, right? So if we look at the Windows Station value for session 1, it will be Windows Station 0. We can compare this with the Process Explorer, the below image for CSRSS which was launched along with WinLog on and SMSS. And so that's what that looks like. This is a high level exposure for this tool. Obviously, there's other things on this thing, obviously. And so we can try to see what this would look like for us, right? So I think I might be able to close auto runs for now, and I can clear the screen, and I will do winobj accept EULA, and this will open up here. And so what they talked about is that what? So within session 0 under DOS services. So we have sessions right here, and there should be more than one session. So session 0, which is Windows, is that yeah, so that's an individual item. So that's within session 0. Let's expand this a little bit if we can, and shrink this a little bit if we can. Symbolic link, and it's at Windows. We have session 1, which is us, the user, and it seems to be nothing in there. And there's session 2. That's odd. Session 1, there we go. Session 0, expand that a little bit. App container named objects, nothing in there. This is in here. There we go. Okay, good stuff. So now there's other things in here, and then RPC control is empty. So we have the local symbolic link, session global, and this is all under session 0. And then if we go to session 1 here, and app container named objects, we have this as well, and same thing. So nothing that, I mean, I don't know what I'm looking at, or I don't know what to look for. There's the DOS devices. There we go. That's what it was. So DOS devices is what they're referring to. And let's zoom out here. And so they said within session 0 under DOS devices, there's an entry for the network drive. So since we didn't have that, I guess it doesn't really apply to us. But these are all the DOS devices, and it all says the same. Everything over here is listed as the same. So that doesn't really apply to us. Under DOS devices of session 1, there's nothing there because it's not the OS itself, it's me as the user. And then there's base name objects that has, ooh, wow, look at that. There's a bunch of stuff here. Most of this stuff we're not going to analyze right now, but so these are Windows objects, right? So that's basically what we're looking at here. And that is pretty much it for Windows objects. So yeah, there you go. So that's it. This is the system information task, and very much an overview. I mean, most of these things we're barely doing even what could be considered a decent overview. They're just mentioning that these things exist. And I'm only guessing that they're saying this because there's going to be rooms about these things that we're going to look at later. So this is kind of a high level, super high level overview of all of these things. So now from here, we're going to go into the final category, which is the miscellaneous category. And I can only imagine how many things are going to be in there. So let's jump into it, and we're going to wrap the room. BG Info, it displays the relevant information about a Windows computer on a desktop's background, such as the computer name, IP address, service pack version, and more. And so this is a handy utility if you manage multiple machines. This tool or similar tools are typically utilized on servers. When a user RDPs into a server, the system information is displayed on the wallpaper to provide quick information about the server, such as the server's name. And so this would be a BG Info screen from what it looks like. And it has the boot time, the CPU, default gateway, so on and so forth. These are all the different fields that are available to it, and refer to the SysInternals BG Info page. So let's run it, and let's actually see what we can kind of discover real quick. Because, of course, this is going to be, whoops, I may have mistyped that. Accept EULA. There we go. And so here it is. This is BG Info. And as the other screenshot, it's basically identical to this other screenshot. And I can't click on anything. Maybe I can click on it over here. So if I double click this, oh, it added it. So now I have another CPU that I just added right here. I see, oh, I see what this is. I see what this is. Okay, so this is for, yeah, I understand. So just input it right here. So now I can, yeah, I can delete it because this is basically all text. So instead of writing all of these things manually, you could literally just go here, press enter, and say network card add. There you go. And subnet mask add. There you go. So these things are all manageable via a couple of clicks, which actually does make it pretty easy to kind of do right here. So if you're doing a lot of virtual machine setups or machine setups and you're on the main server, this is kind of how you would do it. And then we would click apply, and then it would apply these things. Although I feel like these are temporary placeholders, so you may need to put this in somewhere. And I mean, now I'm guessing because we have to do more research on this to be able to officially understand what the hell this thing actually does. And I do not want to save those changes. But so that's BG info, and it's handy if we want to manage multiple machines. And there's a lot of stuff that can probably be done with this to either virtualize or manage other machines and computers, so on and so forth. So that was it for BG info, and now we're going to go to reg dump, registry dump, jump, excuse me. I keep saying dump because I'm excited about it. But jump, so registry jump. This little command line applet takes a registry path and makes registry edit, open to that path. It accepts root keys in standard, H key local machine, and abbreviated form HKLM local machine. And that's all they give us. When navigating through the registry using registry editor, one must manually drill down the key that you wish to inspect, but you can also just type it at the top right here, so you don't need to one by one click any of these things and go down. So there are multiple ways to query the Windows registry without using the registry editor, such as via command line reg query, registry query, and PowerShell get item property. Using reg jump will open the registry editor and automatically open the editor directly at the path, so one doesn't need to navigate it manually. Okay, so reg jump, and this is what the usage would be. So if I did reg jump HKLM yada yada yada, it would just open it up to the path, which again, I feel like in this particular case, it's much easier to do it here because you can it gives you autofill. So I'll do it right here just so you can kind of see what this does. So I'm actually going to, is it available on the desktop here? It's not. So I'm going to search for it real quick just so we can kind of see registry editor, and it'll open it up for us right here. And then if we go to the search bar, or the I guess it's called the search bar, but it's like this browser right here. So if I go to this browser, and so we're just going to go very, very high up here, and we'll click on local machine, and you see how there's this path right there, right? And you can even start at computer, but let's say local machine or current user, let's say. So let's say current user, and you know that you want to go into the console, or even if you don't, if I just do that backslash, now you see how there's all these things that have shown up right here. So I can do console, and then I do another backslash, and it gives me everything else about it. So I can do, system root, but then it's already filled in for me, right? So that might be another, like app events, maybe. We can do app events and then backslash, and then schemes, and then backslash, and then apps, backslash, and then explorer, probably backslash with that too. Look at that. So this way you don't have to actually manually click and search through all this. What they're talking about with the registry editor, which if you know where you're trying to go, is useful. I'm not going to say that it's not useful, but more often than not, especially if you're like new to this kind of stuff, you're not going to know where you're trying to go. It's almost impossible. Like, you need to use the registry editor to find these things. But if I went and did reg jump, so if I want to do registry jump HK local machine, and then I want to do system and current control set, so that's basically what they said, services and web client, and then accept EULA, and so it would open it up for me. Look at that, fancy. Okay, that's great, that's awesome, but I would need to kind of figure this out. I would need to know where I'm trying to go, or at least what that registry is, to be able to jump to it. So it's useful, sure. I'm not going to say that it's not useful, especially if you're doing advanced cases and you are super experienced with the machine and the server, and you know where everything is and what you're doing and all that stuff. I completely understand. I'm not going to knock it in any way. I just think that for somebody who's a beginner or kind of entry level into this type of stuff, you need to be able to see where you're going before you can search for it. And that's just my opinion. You don't have to take my opinion. Obviously, you could say I don't know what the fuck I'm talking about, and you would probably be right. So that's neither here nor there. But that's pretty much it for reg jump or registry jump, reg jump, whatever it is. And now we can move into strings. And there's a little question at the bottom here for strings for us too. So let's go into strings. Strings just scans the file you pass it for Unicode or ASCII strings of a default length of 3 or more Unicode or AC characters. Note that it works under Windows 95 as well. Look at that. This is the tool that was used on day 21 of AOC to inspect a mysterious binary. Oh, you know what? Advance of Cyber 2. I don't know if that was the one that they just did, or Advent of Cyber, whatever it was, but they did something for Christmas at the end of 2023. And I want to say, I don't think this was it. I don't know if it was Advent of Cyber 2. I feel like it was a little bit more advanced of a room than that. But it's cool to know that they've used this previously before. Actually, no, it was that one, because I do remember using strings to inspect a mysterious binary. So the example below strings is used to search within the zoomit binary for any string containing the word zoom. And so the question that they have to ask us right here, it says, what is the full path to the .pdb file? And so find string I zoom. So I guess I'm going to do find string, and then I'm going to do asterisk or asterisk.pdb. I think that's what I'm probably going to search for. So let's zoom out of this real quick. Can you zoom out or no? There we go. And so what we're going to do is we're going to go into the tools SysInternal first. And here we are. And now we're going to do strings.zoomit.exe, and we're going to find the string that has anything to do with, I'm just going to put it in quotes, asterisk pdb, and enter. And that does not show anything, so we'll do it without the quotes. And that doesn't give me anything either. So that's kind of annoying. So let's see what we can do. Maybe we'll remove the asterisk at the very end and see if that works. Okay, didn't have to do the asterisk, I guess, whatever. So it says, what is the full path to the PDB file? So being that we only search for zoomit, I'm just going to take this one. And I can't, oh, I see, I can't copy it because it's command line. That's also very annoying about Windows command line. In Linux, you can copy anything by right-clicking. And I don't want to accidentally do Control-C and have it do something funky because, well, I guess it's not a, whatever. We're just going to type it, who cares? Agent. And there it is. So lovely for us to be able to use strings to find something within something. That is pretty useful, honestly, I'm not gonna lie. And as we go through more applicable or practical cases, we will get to see what the use case for a lot of these things are. So that was it for the last individual item under our miscellaneous task, and now we can jump into the conclusion of this. In conclusion, when you read the documentation of SysInternals, it might hint these tools are for troubleshooting purposes, but that is not entirely the case. You should be familiar or know that SysInternal tools, whether you're a desktop engineer, system analyst, or security engineer, real world scenario, as a security engineer, the person who wrote this room had to work with vendors to troubleshoot why an agent wasn't responding on an endpoint. The tools used were Process Explorer, Process Monitor, and Proc Dump. So Process Explorer to inspect the agent processes, its properties, and associated threads and handles. Process Monitor to investigate if there were any indicators on why the agent was not operating as it should. And Process Dump to create a dump of the agent process to send to the vendor for further analysis. And guess what? Asking questions about SysInternals became part of the interview questions when hiring additional staff. So remember, red teamers and adversaries even use these tools. Below are some additional links. So there's Mark's blog, Mark being the CTO of Microsoft, Windows blog archive, License to Kill, malware hunting with SysInternals. It's a YouTube video, and malware hunting with Mark Rusinovich and the tools, and that's another YouTube video. I am actually very interested in running all of those things, and I would highly recommend you go through those as well. Some of the videos, blogs are a bit outdated, but they're still good to review as it showcases how these things are used extensively. This will build your foundation on the tools that have been covered. So we are now wrapped with SysInternals, and that was very, very useful to know, honestly, even though it was an overview. This thing is still running. So the sig check on Windows System 32, all the executables, is still freaking running. Maybe it's not working because that initial option for the network thing that we had to do to set up SysInternals live, the network discovery. Maybe it's because that's not available, that it's not working. Or it's taking so long to do, but whatever. Or it could just be that the machine that we're on is super slow because it is a virtual machine, and TryHackMe has to limit how much CPU, or not CPU, how much RAM these things use because they have many, many students. But apart from that, everything else worked, and we were able to learn some good information. So I hope you learned some really good information from this, and I highly recommend that you go through all of the extra reading materials and learning materials that they recommended as well. Alright, so if you found anything useful from this video, if you learned anything from this video, or if you were merely entertained and you just had an entry to this SysInternals suite, whatever the case may be, if you got any value from it in any way, I would humbly and kindly, sincerely appreciate it if you could give us a like, a follow, or subscribe, I guess, since we're on YouTube. Turn on that notification bell, and of course drop a comment, because all of those activities actually help the YouTube algorithm give us more reach and find us and kind of expand our reach so that we can grow the community and so on and so forth. And honestly, I would very much love it if you were a part of the community as well. And I drop videos like this at least once a day, so you will be getting good content, and you will learn a lot about cybersecurity and network security, system security, of course, ethical hacking, because that's the fun part of all these things. And yeah, it would just be an honor to have you be a part of our community, to be a part of our channel. So that's all I'm going to say about that. It's your boy Hank Hackerson at Hank Hacks Hackers, and your favorite network and system attacker. If no one else loves you, Hank loves you. I hope you enjoyed this video, and I hope you learned a lot from it. Peace, love, and chicken grease. I will see you in the next video. Peace. Alright, hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite system and network attacker. And today we are going through the Windows Event Logs module inside of the SOC Level 1 pathway of TryHackMe. And this is inside the Endpoint Security Monitoring module. I guess we're going through the SysInternals room inside the Endpoint Security Monitoring module of the SOC Level 1 pathway. Real quick before we jump into the content of the room, I just wanted to kindly and humbly request that if you've learned anything from me, if you've learned anything from this channel, if you learn anything from this video, if you enjoy it at all, and you want to show your support, it would mean the world to me if you could like, subscribe, and turn on the notification bell, and maybe even comment, because all of those activities increase the likelihood that the YouTube algorithm will find the channel and we'll get more reach and we can expand and grow the community. That's the only thing that I ask. I do all these videos for free, sometimes multiple times per day, but at least once a day. And it would just mean the world to me if you could support by liking, subscribing, and commenting, and even turning on the notification bell, because you will get notified the next time that a video comes out. And if you're starting to become a cybersecurity analyst, or if you're starting to become an ethical hacker, all of these posts and all of these videos will apply to you directly, and you'll get a lot of good value from it. That is my promise to you. Now, without further ado, let's jump into the first task of the room. Okay, so what are event logs? This is a Wikipedia definition, and I mean, you can kind of just tell from the name itself what it might be. But event logs record events taking place in the execution of a system to provide an audit trail that can be used to understand the activity of the system and to diagnose problems. They are essential to understand the activities of complex systems, particularly in applications that have little user interaction, such as servers, right? This definition would apply to system administrators, IT techs, desktop engineers, cybersecurity analysts, right? If the endpoint is experiencing an issue, the event logs can be queried to see clues about what led to the problem. The operating system by default writes messages to these logs. As defenders, blue teamers, there is another use case for event logs. Combining log file entries from multiple sources can also be useful. This approach, in combination with statistical analysis, may yield correlations between seemingly unrelated events on different servers. This is where SIEMs, security information and event management, such as Splunk and Elastic, come into play. These are applications or softwares, we can call them appliances. They essentially process logs, right? So if you don't know anything what a SIEM is used for, this is kind of the visual. So the main features is that it helps with detecting threats, investigating, and time to respond. So the response time is a lot shorter because it actually parses and goes through a lot of these logs for you. And when it detects something, it'll pop up a notification. It'll say, hey, something might be wrong. So additional features would be basic security monitoring, advanced threat detection, forensics and incident response, log collection, so on and so forth. So SIEMs are very, very popular in the cybersecurity world, especially as a security analyst. And even though accessing the remote machine's event logs is possible, it will not be feasible in a large environment. Instead, one can view the logs from all of the endpoints, appliances, and everything inside a SIEM. And this will allow you to query the logs from multiple devices instead of manually connecting to a single device. So Windows is not the only operating system that uses a logging system. Of course, Linux and Mac OS do it as well, and probably every other operating system. And on Linux, it's known as syslog. In this room, we're going to be focusing on Windows, so it's going to be Windows event logs. The room machine has already been started. If you are using this room and you want to RDP into it, meaning remote desktop into it, you can go ahead and do that. It says, please deploy the machine, and also you can use the attack box and Remina to connect to the remote machine. Please make sure that it's deployed before proceeding. So I don't think I need to start the attack box because the machine itself started, so we can kind of continue from here, and hopefully we won't need to use the attack box. If we do, I'll just start it up, no big deal. So let's jump into the next one, which is event viewer. All right, event viewer. The event logs are not text files that can be viewed using a text editor. However, the raw data can be translated into XML using the Windows API. The events in these logs are stored in a proprietary binary format with EVT/EVTX extension. The log files with the EVTX file extension typically reside inside the WinEVT logs directory. Elements of a Windows event log are going to be the system logs, security logs. I'm sorry. These are what elements form event logs in Windows systems. So there's a lot of different elements that can form different event logs. So we have the system logs that associate with the actual operating system. You have security logs that record anything that might be log on and off activities, or anything that might go against the audit security policies or compliance issues, stuff like that. There's application logs that have to do with specific applications installed on a system. Directory service events that has to do with the Active Directory activities and changes. And of course, file replication service events. So if something was done during the sharing of group policies or logon scripts from where they could be accessed by users through the client. Then DNS event logs for the domain name service. DNS servers use these logs to record domain events. And then there's custom logs that you can even create or try to start logging by using your own parameters. So they're logged by applications that require custom data storage. This allows applications to control the log size or attach other parameters such as access control lists and other things. So under this categorization, event logs can even go into further classification into types. And there are types that describe the activity in the event log, and there are 5 types. So there's an error, a warning, information, success audit, and failed audit. So an error is basically an event that indicates that there was a such loss of data or loss of functionality if a service fails to load. Warning is an event that is not necessarily significant, but may indicate a possible future problem. If a disk space is low, there's a warning event. Information, an event that describes the successful operation of an application, for example, when a network driver loads successfully. Success audit, so when you run an audit and it does complete successfully, you get that. So a user's successful attempt to log on to the system. And failure audit is when an audit security access attempt that fails. For example, if a user tries to access a drive and it fails. You can do this, you can view these things in 3 different ways. We have the event viewer, the WEVT util, and then we have the get win event. That's a PowerShell. So WEVT util is command line, event viewer is a GUI, and PowerShell gets get win event. And we have our event viewer right here that has 3 panes. And probably at this point we can start this up. So if I go into the start section right here and do a little bit of a search right here, I can open up event viewer and we can actually look at it on this machine that we're on. And there we go, desktop app, and there it is. So as it says right here, there's the pane on the left, which is the hierarchical tree of listings of event logs that are provided. The pane in the middle is the general overview of the summary, and then the pane on the right is the actions pane and the things that we can do, the actions that we can take. This is still kind of loading, but that's basically what the event viewer looks like. And we could do custom views and drop that down, and it'll show server roles and drop that down, so on and so forth. There's Windows logs, application security setup system, forwarded events. There's application and service logs and subscriptions. Even to work with subscriptions, service must be running and configured. No, we don't want to do that right now. But that's essentially it, right? So we have these 4 hierarchicals. I know you could just click on the top one, event viewer local, and it should show you all of this stuff. So summary of administrative events, recently viewed nodes, log summary, so on and so forth. The standard logs that we had earlier defined on the left pane are visible, and we just see that. The following section in the application services logs, so we can drill down to right here. So if it goes into, where is it? So we go to Windows logs, and then open that up, and then you can go into PowerShell, but that doesn't show. So it says drill down on Microsoft Windows PowerShell operational. So where would that be? Application and service logs, my bad. So application and service logs, here we go. And then we got Microsoft, we can open that up. Windows, we can open that up. And then inside this, there's all of these things inside Microsoft. And so we would go to P to try to find PowerShell, and there's PowerShell. And so it opens it up right here, and then operational is right here. And you could also navigate by this, right? You could just double click on operational and it'll open up all the stuff inside the operational. And so now it says right click on operational and then properties. So I could right click on operational and then go to properties, and it will open this up for us. And this is what this looks like. Within properties, you see the log location, which is right here. You can see the log size, when it was created, modified, last accessed. And within the properties window, you can also see the maximum set log size and what action to take once the criteria are met. This concept is known as log rotation. These are discussions held with corporations of various sizes. How long does it take to keep logs, and when it's permissible to overwrite them with new data. So log size is right here. So this one in particular is 2.07 megabytes. And after that, it's going to rotate and it's going to create a new log. On the clear log button at the bottom right, which is right over here, there are legitimate reasons to use this button, such as during security maintenance, but adversaries will likely attempt to clear the logs to go undetected. This is not the only method to remove the event logs for any given event provider. So it's not just GUI that you could do it from, or that button, right? So you can do a lot of different ways to clear event logs. Focus your attention on the middle pane. Remember from previous descriptions that this pane will display events specified to a selected provider, in this case the PowerShell operational. So we can close this out and we can go right here, PowerShell operational. That's the middle pane right here, and all of these things. So information level, verbose level, information, there's a warning. So let's see. Oh, okay, well, I don't want to get sidetracked here. It's probably going to ask us a question that has something to do with this later. So from the above image, notice that the event provider's name and number of events logged. In this case, there are 44 events logged. And for what? For PowerShell, right? You might see a different number. No worries. Each column of these pages represents a particular type. So we have level, which is this thing. It highlights what it is, and so it's information, right? Date and time, the source, the event ID, and the task category. The middle pane has a split view. The more information is displayed in the bottom of the half of the middle pane for the event that you click on, which is right here. So if I click on verbose, it'll open that up. If I try to find that warning sign or warning one, I could probably do it by sorting by name. And then we can go all the way to the top, or well, all the way down. And there should be one that says warning. I know I saw it. It's impossible for it not to exist, because I definitely did see it. And I know you saw it too. So it can't be that it doesn't exist. Maybe it was in a different section. There we go. Here are the warnings. So there's a warning. How's that? I guess by level, it means that it's going to go by the severity level, probably. So it shows the warning. It's not going by alphabetical. So anyways, warnings are at the top right here. And so we have, 6 different warning messages. So we can see that. And then inside that, there's going to be the general. And the general view is the default view. And the details view has 2 options, friendly view and XML view. And so we have this, and has detected an error in snap-in and will unload the snap-in and continue running. And here it is. I guess that's what that is. Okay. And snap-in unavailable. Uh-oh. I may have just crashed our little system here. Okay. So there's that. I'm going to have to restart it when we're done. Then we have the actions pane, which is on the right hand side of this thing. And so you can open saved log with the actions pane. This is useful if the remote machine can't be accessed. The logs can be provided to the analyst, and we'll do this in a little bit. And I think this is the log that we're probably trying to access later, the merged log on the desktop. The create custom view and filter current log are nearly identical. The only difference between the two is that the by log and by source radio buttons are grayed out. What is the reason for that? The filter you can make with this specific action only relates to the current log, hence no reason for by log or by source to be enabled. Why are these actions beneficial? Let's say you don't want all the events associated and you're only interested in 4104 events. That's where these two options come in. And so to view logs from another computer, click Event Viewer Local, which was that very top button that we had, and right click on it and connect to another computer, and you could do that. So that is the general overview of Event Viewer. So let's try to get a little bit familiar with it. So it says use the Event Viewer to analyze Microsoft Windows PowerShell operational log. So we're gonna open that back up to exactly where we were. And I think that button is the shortcut. Yeah, there we go, perfect. So we're going to go to application logs, we're going to go to Microsoft, we're going to go to Windows, and then from here we're going to look for PowerShell, and we're going to open up PowerShell and operational logs. Okay. What is the event ID for the earliest recorded event? So it's all from 220 and then 2020. So it goes all the way back. And so this is probably the earliest one. And the event ID is 40961, I believe. So let's see. 40961. And that is indeed the answer. Filter on event ID 4104. What was the second command executed in the PowerShell session? So we can go and do that inside this actions pane where there's a button for us to be able to filter the current log. So the, let's see, the create and custom view and filter current log are nearly identical, and they're inside the actions pane on the right side here. So let's see if we can find the filter current log, and we want to go, I think it's actually logging this specific one. So if I actually go into the 4104 event ID, then I do filter current log, and it will do that. And so it says filter that. What was the second command executed in the PowerShell? So I guess I can just do all of these things, and we'll do we'll check all of these buttons right here, because it doesn't really, yeah, I'm just gonna do it, why not? So we're gonna filter all of these things that are relevant to this thing. If I click OK, it will show that. And so event 4104, and yeah, so these are all of these that are event 4104. And now the question is asking, what was the second command executed in the PowerShell session? So if I go and it says execute a remote command, and that's the first one, 1006, and this is all going, yeah, it's going so further. So we want the second command, so I'm guessing it's the very one right down here, right? That's what it seems like. Nope, that is not it. So we need to go all the way back to the top to get to 4104 and then find the second command. And I'm probably going to look at this hint just to understand. Click the script block text. Okay, so this is what I did not do correctly. When you click on filter current log, I don't think this part of it mattered as much, so that was an interesting test. Right here, where it was event IDs, previously it said all event IDs, and that's the part that we need to change the number to. So 4104, press OK, and it only now shows everything that has to do with event ID 4104 always. And so if we go to the second earliest, which is from the bottom, and we click on that, this is the command right here. So who am I is going to be the command. So we press who am I, and that is our answer. So what is the task category for event ID 4104? And the task category would be down here. So it says execute a remote command and analyze the Windows PowerShell log. What is the task category for event ID 800? So we'll go back again and we'll change this now to 800, and there's nothing here. It says number of events 712, so I guess it hasn't shown it. Analyze the Windows PowerShell log. And what is the event ID for 800? Okay, so if it's not in this one, I guess there's another thing. So there's Windows PowerShell, and there's probably something under W. There's Windows PowerShell maybe down here. Oh yeah, it is. It's all the way down here. So Windows PowerShell, that's the one that we're looking at. So we're going to filter this log for event ID 800. And the task category for this is going to be pipeline execution details. And there it goes. Okay, cool. We got it. And now we can move on to the next task, which is going to be wevtutil.exe. wevtutil.exe. All right, you played around a bit with Event Viewer. Imagine you have to sit there and manually sift through hundreds or even thousands of events, which is not fun, no. It would be nice if you could write scripts to do this for you, yes. And so let's look at this exe. Per Microsoft, it enables you to retrieve information about event logs and publishers. You can also use this command to install and uninstall event manifests to run queries and export, archive, all that stuff. So as with this, as with any tool, we can access the help file to see what it does. And we can just do this command to see what it is, and it's PowerShell. So let's run it real quick. So wevtutil.exe /, enter. And here's all of the options that are available through this. List log names, login confirmation, event publishers, uninstall an event, get log status information, export a log, clear a log, all that stuff. So under usage, you are provided a brief command of how to use the tool, which is right up here. And it's like this. So wevtil, the command, and then the argument, and then option value, so on and so forth. So the wevtil command is going to be one of these things. You could probably do either the acronym here or actually do enum logs or whatever. And then the argument would be, whatever you want to analyze or export or do anything like that. So as an example, let's see, we can find common options that can be used with Windows Event Utility. The common options are R for remote, and that would be the value. Options IM and UM do not support this. Then there's username, there's password, authentication, Unicode, so on and so forth. It says, notice at the bottom, there's a command /question. This will provide additional information specific to a command. So we can use it to get more information on the command query events, which is QE. So I could go here and do can I type or, yeah. Okay, maybe bring this up a little bit further. So wevtutil query E, and then do this, and now it should give us more about the query, right? So usage, and so on and so forth. So look over the information with the help menu to fully understand how to use this, and you have enough information to use the tool. Time to answer some questions. It's always recommended to look into the tool and its related information at your own leisure. We can get more documentation about it. So how many log names are in the machine? So what is it going to be? Pipe the EL command to the PowerShell measure object commandlet. Okay, so let's see what that's going to look like. So if it's going to be the EL command, so wevtutil EL pipe, and then measure object 1071, and that is the right answer. Okay, what event files would be read when using the query events command? So it's at the top right here from the previous command that we ran, which is the wevtutil QE whatever. So event log, log file, or structured query. So it's going to be event log, log file, structured structured query. Very good. What option would you use to provide a path to a log file? When we look at the options here, it says if true, path is the full path to a log file. Path is the full path that contains a structured query. So this is probably it. So LF or log file, I think, is that how you say it? So it would be for LF true. I got it. Okay, so yeah, that's it. That's what it is. So LF, if true, path is the full path. So LF true, that's the option. And that's how that runs. What is the value for /q? The value for /q is an XPath. So XPath query. Very good. The questions below are based on the command webtil-qe application yada yada yada. So let's run that command. webtil-qe application C3 true and F text. Okay, so there we go. What is the log name? So let's go here. Log name is application, as it says right here. So we can do that. What is the RD option for? So if we go and check that out, let's see what we can find. So I believe instead of actually looking for webtutil, and then the RD options for that, it would actually still be under the QE, because that's what we were running, and it was one of the options under QE. So when you do that, it brings all the options back again, and then RD is right here. And so it gives a very straight up answer. So event read direction would end up probably being that answer. So event read direction, and that is it. And so now we can also look at the C option, which is right down here. It says maximum number of events to read. And that is it, maximum number of events to read. There we go. Okay, cool. So there is that specific task. We just went through webtutil, and this was again a very very overhead view, kind of general view of this whole thing. As you can see, there is plenty of things that can be done with it, and I mean, we didn't even really analyze the output of the application thing that we just read. We just know that we read an application named application, or a log, a file, a log named application. That's all we know that we read. And we read it with the redirection option, as well as the maximum number of events to read option. And the maximum number of events was 3 that we read, and we did read in the event direction, I guess. So that's basically all that was for the webtutil.exe. Now we're going to move on to the next task, which is get win event, which is a PowerShell command. All right, the get win event, it's a tool from PowerShell commandlet. What it does, it gets events from event logs and event tracing log files on local and remote computers. Provides information on event logs and event log providers. Additionally, you can combine numerous events from multiple sources into a single command and filter using XPath queries, structured XML, and hash table queries. The get win event commandlet replaced the get event log commandment. As with any tool, it's good to practice and read the get help documentation to be acquainted with its capabilities. Please refer to the get help information online at Docs Microsoft. So let's look at a couple of examples. Get all logs from a computer. So it would be get win event and list log. And so if we ran that over here, let me see if clear screen, okay, it does work. So get win event and list log with an asterisk. And look at that. That's all the logs. So there we go. The next one is get event log providers and log names. So same command. I'm just going to clear the screen. It's going to be get win event and list provider. and press enter. And look at that. That's a lot of output as well, and it's probably going to keep going. Log filtering. So that's probably a good idea to learn how to filter some of these logs. So we are going to run this for the application log file that we were just looking at. And then what we're going to do is we're going to look at an object where the provider name matches WLMS. So and there it is. And so we're going to run that where object is not, oh, I misspelled object. Of course I did. And so we're going to go and fix the spelling of object. And that should run. And there we go. Okay, so we got it. And so the response is exactly this. So provider name, and it literally gives us the same exact response. Actually, the ID numbers are a little bit different. So that's probably something that's unique to us. And we don't have a level display name either. Ours is just blank. So that's different from the example that's on the screen. If you're ever working on Windows evaluation virtual machine that is cut off from the internet eventually, it will shut down every hour, okay? When working with large event logs per Microsoft, it's inefficient to send objects down the pipeline to a where object command. The use of the get when event command filter hash table parameter is recommended to filter event logs. We can achieve the same results as above by running the following command, which is this thing. So I'm going to run this command. I don't know if I can paste this. Let me see if I could just paste this. That might be useful. I can't paste it. Okay, great. Let me see. Control V. No, that doesn't work either. So let me type this out real quick. Oh, I see. I should have pressed enter in that thing, and it would actually keep it open for us, so we can keep doing that. Interesting. Okay. Now I learned a new thing. And then put that closing bracket and press enter. But it still gave me an error message. So it's like, what the hell? So log name, application, filter hash table, all of that stuff is fine. So I don't exactly know what the problem is here. So get win event is not an event provider on the local host computer that matches WLMS. So I guess we don't have it, which is odd because we did see it in the previous query that we ran. So that's kind of an odd thing that's happening here. The specified providers do not write events to any of the specified logs, and the parameter is incorrect. Let's see what I can do with a little bit of research and see if I can find anything different. From what I understand, I actually did this correctly, so it's kind of it's a little bit odd that it's not working. I do want to move on because I do have to make good time with this recording. So if you find out why that didn't work, please let me know. That would be very, very interesting for me to learn. The syntax of the hash table is as follows, and we see it right here. It could be very possible that I didn't have a semicolon in between those things, so that could be one of the reasons why it didn't work. So I will do this one more time, and I will put a semicolon to separate these two, and maybe that will be the specific reason why it does work. Nope, still doesn't work. Okay, so guidelines for defining a hash table are begin the hash table with an @ sign and close the hash table braces. Enter one or more key value pairs for the content of the hash table. Use an equal sign to separate each key from its value. For example, this. If you don't need to use a semicolon, if you separate each key value with a new line, as in the screenshot above. Below is the table that displays the accepted key value pairs for get win event filter hash table parameter. And so we have all of these things right here. And we used which ones? We used the log name and we used the provider name. And both of those are over here. When building a query with a hash table, Microsoft recommends making the hash table one key value pair at a time. Event Viewer can provide quick information on what you need to build the hash value. So it says right here, so log name, application, source, MS installer, event ID, level information. So log name, there's also something for the user ID, the ID itself, that would be probably the event, the level of it, the provider name, so on and so forth. So that's all there. Based on this information, the hash table will look as follows. Get win event, filter hash table, add log name application, provider name, MS installer, ID 11707. For more information, we can go and check the official documentation. And since we're on the topic, here's a command that you might find helpful used by Mubix. And so get win event, the hash table, which would be the log name, Microsoft Windows PowerShell operational, ID 4104. That's the one that we looked at in the actual event viewer. Select object, property message, select string pattern, secure string. And that is all we get without going into the online documentation. So we're probably going to need to use the online documentation for these, as it says. So first it says execute the command from example 1 as is. What are the names of the logs created to open SSH? So if we went to example 1 right here, as is, so I'm going to write that one more time, and it's going to be a pretty long list. So we're going to do this again. And we're looking for open SSH. Oh, thankfully it's at the very, very bottom right here. So that's pretty convenient. So it says, what are the names of the logs related to OpenSSH? So we have two. It says OpenSSH admin and OpenSSH operational. So we're going to do that. There we go. Execute the command from example 8 instead of the string policy. Search for PowerShell. What is the name of the third log provider? Okay, so we are on the documentation page on Microsoft, and I went down to example 8, and this is the thing right here. So it's get win event list provider policy. So instead of using policy, we're going to use what did they say? PowerShell. So get win event list provider PowerShell. And there we go. So it says, what is the name of the third log provider? So if we go down here, let's see, we got the first one, the second one, and the third one. The name is a very long name. I really hope I can copy this. Control C maybe? Hopefully Control C will actually let me copy. So let's see if that copied it. Oh, it did, thankfully. Okay, so it's not a right click thing, so it's Control C that probably copies. That's great, okay. Execute the command from example 9. We're gonna use Microsoft Windows PowerShell as the log provider. How many event IDs are displayed for this event provider? So example 9, and it's going to say Microsoft Windows PowerShell as the log provider. So I'm just gonna open this up in a separate command, or in a separate window right here, just so I can view it while I'm typing. I'm gonna try to copy and paste it, but I don't know, for whatever reason, I feel like this might not work. So we're gonna do this, copy that. Let's go here. If we could actually paste this, that would be amazing. I can paste it, that's amazing. Okay, so there we go, and then measure, right? They said measure, what is it? Measure object commandlet? Yeah, pipe to the measure object commandlet. So measure object. There we go. That was nice. Okay, I'm excited. Control C, control. Oh, but it's not right. The answer is not right. Oh, because I used the wrong list provider. So that's my bad. Okay, so I got to do this, and then I got to change it to, what is it? We're going to use Microsoft Windows PowerShell. And then we are going to change or add to the very end. We're going to pipe in measure object. Okay, 192, that should be it. Very good. How do you specify the number of events to display? So if we go through here, what I'm gonna do is I'm gonna do a find for events. And there are, oh, it's right here. It's literally right in the very, very first one. So get events from an event log, syntax, max events. That's probably it. So I'm going to do dash max events. There we go. Nice. Cool. When using the filter hash table parameter and filtering by level, what is the value for informational? And check the online help documentation. So filtering by level, filter hash table, informational. So let's see, maybe we can do informational. There's nothing on here. Filter hash table. Hash table. I'll just do the full thing. And what is the value for informational? Okay, so it's actually on a different page. So when you go to, it's under example 17. It gives us a couple of links right here, and this one says creating the get win event queries with filter hash table, and it opens this up, and then you go. It's almost towards the bottom of the page, where we have this thing right here. And so it says informational, the value is 4. So we're going to go here, click on 4, press enter, and that is it. Very good. So we have finished the get win event task, and now we're going to move on to XPath queries. XPath queries, now we're going to examine filtering events with XPath, the W3C created XPath or XML path language in full to provide a standard syntax and semantics for addressing parts of an XML document and manipulating strings, numbers, and booleans. The Windows event log supports a subset of XPath 1.0. This is what an example of that looks like. The following query selects all events from the channel or log file. So XPath query, system level 3, time created, and then this thing I believe is the actual time created. Based on the documentation, XPath level query starts with the asterisk. I just drew a blank. The asterisk or event. The above code block confirms this, but how do we construct the rest of the query? Luckily, the event viewer can help us with that. So we can create an XPath query for the same event from the previous section. Note that both WebTutil and getEvent support XPath queries at event filters. So if we go and choose under details, now this was unfortunate because every time that I tried to do this, it would crash. When I would try to look at the detailed view, it would crash. So if I click on details tab and select XML view radio button, don't worry if the log details you're viewing are different. The point is understanding how to use it. So I guess so when you click on XML view, it would be the very top piece that is the event, and then the first tag is the starting point, and you can be an asterisk or the word event. The command so far looks like get win event, log name application, filter XPath, asterisk. And then the next piece is the system, and the next tag is the system, and the get win event, log name application, filter XPath, asterisk system is what it's going to look like so far. Then we expect best practice to explicitly use the keyword system, but you can use an asterisk instead as with the event keyword. The query filter XPath is still valid, so asterisk / asterisk. The event ID is 100, so we're going to plug that into the command, which is going to look like system event ID 100, and this will, I guess this is the final piece, right? So get win event, log name application, filter XPath, event ID 100, and it shows us all the information about event ID 100. When using WebTutil and XPath to query for the same event log and ID, this is the result. So this previous one was get win event, and the next one is WebTutil. QE, so we're querying the application, and the query itself is going to be similar to the other one, except the event ID is not in brackets here. Everything is inside a quote here. On this situation, this is no quotes, and you have the asterisk, system, the event ID is inside brackets and then text and count 1. So we just want the first count. And the 2 additional parameters that we used in above command just to retrieve 1 event and not to contain any XML tags. So that's why we said text. If you want to query different elements, such as the provider name, the syntax will be different. To filter on the provider, we need to use the name attribute of provider. So this is the commandlet from PowerShell for get win event, log name application, filter XPath, system provider name, and then that's what it looks like. And that's how you create that. And if you want to combine 2 queries, the answer is yes. The provider name is WLMS, and the output, there are 2 event IDs. So there's event 101. So we could do get win event, log name application, filter XPath, system event 101, and system provider name is WLMS. And that's what it would look like. No, this is not that, because they don't have the event ID in there. But this one has the filter XPath, system provider name, and so we got that. Let's discuss how to create it for the event data that have elements within event data. It's going to be a little bit different. It doesn't always contain information. Below is the XML view of the event for which we will build our XPath query. And so we do have event data in this particular case, and there's a bunch of things in there, including target username. And so what the command is going to look like is get win event, log name, security is the name of the log, filter XPath, asterisk event data, because we are going inside the event data section, data, name, and then the name of the data is target username, and that equals system, because it's the target username is system. So that's how you read that. And so that would end up being this particular thing. Max events is going to be 1 because we are using the get win event and not the wevtutil. So we would use max event 1. Wevtutil is the /C1. That's what that would be, the equivalent of max events here. And so the max events parameter was used and it was set to 1, so it'll return 1. So now we have enough knowledge to create it, I guess. So now we are going to combine this knowledge to get a query on WLMS events with a system time of this much. So let's see what we can come up with. All right, so our hint gives us some useful information here. So the key XML elements to be used are the provider name, which is WLMS, and the system time created. And so we're going to use both of those things. And what I'm going to do is I'm just going to copy this entire section, and I'm going to delete the word and from it, and then I'm going to paste our values in there. So we're going to do this. First, we need to do get win event the way that everything else looks like. So we're going to do get win event, and we are filtering to filter from a system with a system time of so on and so forth. I guess it would be inside the log name security and the filter XPath option. And what now we're going to do is we're going to paste those 2 values that we had, which is right here beautifully. And so on the inside of the filter time, I'm going to put this thing. So copy that and click here, and this should paste it. Perfect. It pasted it right in the middle of that. And then inside the name of the provider, we're going to put WLMS. And I do believe that I have to wrap all of this inside of quotes. So we're going to put a quote around this one, and we're going to put a quote around the very end of it. Like so. Okay, so now we have that, and it says what is the query to find, so on and so forth. So now that I have this entire query, I believe I'm just going to copy this full thing. And let's see if I paste it here, if that'll be correct. That is correct. Look at that. Okay, so using the get when event and XPath, what is the query to find a username named Sam with a logon event ID of 4720? The answer to this one is going to be a combination of this particular command right here, as well as the one that we just saw up here where it has the system event ID. So we're going to combine system event ID and the target username. So we're going to do get when event, log on, log name, security, filter XPath, all of this, and then we're just going to change the username to Sam, and then we're going to put and. So since you notice how there's double quotes and then there's that single quote that applies to this thing right here. So we're going to do and then from there we're going to add the system event ID parameter as well. So right here, you see how there's an and it's been separated. So that's basically what we're going to do. So we're going to go here and we're going to create this whole thing. I'm going to create it here first just to kind of make sure, because I don't know if you noticed, but there's a little red mark that comes here if it's incorrect. So if I do, I don't know, something, I don't know, is that even right? That's not right. It hasn't given me the red mark, but it gives you a red mark. Essentially, when you're typing a command up and you don't have the right command on or anything, it'll give you a notification just by putting a red instance over there that, yeah, you know, this is, there's an error here. And so from that, we can kind of make sure whether or not this is good or not, right? So if I can go here and do the person's name is going to be Sam, and then go here and press and then do one of those things, then we can add the second option. So 4720 is the system ID that we want. So we're just going to copy this section right here, and we're going to copy that, and we're going to paste that over here. And inside the system ID, we're going to just change that to 4721, right? 4721, that's what it was. 4720. So that's what the command should look like at the very end. Get when event, log name, security, filter XPath, event name by target username is going to be Sam, and the system event ID should be 4720. And that should work. So does this even exist? Let's see if we can even search for this. Seems like it doesn't exist. But for now, I'm going to just copy this and go over here and paste it. And that is the event. But I guess it doesn't work because maybe there is no such person there. So based on the previous query, how many results are returned? Okay, so we can enter this. So press enter. Run for me. Oh, there we go. We got it. We got 2 results. So boom. And based on the output from question number 2, what is the message? And the message is a user account was create, I guess. I think it's supposed to say created, but a user account was create. Okay, that's fine. And then still working with Sam as the user, what time was event ID 4724 recorded? And so we got 4724. So same thing. So we're gonna just do an up. Now we're gonna just change 4724 to the event, and it's gonna give us that. And now we have our event time. So I'm gonna try to copy this section, and from here we're gonna go and try to, whoops, we're gonna paste it in here. And there is that. And what is the provider name? So let's try to find that. The provider name is right here. Microsoft Windows Security Auditing. And we'll just take that whole thing and we'll copy that and then come over here and paste it. And that is it. Great. So not bad. It's pretty cool that we could do this, honestly. So now moving on from XPath queries to event IDs. All right, here we go. When it comes to monitoring and hunting, you need to know what you're looking for. There are a large number of event IDs in use. This section is aimed at assisting you with that. So There are plenty of blogs, write-ups, and everything on this topic. The first resource is going to be the Windows logging cheat sheet for Windows 7 and Windows 2012. The last version of the update is October 2016, but it's still a good resource. The document covers a few things that need to be enabled and configured to look for event IDs based on categories like accounts, processes, log clear, etc. So this is what it kind of WebTutil is. Use this utility to query your logs, QE security, query the security log for events. Lots of flags here, so read the helpful WebTutil commands. The read 5 events we already know. Newest events first, we already know. F-text, format text, also can do XML. So we've used all of those so far. Success and failed logons, user account change, new service installed, user account changes. All of those are available. This is just a snippet from the cheat sheet. So if you want to see the new service was installed, look for event ID 7045 within the system log, and that will show you. And so it has the event IDs for each one of these as well. So right here, right, new service installed, system event ID 7045, and then just the rest of that stuff, and it should give you the response that you're looking for. Spotting the adversary with Windows Event Log Monitoring is another resource. It's an NSA resource, and it's a bit outdated but good enough to build upon the foundation. The document covers some concepts in this room and then some. We can click on Get File to download the resource, which I guess would be inside the actual browser itself. You have the Windows Firewall. These are the firewall rules for event IDs and levels and event logs and event source, so on and so forth. The above is from the document. If you want to monitor if a firewall rule was deleted, the event is 2006 or 2033, which is right here. Where else can we get a list of event IDs? MITRE ATT&CK, of course. We've done a video on MITRE ATT&CK and the MITRE framework, so I highly recommend you go check that out. It's on the channel. And you can look at attack ID T1098 for account manipulation. Each attack ID will contain a section sharing tips to mitigate. And so detection, collect events that correlate with changes to account objects and or permissions on systems and the domains, such as events 4738, 4728, and 4670. So the last two resources are from Microsoft directly and Events to Monitor, and the Windows 10 and 2016 security auditing and monitoring references, which this is a screenshot of. So 1100 is the event logging service has shut down. 1102, the audit log was cleared. 1104 is the security log is now full, so on and so forth. So it's nice that the event IDs are attached to specific events, and you can now filter by those events. And if you have a cheat sheet of important events in the context of cybersecurity, for example, then you can filter for those events specifically, and it'll kind of speed up the process, and you'll have more of a streamlined process to find these things and mitigate and so on and so forth. So some events will not be generated by default, and certain features will need to be enabled on the endpoint, such as PowerShell logging, and this can be enabled via group policy or the registry. The local computer policy, configuration, administrative templates, Windows components, Windows PowerShell is where we would go inside the group policy to be able to enable or disable that. Some resources to provide more information about enabling the PowerShell logging along with the associated events. So logging Windows, visibility through PowerShell, configure PowerShell. These are some event codes of use. Another feature to enable and configure is audit process creation, which will generate the 4688 ID. This will allow command line process auditing. It is not enabled in the virtual machine, but feel free to enable it and observe the events generated after executing some commands. So this would be local computer policy, configuration, admin templates, system, audit process creation, and then we can go ahead and configure that. Event properties 4688 is process command line, which is what this would look like. So the process information and for the command line. And that is that. To read more about this feature, refer to the Microsoft documentation. The steps to test the configuration are at the bottom of the document, which would be right here. So try this: explore command line process auditing, and we can just follow all of these. So I wonder which one of these. Oh, we don't need to do any of these right now, but I guess we're going to put all of these theories into practice, combining everything that we just learned. So we're gonna complete this particular task, and I'm probably gonna be referring back and forth to all of these things that we just went through, so we can answer the questions that are about to come up right here. So the next scenario questions are based on the external event log file titled merged EVTX, which is on the desktop. You can use any of the aforementioned tools to answer the question. So scenario 1, which is questions 1 and 2, the server admins have made numerous complaints to management regarding PowerShell being blocked in the environment. Management finally approved the usage of PowerShell within the environment. Visibility is now needed to ensure there are no gaps in coverage. You research the topic, what logs to look at and what event IDs to monitor. You enabled PowerShell logging on a test machine and had a colleague execute various commands. The security team is using event logs more. They want to ensure they can monitor if the event logs are cleared. You assign a colleague to execute this action, and the threat intel team shared its research on Emotet. They advised searching for events 4104 and the text script block text within the event data element. Find the encoded PowerShell payload. And a report came in that an intern was suspected of running unusual commands on her machine, such as enumerating members of the administrators group. A senior analyst suggested searching for the net1 executable, confirmed that suspicion. So we are going to go straight up from the first series of questions. So the first 2 questions belongs to scenario 1, and then 3 and 4 scenario 2, 5, 6, and 7 is scenario 3, and 8 and 9 are scenario 4. So let's go and let's dive into it. So what an ID is to detect a PowerShell downgrade attack. And so we can go here and we can look at what was inside our PowerShell references to see if we can find a PowerShell downgrade. If not, we can just go to the website that they're referring to so we can check that whole thing out. So I kind of cheated a little bit and I Googled what the PowerShell downgrade event ID might be, and it could be either 400 or 4688. So let's try one of those two, and let's go over here and let's try 400 first, and that's the answer. Okay, very good. What is the date and time this attack took place? And so now we're going to search for that ID in our log file that we have. So I'm going to close this down, and I'm going to shrink this, and we're going to open up the merged document here. And so what we want to look for is the event ID 400, and let's see what we can find. The first appearance of this downgrade code, the event ID 400, was 12/8/2020, and the PowerShell event 400, and so on and so forth. So this is it. What is the formatting of this that we need to do, which is month, day, year, and the time. So I'm just going to see if I can copy this particular section and see if we can just paste it as our answer. This might not be the right answer, but it's not. Okay, so that is that. So let's try to see if we can find another event that has to do with the PowerShell downgrade. Okay, after a lot of trial and error trying to read this thing with the get win event and trying to find the information that way, there is a way. I mean, this is kind of like the manual way that we could do this, and I guess it's not the preferred way, but it is possible to do it like this. So essentially what we're looking for is a difference in host version. So all of the hosts right here, and I'm going to kind of zoom in a little bit so you can see all of the hosts, with the exception of one, this one also is actually downgraded as well. So all of them should be at 5.1. If you see right here in the host version right here, all of these say 5.1, right? And so when I go here, there is one up here that was host version 1, and then there's one at the top that's host version 2. So these are PowerShell downgrade, I think is what the phrasing of this was. So it says, what is the date and time that this attack took place? PowerShell downgrade attack. So it could be either of those two. The one that is host version 2 could be one. So we'll try this one. It could also be the one that's host version 1. So let's try host version 2. Okay, that's the one. But essentially, you're looking for the host version. And one of the big challenges that I had was that it couldn't even read the file that we were on. So because I was using log name, and instead of using log name, we're supposed to use path. And because it's a generated log that was created at some point, it's not one of the system logs. So if you want to read a log like that, you would need to use path, and then you declare the path that the log is actually on, and from there you can kind of start selecting the objects and the properties and stuff like that. So that's the furthest I got. I spent maybe a good 10-15 minutes on it, and I am limited on time because I want to make sure that I finish this recording in a timely manner. So I just resorted to manually searching through the log entries individually, and we just found it. So that is that question. Now we can move on to the next question, which is now questions 3 and 4. Security team is using event logs more. They want to ensure that they can monitor if the events are cleared. You assign a colleague to execute this action. So a log clear event was recorded. What is the event record ID? So the event record ID for log cleared, and I think we actually see that here somewhere. And we can go, and this is for firewalls. We can always go and, oh, there we go, it's right here. The audit log was cleared. So 1102S maybe, that might be it. So it's either 1102S or it's 1102. I'm gonna add some time to our machine so it doesn't die on me. So let's try that first. We're gonna do 1102S. That's not it. 1102. That's not it either. That's crazy. Okay, so log clear event was recorded. What is the event record ID? What does the hint say? Check XML view. Okay, let's see if it'll let me check it without crashing. So 1102 is the event ID for log cleared. So let's see if that even shows up here. Okay, so we did some online Googling and researching, and there are 2 different IDs that could be used for log manipulation when a log is cleared. So 1102 was the one that we just searched for and nothing showed up. So another one could be 104. So let's try to go and filter for 104 and see if we can get anything out of that. And we do. Very good. And let's see if I can get the details without it crashing. Oh, great. I got the details. Check the XML view. And the question is, what is the event record ID? So the event record ID is going to be in the XML, and it's right here. 27736. That's it. So 27736. That's that. Great. What is the name of the computer? So let's find that here. Computer name is this thing, PC01 example.org, and there's that. Now we're moving on to the next portion of this, which is 5, 6, and 7. The threat intel team shared its research on Emotet. They advised searching for event ID 4104 and the text script block text within the event data element. Find the encoded PowerShell payload. So what does our hint say over here? For XPath query, use oldest max events and pipe to format list. Okay. All right. So I tried this with the get win event as well, and unfortunately I came up short. So we're going to resort back to the GUI, and we're going to filter it with the event 4104 this time, and it's going to give us a certain number of events, and what they're looking for is the oldest. So we're going to look at the script block text, and the specific hint right here was to use oldest, meaning go for the oldest, and see what we can find here. So we're going to go to the oldest of these things, which is from 8/25/2020, and the script block text is right here. So the question is, what was the name of the first variable in the PowerShell command? And the first variable, I believe, is this right here. So VA5 something something something. So I'm gonna try this one. Let's see if this is the proper. Okay, doesn't seem to copy. Let's see if it'll do Control C. If that works. That does work. Okay, cool. So I'm trying with the PowerShell first with the actual get when event thing, and that doesn't seem to be working. So I may have to just resort to the GUI from here on out. So now question number 7, I believe, is that what we're on? 1, 2, 3, 4, 5, no, 6. We're on question number 6, which is still here. So the question is, what is the date and time that this attack took place? So it's this thing right here. We're going to copy that and go here. And what is the execution process ID, which is going to be under here, and we're going to look for execution process ID 6620 right there. So that's that, and that's that event. What is the group security ID of the group that she enumerated? So the suggested searching for system32 net1exe, enumerating members of the administrator group, and a senior analyst suggested searching for that net1exe. What is the group security ID of the group that she enumerated? Okay, upon some Googling, we found a website that shows us 2 different enumeration event IDs, and this is local group membership enumeration and the user's local group membership enumeration. So this is the user itself that is running it, and then there's the actual group membership enumeration, which is probably what this is going to be. And so 4799 is what we would need to filter for. And so if we go through here and change this to 4799 and filter that, and we got a few things that show up. And so it says group security ID of the group that she enumerated. So if I click on one of these things, there should be an SID, security ID. It says target SID. Backup operators built in, so Windows auditing. Let's see if there's anything that is administrators. Administrators, there we go. Target SID of administrators would be this, probably. Let's see if this works. That does work, great. And what is the event ID? For this particular one, the event ID is, it's different. Is it different? Yeah, event ID, 4799. That is what it is. It's the same one that we searched for, 4799. Okay, there we go. If I would have stuck to just using the GUI, which is this thing right here, our event viewer, this would have been much faster. But I was very much trying to figure out how to do it with the PowerShell commands and all those things, and I came up short. More often than not, I came up short. I was able to kind of do partial parsing of the log, but as you can see, a lot of it was failed attempts. So if you know what to do and how to search for the specific questions in this exercise using PowerShell, I would very much love to learn that. I even tried to use the Google AI to help me, just to see if I can maybe craft some better commands and stuff, and that also came up short. So yeah, if you can come up with any answers to that, I would love to hear from you in the comment section other than that, we use the event viewer. And I mean, there's a reason why there's a GUI for this, because it's a lot faster and easier and more convenient. And I know sometimes we don't get to have access to a GUI, so I totally understand that. But if you do have access to it, it feels like this might be the better way to go, unless you are extremely fluent in PowerShell commands in a way that you can just write these commands and parse through the file and find exactly what you need to find. So I am not there yet. I will be the first person to admit that to you. But I was very capable at finding it using Google, some basic Google searching, finding the event IDs that we need to find, and then going through the XML view and these different versions of the thing. So that is it for our Windows event logs room. And now we're going to jump into the conclusion. All right, in this room, we covered the event logs, what they are, how to query them using various tools and techniques. We also briefly discussed the features within Windows that you need to enable to configure to log additional events to gain visibility. The information is going to serve as a primer for other rooms covering Windows internals, SysMon, and SIM tools. We have additional reading material, which is all of this stuff right here, that I will do in a bit. Definitely not in this particular recording, because I need to wrap this recording. But apart from that, that's pretty much it for the Windows event logs room. I hope you found it useful, and I hope you learned some good stuff from it. If you did find it useful, and if you found some good stuff from it, I would kindly request that you like, subscribe, and turn on the notification bell, and maybe even drop a comment in the comment section, because all of that activity helps us with the YouTube algorithm so that we can get better reach and better exposure, so that we can expand the community, and all of that gives me more motivation to put out more of these videos for you. I don't ask anything else from you. I have nothing to sell, and I just would very much love your support. So any of those activities would help me out tremendously. You know, like, subscribe, turn on notification bell, and comment. And if you actually subscribe and turn on the notification bell, you'll be notified the next time a video comes out. And if you're studying for cybersecurity analysis, or if you're studying for ethical hacking or any of that stuff, all of these videos will actually be useful to you as well. So you'll be helping me and helping yourself, and it's a pretty good win-win situation. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite system and network attacker. I hope you got value from this room. If you did, please let me know what you learned in the comment section below. Apart from that, I will definitely see you in the next video. If no one else loves you, Hank loves you. Peace, love, and chicken grease. And I will see you in the next one. Bye. Okay, hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. And today we are going through the SysMon room that is inside of TryHackMe's pathway for SOC Level 1, the Security Operations Center, or the Security Analyst role. And this is in the Endpoint Security Monitoring module. We just did the Windows event logs in our last one, and so we are going to be doing the SysMon in this current room. And this is kind of what the room looks like, and it is inside of TryHackMe. If you don't have a membership to TryHackMe, there's a link in the description below that'll take you there, and it'll give you a discount on that. Before we jump into the room, I have one simple and humble request from you. If you like the content of this video, if you've learned anything from this video, or if you've learned anything from my channel so far, I would humbly request and kindly and respectfully, I would very much love it if you could like, subscribe, and turn on the notification bell, and even drop a comment in the comment section. All of those things helps with the YouTube algorithm to gain more reach on the channel, so that we can expand the community and grow the community. And I do all of these videos for you guys for free. I drop at least one a day, sometimes several per day. So if you turn on that notification bell, you'll get notified the next time a video comes out. And if you're studying to become a cybersecurity analyst or a ethical hacker, then all of these things will be helpful to you as well. So that's basically all I'm going to say about that. It would mean the world to me if you could like, subscribe, turn on notification bell, drop a comment, all that stuff. And yeah, that's pretty much it. So without further ado, we are going to go into the introduction of this room. All right, Microsoft Security, SysMon, is a tool to monitor and log events on Windows. It's commonly used by enterprises as a part of their monitoring, part of the Windows SysInternals page. SysMon is similar to Windows event logs with more detail and granular control. And we did the SysInternals video already, and that should be available by the time that this video comes out. That should already be uploaded and live on the channel, so you're more than welcome to go check that out. It's a pretty useful tool, the SysInternals tool, and SysMon is a part of that suite of software and applications. So it's a part of Microsoft Security. SysMon specifically is a part of Microsoft Security, and uses a modified version of the Blue and Ice boxes, as well as SysMon logs from the HoloLive Network Lab. That's what this room is about. And so before completing, it's important to do Windows Event Log, which we just did, and that should also be live by the time that this video comes out. So you should have that access to that already as well. The SysMon overview goes like this. So from the Microsoft docs, System Monitor is a Windows system service and device driver that, once installed, remains resident across system reboots to monitor and log system activity to the Windows Event Log. It provides detailed information about process creation, network connections, and changes to file creation times. By collecting the events it generates using Windows Event Collection or SIM agents, and subsequently analyzing them, you can identify malicious or anomalous activity and understand how intruders and malware operate on your network. It gathers detailed high-quality logs as well as event tracing that assists in identifying anomalies in your environment. It's most commonly used in conjunction with SIMs like Splunk or other log parsing solutions that aggregate, filter, and visualize events. When installed on an endpoint, it'll start early in the Windows boot process. In an ideal scenario, the events would be forwarded to a SIM for further analysis. However, in this room, we're going to focus on SysMon itself and view the events on the endpoint itself with Windows Event Viewer, which we did. So events with SysMon are located in the Applications and Services Logs Microsoft Windows SysMon Operational Directory. The configuration overview is as such, so it requires a config file in order to tell binary how to analyze the events that it's receiving. You can create your own SysMon config, or you can download a config. It's an example of a high quality one is right here, and SysMon includes 29 different types of event IDs, all of which can be used with the config to specify how the events should be handled and analyzed. We're going to go over a few of the most important event IDs and show examples of how they're used with config files. When creating or modifying configuration files, you'll notice that a majority of rules in SysMon config will exclude events rather than include events. This will help filter out normal activity in your environment that will in turn decrease the number of events and alerts that you'll have to manually audit or search through. On the other hand, there are rule sets like Ion Storm, the SysMon config fork that takes a more proactive approach with its rule set by using a lot of include rules. You may have to modify configuration files. Configuration preferences will vary based on what you need in your team. So the first event ID is the process creation. So event ID 1 is process creation. This will look for any processes that have been created. You can use this tool. You can use this to look for known suspicious processes or processes with typos that would be considered an anomaly. This will use the command line and image XML tags. So this is the rule group. The name is group creation or process create exclude command execution. The command line condition is that Windows SVC host XCK app model, so on and so forth, command line. The above code snippet is specifying the event ID to pull from, as well as what condition to look for. In this case, it is excluding the XVC host process from the event logs. Now we have event ID 3, which is network connection. It will look for events that occur remotely. It'll include files and sources of suspicious binaries as well as open ports. And it will use the image and destination port XML tags. And that's what it looks like. And the code snippet includes 2 ways to identify suspicious network connection activity. The first way will identify the files transmitted over open ports. In this case, we are specifically looking for nmap exe, which is right here, which will then be reflected with the event logs. The second method identifies open ports and specifically port 4444, which is commonly used with Metasploit. We've done that a lot. If the condition is met, an event will be created and ideally trigger an alert for the SOC to further investigate. ID 7 is image loaded. It's going to look for DLLs loaded by processes, which is useful when hunting for DLL injection and hijacking attacks. It's recommended to exercise caution when using this. It causes a high system load. This event will use the image, signed, image loaded, and signature XML tags. And the above code looks for any DLL that have been loaded within the temp directory. If a DLL is loaded, it can be considered an anomaly and should be further investigated. We have event ID 10, which is create remote thread, and will monitor for processes injecting code into other processes. The function is used for legitimate tasks and applications. However, it could be also used by malware to hide malicious activity. This event will use the source image, target image, start address, start function XML tags. And this piece of code shows 2 ways of monitoring. The first is to look at the memory address for specific ending condition, which could be an indicator of Cobalt Strike Beacon right here. The second method will look for injected processes that don't have a parent process. This should be considered an anomaly and require further investigation. Event ID 11 is file created. It's going to log events when files are created or overwritten. This could be used to identify file names and signatures. And the event uses target file name XML tag. This is an example of ransomware event monitor, and just one example of a variety of different ways. So we have event IDs 12, 13, and 14 for registry events. They look for modification to the registry, and it can include persistence and credential abuse. This uses the target object XML tag. This code right here looks for registry objects that are in the Windows System Scripts directory, as this is a common directory for adversaries to place scripts to establish persistence. Then we have ID 15, which is file create stream hash, and it will look for any created file that is in an alternate data stream. It's a common technique used to hide malware, and it uses the target file name XML tag. This specific piece of code looks for files with the HTA extension that have been placed with an alternate data stream. We have event ID 22, which is the DNS event, and it's going to log all DNS queries and events. It's a common way to exclude all trusted domains that you will know to be very common noise in your environment. Once you get rid of the noise, you can then look for the anomalies. This uses the query name XML tag, and this piece of code will exclude any DNS events with Microsoft.com query. This will get rid of the noise that you see within the environment. So there's a lot of different ways that we can use tags to customize the configuration, and we'll be using the Ion Storm and Swift on security config files for the rest of this room. However, we can use or create our own configuration files. So that is the gist of the event IDs and SysMon overview. Now let's jump into installing and preparing SysMon. Alright, so I have already pressed the start machine button, so that's already live, as you can see from the top of the screen right here. Installing SysMon is fairly straightforward and requires just downloading the binary from Microsoft website. You can find the binary from Microsoft SysInternals website. It can be part of the SysInternals suite if you download the whole package. The PowerShell command would be to download SysInternals as such, and then it'll just download it into that C directory. To fully utilize it, you'll need to download a SysMon config or create your own config. We suggest downloading Swift on Security SysMon configuration, which is what we're going to be using in this room. Then we have starting SysMon. So the command would be sysmon exe, accept the license agreement, and this is the configuration file specifically. So it needs to be wherever the actual exe file is obviously located. So wherever you download and install it, there's going to be the exe sysmon, and then you would accept the licensing agreement and initiate whichever Swift XML, I guess, is going to be the specific configuration. It comes in an XML format. And so from that, we can look at event viewer to monitor events. The event log is located under application services logs, Microsoft Windows SysMon operational. And you can find that through the hierarchy of the event viewer. At any time, we can change the configuration file by uninstalling or updating the current configuration and replacing it with a new configuration, or you can always just refer to another configuration file when you start it up, right? If installed correctly, your event log should look like this. And for this room, we already have created an environment with SysMon and configuration files. So deploy and use the machine for the remainder of this room. And this is what it is if you wanted to remote desktop into it. It's going to start in a split screen, but I'm going to open it up in a full screen view so that it's a little bit easier. And from there, we can now actually go into the first official exercise, which is called cutting out the noise. So since most of the stuff is noise and it's excluded or filtered out, we can focus on meaningful events considered to be malicious activity. And it could be anything from ransomware, persistence, Mimikatz, Metasploit, C2 beacons, and this is just a small handful of what could actually go wrong. The best practices are, to exclude over include is basically what it says, right? So it's like it offers a fairly open and configurable platform. Generally speaking, there are a few best practices, and a few common ones are this, right? So when creating rules, it's typically best to prioritize excluding events rather than including events. This prevents you from accidentally missing crucial events. CLI, command line interface, gives you more control. The CLI gives you the most control of filtering and allowing for further granular control. You can use get when event, which we did in the last exercise, or webUtil to access the filter logs. And you can incorporate SysMon into the SIM and other detection tools. We need to know the environment before implementation. It's important when implementing any platform. You should have a firm understanding of the network environment that you're working with to fully understand what is normal and what is suspicious. So filtering events with event viewer, we can filter by event ID, and we can click on the filter current log to actually open it up and search by event ID. And then when it opens up, it looks like this. And then in this little section where it says all event IDs is where we would put the event ID. And then filtering with PowerShell, which if you saw the last video on the event viewer and I was trying to create a bunch of different PowerShell commands to filter, unfortunately I kept running into walls and it wasn't working that well for me. So to answer the questions of that last room, I resorted to using the event viewer, which is perfectly fine because they tell us that we can do that. But it's faster if you know the commands that you want to use with PowerShell. And so get when event with the XPath queries is very useful. They said we're going to be using webUtil exe, so that's probably what we're going to try to do here. The command line is typically used over the event viewer because it allows for further granular control and filtering, whereas the GUI does not. For more information about that stuff, look at the Windows Event Log Room, which is another video that has already been up. And the instructions are there, and we went through the instructions and we found a lot of external sources that we used to do it. Unfortunately, when I was running the commands inside the virtual machine that was provided, I kept running into walls, and obviously I need more experience with it. So that's neither here nor there, okay? I know for a fact that I need more experience. So filtering by event ID looks like this. So this is the XPath query for it. And so you're looking inside the system, and then the event ID equals the ID. filtering by XML attribute name, so event data, data, name, and then whatever the name of the XML attribute is, or the name that you're looking for, by event data, and then the data itself. And then we can put these filters together with various attributes and get the most out of the log. So below, it's get when event, which is this whole thing right here. So it's looking get when event path, and that's the path to the log. And we're going to create an XPath filter on system event ID 3 and event data that is named destination port and event data that is data 4444. And so we're looking at the port and port number 4444, and that'll get something out for us that has to do probably with Metasploit, some kind of a reverse shell or something that was created. So that's the gist of the filter creation. Believe me, it is much deeper than that. But we're going to try to see what we can find using some of this stuff. So it says how many event ID 3 events are in this particular path right here, this particular log file. So we're going to filter by event ID, which is right here, and it's going to be by event ID 3. So first I'm going to go to the full screen right here. We got that. So now we're going to open up PowerShell, because that is the tool that we're going to search for, which, by the way, we can obviously do with the specific event viewer as well. But it's kind of, I want to get better practice at this. So if I don't find it through PowerShell, I'm going to resort to the event viewer itself. So we're going to do get when event path, and then we're going to go to the path of the file, and then the system event ID filter. So here we go. It's going to be get when event path, and then we're going to paste that path in there. And then now we're going to take this piece right here and copy that, and it's going to be filter XPath first, and then we're going to put the system event ID portion. So filter XPath. Is it supposed to be all caps? That's the other thing. So X and P are supposed to be all caps. XPath, and then paste that in here, and then change that to number 3, and let's see what we get. Oh my god, that's a lot, dude. I think there's something called measure. Yeah, it's over 10,000 or however many thousands it is. So there's something that we can do to measure the output or something like that. I need to find out exactly what the command is. So give me one quick second. Okay, I was close. It's measure object. So we're just going to do a pipe at the end, and we're going to do measure object, and it should just count through it and then give us the number of the whole thing at the very end. And obviously, as you saw, there's a lot over here, so it's probably going to take a few seconds to count everything and then give us the actual count. So I'll be right back. All right, here we go. We got the finished number, and that's 73,591. So 73,591. And I think I need to put a comma in here, otherwise it won't count it for whatever reason. And that's not a comma, that's a comma. There we go. So 73,591 is the total count. And so what is the UTC time created for the first network event? So we're going to basically run the same thing, but now we're going to do a max count parameter, max count option, to give us just the first one. So I'm going to run the same thing, and I'm just going to do, I think it's max count. Okay, it's not the first item, it's actually the last item. And so when you do max events 1, it literally takes the very first item that printed from the search that it was doing, and to be able to find the one that they're talking about, where they say what's the thing of the first network event, it's actually the last item on the list. And so this is what the first item would have looked like. and this is what the last item on the list would have been, which is the actual correct answer. So the way that we did that was to be able to print it, we assigned our entire search with getWinEvent to a network events variable. And so the getWinEvent, path, so on and so forth. In this particular case, I just did where the object is ID 3. You could have also just finished it with the same thing where it says system ID, so on and so forth, that specific XPath. From there, we created another variable, which was the last event. So last one right here. So we do last one. It just takes the last single object from this new variable that we created, that is that entire list. And so when I ran this, by the way, it also took a few minutes for it to complete because it went through the entire 73,000 results again. And then from that, we created the last one, and then we printed the last one onto the screen. So last one, the value, and that's the value of the very last entry of those 73,000 results. So that's how we got this particular answer, and now we are done with the cutting out the noise exercise. So now we're gonna hunt for Metasploit. Hunting Metasploit comes down to typically 2 ports. So 4444 and 5555 are the ports that have mostly been used by Metasploit reverse shell. I don't know why those ports, because essentially you could use any port to assign a reverse shell to, but for whatever reason, it's been those ports that have been used so frequently that essentially anytime that it pops up, it ends up being, oh, okay, this is probably Metasploit. A lot of this can be referred back to the MITRE ATT&CK software and their attack framework, and we can learn more about the payloads that are used in malware and stuff like that with the malware common port spreadsheet. It's covered further inside the hunting malware task that's inside this room. So what we're trying to do is we're trying to hunt for network connections, and the rule group itself is this entire set of rules, and what it does is it searches for these 2 ports specifically. So what we're going to do is we're going to open this in Event Viewer to view a basic exploit with Metasploit, and this is kind of what it looks like when you go into the details of it. It'll show you all this information, and then it says destination port 444, so it's limited to 3 4s, not 4 4s. And once we have this, we can get the process ID and the image. So the process ID is 3660, and the image is where exactly? Right here, image, right there. And that's what's been used over there. So we can now hunt for open ports with PowerShell, and we would use the getWin event with the XPath for network, connect, and destination port. And so this is what it would look like. getWin event. This is the path of the log file that we're filtering. These are going to be the filters. So event ID 3 and event data, name destination port, and event data 4444. And it will bring that up for us. And now we can break this down by its filters to see what it's doing. The first is the event ID, which we've already done. The next one is filtering for the data name, which is in this case destination port. And then the next one is going to get the value of that, the data that's actually in there, which is 4444. And now we can adjust this along with our own events to get exactly what we want in return, right? So that's kind of the gist of this one. The next one is going to be detecting mimikatz, and then hunting malware, hunting persistence, detecting evasion techniques, and then we'll probably go into the practical. Look at this, there's a bunch of questions over here. So we're going to go into the practical for that as well. That's so intimidating, just looking at that list of questions. But okay, so the first one was hunting Metasploit, and we saw what kind of filters and everything we needed to create to do that. And after that, we're going to read into hunting mimikatz and then malware and all that stuff. And then we're going to combine all of these things. I'm pretty sure we're going to combine all of this to get the answers for our practical investigation. So let's go into detecting mimikatz. Detecting mimikatz. And mimikatz is one of those things that you're going to have a hard time trying to find information unless you go into like specific blogs and stuff like that. to use it, because it's known for being something that dumps LSAS hashes and usernames and password hashes and all that stuff. So it's an important tool from the perspective of the attacker, and it's something, of course, as a security analyst, you need to be able to learn to detect and connect. So we can hunt for the file created, execution of the file, and creation of a remote thread and process that Mimikatz creates. AntiVirus will typically pick up Mimikatz, as the signature is well known, but it's possible for threat actors to obfuscate and use droppers to get onto the file device. So that's also important to know. We'll be using a custom configuration file to minimize network noise and focus on the hunt. For more information about this, we're going to check out MITRE ATT&CK T1055 and S0002. You can download the event logs used in this room, or you can find it in the practice folder on the given machine, which is what we're going to do in this case. Detecting file creation is going to be done using this particular rule inside a config file. And the first method is to hunt for Mimikatz, is just to look for files created with the same name as Mimikatz. And this is a simple technique, but allow you to find anything that may have bypassed the antivirus. Most of the time when dealing with advanced threat, you will need more advanced hunting techniques like searching for LSAS behavior, but this can still be useful. This is a very simple way of detecting Mimikatz activity that has bypassed antivirus or other detection measures, but most of the time it is preferred to use other techniques like hunting for LSAS specific behavior, and this is a snippet of the code. Then hunting abnormal LSAS behavior is use process access event ID to hunt for the abnormal LSAS. This event, along with LSAS, would show potential LSAS abuse, which usually connects back to Mimikatz and some other kind of credential dumping tool. So we can look for more detail on this. And if LSAS is accessed by a process other than SVC host exe, it should be considered suspicious behavior and should be investigated further. To aid in looking for suspicious events, you can use a filter to only look for processes besides SVC host. System Monitor will provide us with further details to help lead the investigation, such as the file path, the process originated from. To aid in detections, we'll use a custom configuration file. Below is a snippet of the config file, and we're going to open this, hunting LSAS and event viewer to view an attack using the obfuscated version of Mimikatz, and that's what that would look like in this case. And you see the call trace is a very, very long call trace. The target image was the LSAS image, and the source image is Mimikatz. And we have the source process ID. We can see that the event has the Mimikatz process access, but we also see a list of SVC events, and we can alter our config to exclude events with the source image event coming from SVC host. To look below for modified configuration to cut down the noise that is present in the event logs. And by modifying the config to include this exception, we've cut down our events significantly and can focus only on the anomalies. This technique can be used through the SysMon and events to cut down the noise in logs. And so detecting LSAS behavior with PowerShell works as such. So we're going to use get win event with the XPath queries, and we're going to use the same XPath in the rule to filter out the other process from target image. If we use this alongside a well-built configuration with a precise rule, it will do a lot of the heavy lifting for us, and we need to filter a small amount. So get win event, path, the path to the log, filter XPath, system event ID 10, and event data is going to be target image, and the event data is going to be this specific thing. So going through all of this combined with a good configuration file is what the action plan is to try to find Mimikatz. And I'm going to open up all of that stuff when we actually get to the practical investigation section of this. And so hunting malware is the next one. Hunting malware. Malware comes in a lot of different forms. The one that we're focusing on is going to be rats and backdoors. Rats is a remote access Trojan. To essentially, they're used to any other payload to gain remote access to a machine. Rats typically come with other antivirus detection evasion techniques that make them difficult, like using MSF Venom, for example. It typically uses a client-server model and comes with an interface for easy use administration. Some examples are ZZ, I think, Sexy, maybe, and Quasar. To help detect and hunt malware, we'll need to first identify the malware. And that can be done and then after that, we can modify the configuration files, and it's considered hypothesis-based hunting. There are, of course, a plethora of other ways to detect them, but we're just covering a few things. More of this can be found on MITRE ATT&CK, hunting rats and C2 servers. What we're going to do is we're going to hunt Metasploit first, and we can look through and create a configuration file to hunt suspicious ports on the endpoint. By using known suspicious ports, we can add to our hunting methodology, in which we can use logs to identify adversaries on our network, then use packet captures or other detection strategies to continue the investigation. The code snippet below is from the Ion Storm configuration file, and it looks for 1034 and 1604 as the ports, and it excludes common network connections like OneDrive. By excluding events, we can still see everything that we want without missing anything. So when using configuration files in a production environment, you have to be careful that what is happening with the configuration file is an example of this Ion Storm configuration, and it excludes port 53 as an event, which is DNS. And attackers and adversaries have begun to use port 53 as a part of the malware, which would go undetected if you blindly use this configuration file as it is, because it's the legitimate port for DNS. So what we have here is the rule group that the destination port is 1034, 1604, and the connection image condition is OneDrive exe, and that's pretty much the rule itself. So if we open the hunting rats log file, we'll be able to see that it's being dropped onto the server, and so we have the process ID itself, the image, which is Big Bad Rat exe, and it is on the source host right there, source port 52821. The destination IPv6 is false, destination IP is this, host name is that, and destination port is 8080, which is typically used for web servers. We're detecting a custom rat that operates on 8080. It's a perfect example of why you want to be careful when excluding events in order to not miss potential malicious activity. So this is a commonly used port by web servers. So if it's being run on that, it could, if you exclude by the 8080 port because you're like, oh, this is normal, you're going to miss this one. So hunting common back connect ports with PowerShell. We're going to use pretty much the same stuff, but now we're using network connect and destination port as our options. So excuse me, get when event path and filter XPath, event ID 3, and then the event ID data name is going to be destination port, and the data is going to be whatever the port is going to be. In this case, it is port 8080 that we're trying to pull from, and then that's what we see over here. So that was it for the basic instructions on detecting or hunting malware. So let's try to learn how to hunt persistence. Persistence is essentially a strategy for a hacker to stay on the system so they don't have to constantly re-exploit the system. What we're going to be focusing on is registry modification as well as startup scripts, and we can hunt persistence with SysMon by looking for file creation events as well as registry modification events. The config file Swift on Security does a good job of doing that, and we can also filter by the rule names in order to get past the network noise, and so on and so forth. So looking at Swift on security detection for a file placed in the startup environment and the start menu environment, this is the snippet of the code, and you can find it on the MITRE T1547. So this is the rule group, right? We're gonna target file name T1023 T1165. Condition contains the start menu startup, and if we open it and we go into that specific event, you'll see the 1023 rule has been gone off, and notepad is the image that's being executed, and the target file name is persist.exe. That is inside this long pathway right here, but it's inside the startup folder. And persist, I mean, it's very obvious that it's called that. So nobody's going to name their actual executable persist. So that's the other thing that we got to be careful about, because it's not going to be this obvious. So when we look at the specific thing, we can see that the rule name T1023 is right here available to us. So what we can do is we can filter by that inside the filter log, and it can be done by doing which specific item here. I think, let's see what the instructions tell us. So it says you can adjust the config file to be more granular and just a file create a tag. We can also filter by the rule name 1023, and so if we were to I guess look at what the event ID, is that what we're looking for over here? Once you have identified a suspicious binary and apply, you can begin an investigation on the directory. This piece right here, I don't exactly know why they brought this up, but this is what happens when you click on the filter, and it obviously looks like that they're filtering for the event ID 11, which means that the event ID 11 will only show up, and it's going to show SysMon, file created, file create for the rule, so on and so forth. So I don't know how that connects back to this particular section right here for the rule name T1023. So that's kind of annoying, but whatever. Hunting registry key persistence. So if we wanted to look at the registry key now, we can registry modifications that are placed script inside the Windows run portion and other registry locations. This is T1112 is the MITRE attack ID, and so this is what it will look like, where it will looks like it looks at these specific event IDs. Is that what? Not event ID, my bad. Rule name. Those specific rule names, and then the conditions that contain the current version run, the group policy scripts, and current version Windows run. And if we open that specific one, we see that that rule has actually been elicited under a run key. The image is regedit, the registry edit executable, and the target object is the persistence object. And the details are a malicious executable inside the system32 directory. So when you look at that, if you go under this actual path right here, so current version run persistence, we can also see that the malicious exe was added to this thing. We can also see that the exe can also be found in another place. So it was in two places, right? Just the startup technique, we can filter by rule name T1060 to make that finding the anomaly easier. And this specific registry path is the current version run, where you look at that and you see persistence sitting right there. So we have now done the hunting for persistence, and we can move on to detecting evasion techniques, and then jump into all the practical questions. Evasion techniques are a bunch of different techniques that basically attackers use to avoid being detected, as the name implies, to avoid antivirus detection, so on and so forth. Some examples are alternate data streams, injections, masquerading, packing, compression, recompiling, obfuscation, anti-reversing techniques, and there's a lot. What we're going to focus on are alternate data streams and injections. Alternate data streams are used by malware to hide the files from normal inspection by saving the file in a different stream apart from the data stream. So SysMon comes with an event ID to detect newly created and accessed streams, allowing us to quickly detect and hunt malware that uses ADS. Injection techniques come in very many forms: thread hijacking, PE injection, DLL injection, and more. We're going to focus on DLL injection and backdooring DLLs. This is done by taking an already used DLL that is used by an application and overwriting or including the malicious code with it. This is the codes, the specific identifiers with MITRE, and the event logs are going to be inside our attack box, but if you want to do it yourself, they're all attached to this task. So alternate data streams can be used with the Swift on security configuration file, and there's event ID 15. Will hash and log NTFS streams that are included with the SysMon config file. This will allow us to hunt for malware that evades detection using alternate data streams. So we're going to hunt for the temp and startup folder, as well as the HTA and BAT or HTA and BAT extension. And so this is what the rule looks like, and this is going to be inside the Swift on security SysMon configuration. And so if we open the hunting ADS log, we should see something similar to this in there somewhere. And so you have the process ID, the command line, the command terminal is what's being used as the image. The target file name is the not malicious.exe malicious one. And then this is the hash value of it for MD5, and then there's another one for SHA-256. And the content is, this is ADS. So if you go inside users THM threat and do a directory listing just so you can see what's inside it, we'll be able to see that the not malicious TXT and its correlation is all in there. So that's what it is, right? User administrator downloads, not malicious, so on and so forth. So that's kind of funny. The detecting remote threads would be done with the create remote thread. So remote threads are created using the Windows API create remote thread and can be accessed using open thread and resume thread. This is used in multiple evasion techniques, including DLL injection, thread hijacking, and process hollowing. We will use the SysMon event ID 8 from the Swift on security config file. The code snippet below is from the rule that will exclude common remote threads without including any specific attributes. This allows for a more open and precise event rule. So source image is this location and condition is this condition, and that's basically the rule. So if we open the detecting remote threads log, we'll be able to see this information somewhere in there, where you have the process ID, the source image, which is going to be PowerShell that's been used, and the process ID for the target right here, as well as the notepad for the target image, and so on and so forth. So this one kind of seems very inconspicuous. It doesn't even seem shady, but as you can see, PowerShell is creating a remote thread and accessing notepad. This is obviously a point of control, I think. I don't know if that's what that stands for, and could in theory execute any kind of executable or DLL. The specific technique used in this example is called reflective PE injection, and detecting evasion techniques with PowerShell using getWin event and the XPath filter and event ID. So getWin event path to log is going to be filter XPath, and event ID is right there. And so there it is. GetWin event path, user, analyst, so on and so forth. That's where the log is, and we're filtering for the XPath, and that's what we're going to find if we do that. So there is all of our basic documentation instructions for this, and from here we are going to look at the practical investigations. Alright, event files used in this task are inside this place, and they use those types of GitHub repositories. We can get those if we wanted to, or you can get them on your machine if you wanted to. Investigation 1 is build that's the wrong USB. So in this investigation, your team has received reports that a malicious file was dropped onto a host by a malicious USB. They've pulled the log suspected and have tasked you with running the investigation. That's in investigation 1. And investigation 2, another suspicious file has appeared in your logs and has managed to execute code masking itself as an HTML file, evading the antivirus detection. And we can open the logs and investigate. The third one is 3.1 and 3.2, so there's 2 pieces in here. We have your team has informed you that the adversary has managed to set up persistence on your endpoints as they continue to move throughout your network. Find how the adversary managed to gain persistence, and the logs are located here and here. Then we have, look, I built a botnet. As the adversary has gained a solid foothold onto your network, it has been brought to your attention that they may have been able to set up C2 communications on some of the endpoints. Collect the logs and try to figure out what's going on. So investigation 1 has 3 questions, investigation 2 has 3 questions, 4, 5 questions, 3.1 has 4, 5 questions, 3.2 has 4 questions, and 4 has 3 questions. Okay, so not bad at all. So first and foremost, we are now going to investigate this log right here, the investigation 1 EVTX log. Alright, we have our exercise file open in the event viewer, and we have PowerShell open just in case we can pull it off with PowerShell. So the first question is, what is the full registry key of the USB device that is calling SVC host in investigation 1? So, okay, so we're going to create a variable called the registry event, and it's a get when event command running on the path. I'm inside the actual investigations folder that's on the desktop and scenarios, and specifically dealing with investigations 1. And then so we pipe that into where the object ID equals 12, or the ID equals 13, or the ID equals 14, and the properties value is like SVC host exe, and then we're going to select whatever object comes out of that. So that's the first thing where we create the actual variable, and then from there, let me just make sure I enter that correctly. And from there, now we're going to go and find the specific event. All right, while that's running, I'm just going to open this up in the event viewer and see what we can find over here. There are only 11 items inside this log, so it shouldn't be too difficult to kind of parse through it manually and see what's going on. We have 11 event ID 13. That looks very sketch from the very get. And it, I mean, itself, it just seems so freaking sketch. So the image is in the registry, as we can tell. Control set enumeration, bus enumeration root, all of this just seems super freaking sketch. None of this is recognizable in my opinion. And then of course you have something called friendly name at the end, which is just, come on. So okay, that is, in my opinion, I think that's the actual answer. And this one was a little bit easy to find, so we're just gonna right click and see if we can copy that, and I'll just do Control C and then zoom out of that, and then let's go here and just paste that, and let's see if that's right. And that is the right answer. Okay, so what is the device name when being called by raw access read in investigation 1? So what is the device name? So we're gonna go into the details here and see what we can find, and I'm gonna pull this up now since we have our correct packet, and it's being called by raw access 1. So what is the device name here? And now I understand why I couldn't find it before, because I was looking at the wrong item. So it's actually being called by raw access read, which is event number 9 detected over here. So in one of these things we could probably find the device name, and look at that. So hard disk volume 3, that's probably it. It's either device hard disk volume, or it's just hard disk volume. So I'm going to try the full path first, and that's the right thing. So yeah, I was just looking in the wrong place. What is the first exe the process executes in investigation 1? The first exe that it executes in investigation 1. So process creation, network connection, process creation, process terminated. So the first exe, and that will probably be at this time. So this is the very, very beginning of this. So the first exe that was created would be the what is it, WUDF host would probably be that first exe. And as we go through this, we can also see that it is indeed the first exe file. So I'm going to take the full path just in case they need the full path, but I think it might be just it's just a short version of it. So we can delete all of this intro and see if this is the right answer. Oh, it's not. Okay. So what is the first exe the process executes in investigation 1? Let's see. Okay, so the run DLL32 was the one. So this is it's actually the one at the very, very top, and it shows under process terminated, which is the task category, which means that there was something that was executed. All these other ones are process created, which is not what it was asking us to do. So under process terminate, we can just assume that there was something that was ran, and the only other option would have been that, because everything else is either the WDF host or the SVC host, and from there we only found the one thing that was the DLL32. So now from here we can move on to investigation 2 and try to find the full path of the payload first, and so on and so forth. So let's find the full path of the payload in investigation 2. Okay, in this one there's only 3 items, 3 log items. We have the network connection detected, the process created, which has 2 of the same event ID, but there's 2 different payloads that have been injected, it seems, as the command line. So the very first one, which happened at 7:13:42 a.m. No, 7:13:42. Here we go. That's probably the one, because it happened immediately, and it seems to be there's 2 different things right here. So there's the command line of the system where it's located inside that, and then we have the execution right here. So I'm going to copy this one. I believe this is the answer for this thing. So let's try that. That is the answer. And now what is the full path that it masked itself in, which is this thing. So let's see if this actually is correct. That is not correct. Okay, so it says what is the full path of the file that masked itself as in investigation 2. This could be the parent command line. It could be the parent image for Internet Explorer. Let's see what we find in packet 3. The image is emish, and that one is not the right answer right here. So obviously I'm probably not doing the best version of this this research. I'm kind of doing trial and error, because I'm trying to see, and then I reverse engineer based on the stuff that I learned from the actual answer. So if I can see that it's actually being done, then that might be it. So it could mask itself as the SVC host, because we've established that this could be a very common thing that's being done, and that's not the case in this case. And so what we can do is we can just go back to the original log, which was this one, the original log item, and what I feel like might be the case would be the Internet Explorer option here, that it was used for that. So let's see if that's the answer, and that is not the answer either. So now I really have to do some research and see what's going on. So let's see. Okay, we were close. I was close. It's the command line injection right after this that is the mask for the downloads update HTML. That is specifically the answer that's been used as a mask, right? So this thing inside the quote was the original command that was injected from the command line, and then you have this thing that's after the fact that ends up being the mask for it that's covering it up. Okay, not bad. Figuring it out little by little, piece by piece. And so we have what signed binary executed the payload in investigation 2. What signed binary? So let's see that. Okay, so that one was the mshta.exe that was signed in the signed binary that was launched, and we see that under the image information of the packet, where we can go and try to find under the event data. And now the second to last question is, what is the IP of the adversary in investigation 2, and what is the port in investigation 2? So we're looking for the IP and the port. So that one is going to be under the network connection detected section, and it's the destination, so where this is going, right? So 10.02.18 will be the IP, and then 4443 will most likely be the port. So we have that, and then 4443, and there's that. Okay, great. So now we can move on to investigation 3.1. So what is the IP of the suspected adversary in 3.1? So let's open that up. All right, we have our third log opened up here, 3.1, and we're looking for the IP of the suspected adversary for this one. And based on the last one that we did, I know that we're looking for a network connection situation. So there's 3 that have been detected. There's the network connection details. So let's look at that over here. We have a destination IP of this on port 80, source IP on 54.921, which seems like this might be the situation. Okay, in all 3 of them, we have different ports for the source port, same IP for the source IP, and the host name is the local domain. But then what's interesting here is that we have Empire C2 as the destination host name, and if we were to look at the rest of them, it's the same IP as well, and it's being done on port 80, which is HTTP, and they're all going to Empire C2, which seems like a command and control name, as the name kind of implies. So we're going to try this one as the IP address, and that would be the right IP address. What is the host name of the affected endpoint in investigation 3.1? And so the host name is this thing right here. This would be the full host name, and I wonder if it's the full thing or if we just need the local domain part. But let's see if this will work. So it's actually the user that we're looking for. It's not the host name that we're looking for specifically. It does start with it, right? But then you have the very end, that last Q, the \Q that applies to the user itself. But this was the host name, just to be very clear here. But then they're looking for the user specifically for this answer. So we got that. And what's the name of the C2 server, which we already saw earlier? So it's Empire C2. And we're going to just copy this real quick and take it and paste that over here. And last thing is, where in the registry was the payload stored in investigation 3.1? So we're going to look for the registry right here. The specific task category that we're looking for is not object added, but value set. And there are 2 of them. And they are pointing to the target object of the software Microsoft network debug. And if we look at it, it only looks on the first one that the value has been set on that. The next one kind of gets a little bit further and it goes into the debugger, but we know that it's the very first one that we're looking for, and it's this thing right here. So target object value would be the debug, network debug that we're looking for. So let me try this thing. Okay, very good. And what PowerShell launch code was used to launch the payload in investigation 3.1? All right, out of all of our log items right here, we have the one that is, where was it? It was this thing right here that actually has a pretty hefty PowerShell command right here. That takes this whole thing, and at the very end, they even exit out. How considerate of them. So let's see if this is the one. And that is indeed the one. So, okay, so we're done with investigation 3.1. And now we can graduate to investigation 3.2. This one is a little bit more intensive because it has 24 events inside it instead of just a handful that we can manually review. So for this, I'm going to rely on PowerShell to try to find our answers over here. We might be able to find the IP address because I know that we're looking for network connections. So there's 1, 2, and just a handful at the bottom right here. So we can probably try to find it through the network connections and see if we can find that IP address of our attacker. Yeah, so with every single one of the network connections items under the destination IP going to port 80, there's this really funky AOL address right here, and then we have the destination IP that is feeding information out to it, and then we have, of course, our host being the source of the full thing. So let's see if this ends up being the correct address, and it is. What is the full path of the payload that is located in investigation 3.2, the full path of the payload that we're looking for? After the network connection was initially made in the morning right here, there was a pipe that was created and the pipe actually connected, and immediately after there was a process that was created. And if we go inside the command line execution of what was done, it's broken down into several portions, this command right here, and the very last thing is an output into a file. So this whole thing you see right here is not the actual output. This right here, this little arrow, is what you want to output something into, and so it would be output into this. So that's where it's going to be outputted into, whatever they're creating, and so that would most likely be it, and that is it. So what was the full command used to create the scheduled task? And this might be the entire command right here that was used to create the scheduled task. So let's see, process created, process terminated, pipe created, pipe connected, process created, and let's see what the command in this situation is. Is this a scheduled task creation? It's actually a little bit further up, and we are using the scheduled task system32 executable. So this full thing would most likely be the answer that we're looking for, where they're creating a scheduled task. And that is indeed the answer. And for 3.2, the last one is, what process was accessed by scheduled task that would be considered suspicious behavior? So what was accessed by scheduled tasks in this piece right here? And if we just go up a few more items inside our task categories, we'll see that there was a process accessed on a couple of line items, and immediately you see right here that this piece right here, from what we know so far, that this is what's used to dump security authentication and people's passwords and usernames and hashes and so on and so forth. Investigation number 4 has 13 events. They are all network connection events. So this one is a little bit tricky, and what they're looking for first and foremost is the IP address of the person that would be attacking, right? So the IP address of the attacker. So Empire C2 just stands out from the very beginning, and I'm just going to take a shot on my first shot with this just to see if that is indeed the IP, and it is the IP. And they're using port 80, and what C2 is the adversary utilizing in investigation 4? So what they're looking for is the actual C2. The only thing that I can find that would potentially be it would be either boot PC, which doesn't really seem likely, or it would be actually Empire. So if we just use that word Empire without the C2, that could potentially be the answer. So let's see which one it would be. Oh, it is Empire, just like that. So easy, straightforward. I will be the first one to admit that when you're going through a lot of log files, so as you just saw, it took me a good amount of time to filter through everything in here, especially if there is more than a few dozen items. So it's not the most practical version of finding the information, although it can be done. So that's pretty much the name of the game, is that if you have the ability to at least spot certain things, it can be done. And then as you're just learning the specific pathways and options to search for, right? The parameters to search for, the options to search for, you get more familiar with these things, and then from here you can try to find what the next step of it would be by creating PowerShell commands, searching for things like destination IP or anything else that you would want to search for. It's a good idea to first at least understand what these options are and what they're called, to go from there, because a lot of times I wouldn't know what to even search for, right? So that's the first part, is to familiarize yourself with these things so that you can actually know what you're trying to search for when you're creating your PowerShell commands. In this particular case, the log files were not gigantic, so it was practical enough for me to kind of sift and sort through them, and it would probably take me more time to try to find a way to write the PowerShell command and keep doing trial and error to try to find that, versus actually going through the log files visually through the GUI. So that's my justification of using the GUI, but it's one of those things that you got to get the result however you can get it. And fortunately or unfortunately, I can't really sit here for hours on end just trying to do trial and error to try to find these answers. So that's how I found them. If you find them using PowerShell commands, more power to you, no pun intended. I highly recommend that you keep doing that. This is something that I know I have to learn how to do better. So it's one of those items in my task that I need to just get much better at, to use PowerShell to try to search through the system using, I think it was get win something. See, I even forgot the command itself. But at the very least, we were able to get the answers and get win event. That's what it is. We were able to get the answers and we were able to complete this room. If you got any value from this video, if you learned anything, if it made your life a little bit easier, or if you just want to show support, it would mean the world to me if you could like, subscribe, turn on the notification bell, and of course leave a comment, because that helps us with the YouTube algorithm and we can get more reach and expand the community and grow the channel, so on and so forth. I would sincerely, thoroughly appreciate that. I respond to all comments as they come in, so if you drop a comment and you have a question, or if you just want to say hi, I will definitely respond to you, and I will continue to do that until it gets so unmanageable that I personally don't have time to do it, which I don't think it's going to happen anytime soon, unless, I don't know, we blow up for whatever reason. But until then, I will be more than happy to answer your questions, to acknowledge your comments, and to just hit you back up if you drop a comment. But that really would mean the world to me if you could like, subscribe, turn on the notification bell, and comment. And of course, if you turn on the notification bell, you get notified when a new video comes out, either inside the path for SOC analyst or inside the path for penetration testing and ethical hacking. So this was the room for SysMon, the system monitor, and yeah, we're wrapped with this one, thankfully. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite system and network attacker, and I look forward to seeing you in the next video. Hopefully you enjoyed this one. Peace, love, and chicken grease. If no one else loves you, Hank loves you. See you in the next room. All right, hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite system and network attacker. And today we are going into OSQuery, the basics. And OSQuery was mentioned in one of our previous rooms, in one of our previous videos. It's a part of the Endpoint Security Monitoring module of the SOC Level 1 pathway at TryHackMe. And we talked about it, I don't know, it was probably like the intro to endpoint security where we talked about it a little bit. And it's something that's been developed by Facebook, as you'll see in a little bit. All right, before we start the module, quick little notice. If you find any value from this, or if you've ever found any value from my channel, or if you learn anything from it, so on and so forth, it would mean the world to me if you could like, subscribe, and turn on the notification bell, and even drop a comment. Every single one of those activities will actually help with the YouTube algorithm and help us gain more reach so that we can grow this community and help educate more people. That's the only thing I ask from you, and it would just mean the world if you could actually show your support in that manner. If not, it's all good. Even your viewership means a lot, and it does help, but if it really would help if you could like and comment and subscribe and turn on the notification bell. And obviously when you turn on the notification bell, you get notified the next time a video comes out. So if you're studying for a cybersecurity analyst position, or if you're studying for ethical hacker, all that stuff, all these videos will actually help you in your path. So that being said, without further ado, let's jump into the introduction of the room. All right, OSQuery is an open source agent created by Facebook in 2014. It converts the operating system into a relational database and allows us to ask questions from the tables using SQL queries. So it's very similar to SQL databases, like returning the list of running processes, a user account created on the host, and the process of communication with certain suspicious domains. It's widely used by security analysts, incident responders, threat hunters, etc., and it can be installed on multiple platforms, probably the one that you're even on too. What we're going to learn about in this room is going to be the what it actually is and what problem it solves, the interactive mode of OSQuery, how to use the interactive mode to interact with the operating system, and how to join two tables to get a single answer. So it's pretty much an overview kind of a room, and you'll learn some good basics about it, and then we will go into further stuff in future rooms and in future videos. All right, connecting with the lab requires that we start our machine right here, which we already did, and it populates the IP address for me. And just from the piece right here where it says we're going to get a PowerShell terminal, I'm guessing it's a Windows machine that we're going to be working with. And so that has been completed, and it's pretty straightforward, so I don't think we need to do an entire dedication to this, and we can jump into OSQuery interactive mode. And the interactive mode is, I guess, one of the many ways that we can interact with OSQuery. We can open a terminal and run OSQuery I, and then to understand the tool, you just type .help, .help command is what it seems like. And then so when you do that, it goes from the specific user account that you're in, and it immediately shows the OSQuery terminal, and then from there you can input all of your OSQuery commands. And we can list tables by using .tables. You can list the process associated with the table by using .tables process. We can list all the tables with the term user in them, so .tables user, and it will show the tables for that user. Or the user, the tables that have the term user in them. And what else do we got? The table schema. Table names are not enough to know what information it contains. You have to actually know what to pull from the column, and then the individual data inside the columns and the rows and so on and so forth. So the knowledge of columns and types, known as schema in this context, which is, I don't think that's consistent to the overall SQL language. I think it's more consistent to the OSQuery language. It would be .schema, and then you give it the table name. And then so .schema users will give us the creating the table users with these UIDs and UID sign and all of these different things that are inside it. The above result provides the column names like username, description, PID, followed by respective data types, big int, text, integer, etc. and we can pick a few columns from this so we can see what's inside them. So we can do select column 1, column 2, 3, and then from table, and it will give you that information from the individual table. And so OSQuery I, and then select GID, UID, description, username, and directory from users. That's the command right here. So you don't do column 1, column 2, column 3. You literally have to say select GID, UID, description, yada yada from users, and then it'll spit that out for you onto the screen like this. And then we have the display mode, that if we press .help, it'll give you more information about it. And the display mode can be done in a few different versions. So the CSV version, column version, line list, and pretty, which is pretty printed SQL results, which is the default typically, which is probably what this is, what looks like over here. So the questions here says how many tables are returned when we query table process. So that we will need to open up the actual machine and query OSQuery. All right, we start PowerShell and we do OSQuery I, and it should open up OSQuery in interactive mode. And the command that we're looking for is going to be table process, I guess. So when we query table process in their interactive mode, and that'll give us OSQuery, and then we do .tables process, and it gives us 3 tables as a result here. So the answer to this question should be 3. Very good. Now looking at the schema of the processes table, which column displays the process ID for a particular process, for the particular process? So looking at the schema for the processes table, which is our 3rd table. So what we want is .schema, and we want the table name, which is processes. And there's a lot of responses here. So what we want here now is the ID, which column displays the ID for the particular process. I'm going to venture a guess that it's going to be the PID. So if I actually pull that from it, so if I say select PID from table or from processes, and holy shit, look at that. We have all the PIDs, and then that's the process ID. So maybe a better name would be to do PID as well as the process name. So name right there. So PID and name might be a good idea. So we'll do select PID and, or no, not PID and. We'll do select PID name from processes. And then there we go. Now we actually have the PID as well as the name of the process next to it. So that's what it'll be like. And you got to make sure that you put that semicolon at the very end of it. So the looking at the schema of the process table, which column displays it? It's going to be PID. And examine the .help command. How many output display modes are available for the .mode command? So let's go to .help, and we're going to look for .mode, and it says the output is 1, 2, 3, 4, 5. So there's 5 different outputs for .mode, and there it is. Now moving into the schema documentation, and that's the image itself. So for this task, we're going to look at the documentation of OSQuery 5.5.1, which is the latest version. The schema documentation looks like the image shown below. And so if we just open this up in a new tab, it should look just like that. And then we have the 274 tables, and there's a lot of different options under the tables right here. And then under that, or on this main page, it looks like we're going to see, oh, I see. So it just goes to the actual table itself, depending on which one to click. It's all one page. It's a one page. Got it. Okay. So very good. So these are all of the tables that we have over here, and there's 274 of them. Over here it says 106. So ever since the creation of this room, there's definitely been several new tables that have been added to this. And so we have the number of tables, the table name itself, that's the current version that would be on, compatible with Windows. So this particular situation, maybe that's what it is. So if we do compatible with Windows, there you go. It'll bring it down to 106 for us. And so 551 Windows, and now we have 106 tables. And so the then app compat shims, whatever that is, app compatibility shims are a way to persist malware. Then we have the column that is inside of it, the type of information that's in it, the type of data that's in it, and then the description. And the breakdown would be as such, although I feel like we don't really need that much of a breakdown. But so drop down list with various versions of OSQuery, choose the version of OSQuery you want to see, number of tables within the selected version. I mean, so this is what all of these things are. And we already saw all of this, so we know exactly what's going on over there. And show only tables compatible with Windows, we already did that. And now we have enough information to navigate. So in OSQuery version 551, how many common tables are returned when we select both the Linux and Windows operating system? So if we go here and do Windows and Linux, we should get a combination, right? So it should only be 56 that apply to both. In 551, how many tables for Mac OS are available? So we just turn this off and turn Mac only on, and that would give us 180. And in the Windows operating system, which table is used to display the installed programs? So we're gonna go to Windows, and then I'm just gonna search the page for installed programs. So Atom packages is list all Atom packages that are installed. So installed, let's see, programs, is that a term that'll show up? No. So if I do programs, come on, programs, there is one, and then there is right here. It's actually called programs. So that's the table that's going to show us the number of programs. Very good. And in Windows operating system, which column contains the registry value within the registry table? So in this Windows, so we have to go to registry. So we're gonna search for registry, and it shows, what does it show? We want which column contains the registry value within the registry table. So name of the registry value, type of registry value, data content of the registry value, and then timestamp of the registry. So the name of the registry value or the actual value itself. So it would either be data or name, right? It says which column contains the registry value within the registry table. I would say it's data. Yeah, there you go. So there you go, we got that. Pretty easy navigation, and it's actually very, very user-friendly, very helpful. I am quite impressed by the developers at Facebook, or AKA Meta. You would think that these guys know what they're doing when they're building something, right? So it shouldn't be surprising that they are good at building something helpful and useful. So moving on to creating SQL queries. All right, the SQL language implemented in OSQuery is not an entire SQL language that you might be accustomed to, but rather a superset of SQLite. So realistically, all your queries will start with a select statement. This makes sense because with OSQuery, you are only querying information on an endpoint. You won't be updating or deleting any information, which makes sense. The exception to the rule would be using other SQL statements such as update and delete is possible, but only if you're creating runtime tables, which is views, or using an extension of the extension that supports them, if the extension supports them, excuse me. Your queries will also include a from clause and end with a semicolon, which we've already established. So if we look at the schema for programs, and select whatever from programs limit 1 will look like this, right? Select everything from programs limit to 1, and it's going to only give the very first output of everything. So name, version, install location, but it's only giving us out of the first one. The limit was used by a number to limit the results to display. Your results will be different if you run this query in the attached VM or the local machine. The number of columns returned might be more than what you need. You can select specific columns rather than retrieve every column. So name, version, install location, etc. from programs limit 1, right? So it would only give you name, version, install location, and install date from programs. So the count query, so select the count from programs, and it says 160. It shows how many programs or entries in any table are returned, and so we can see how many there are. And so if we do that, that means there are 160 actual results that we can pull from inside the programs table. Select everything from users where the username has James. So it brings all of the information about somebody whose name is James, and that is pretty intuitive as well. The equal sign is not the only filtering option in a where clause. Below are filtering for operators that used in a where clause. So equal, not equal, greater than and equal, less than and equal, between, that's nice, like, okay, and then wildcard multiple characters, underscore would be wildcard 1 character. So matching wildcard rules. So this is from the OSQuery documentation showing examples of using wildcards. So match all files and folders for one level, match all files and folders recursively, meaning go through everything inside of that directory or that program. Match all within the level ending in ABC, and then match all within the level starting with ABC, right? So if you do this first, that means it ends with this, and then if you do the characters first and then percentage signs afterwards, that would be everything after that should match with it. So matching examples would be users percentage library. So show for every user's library, but not the contents within. Now you do users percentage library, and then you put that / at the end, and it shows for changes to files within each library folder, but not the contents of their subdirectories. And then you have the percentage after the fact, which changes to files within each, so it actually is now looking at the files inside of the directory. Now we have to, which means recursively within each directory, it goes through everything. And then bin percentage sh would be monitor the bin directory for changes ending in sh. So some tables require a where clause, such as the file table to return a value. If the required where clause is not included, then you will get an error. So in this situation, it says select from file, and then table file was queried without a required column in the where clause. So it would mean that we would need to do select something from file where the something or where the file is something like that. Joining tables using the join function. So schema users, so this is the users table, schema processes, that would be the process table. And then now we can combine certain things. We can join certain things from these two tables. So looking at both of them, we have UID and users. That's meant to identify the user record, and in the process table, the column UID represents the user responsible for executing the particular process. And we can join both tables using the UID field. So select UID, PID, name, path from processes, select UID, username, so on and so from users, and the join query would be select P, PID, so processes PID, P name, P path, and then U username from processes, and then P join users U on U UID equals P UID limit 10. So you want to select the PID, the name and path from processes that's been established as P for the variable of it, and then you want to select the username from users that's been used as the U variable, and then you want to join them. So join from processes P, join users U on U, UID, P, UID, and then limit 10. So what that would look like is that would give us the PID and the name of the PID, the path of the PID, and the username that ended up using it. And so you pull it from the users as well as the processes table. For more information regarding SQL and creating queries, we can visit the documentation. So using OSQuery, how many programs are installed on this host? So we can pull out of this right here, and let's do can I do clear screen? Would that still work? No, it doesn't work here. So I need to close that out, do clear screen, and then from here I'm going to do OSQuery I one more time, and it will put me into OSQuery. And so now I want to see programs, right? Is that what they're asking for? How many programs are installed on this host? And I think I can just do, what is it? Schema, programs, and then there's a count. There was something that gave us something about count. So right here. So instead of actually being schema programs, what it's going to be is that it's going to be select count. So select, I think it might need to be caps locked. Why is my caps lock not working? Select count from programs and do that, and it will give us 19 as a total count. So we can just do that right here. And then using OSQuery, what is the description for user James? So we can see just from here that under the schema for users, there is a description column. So what we're going to do is we're going to say select everything, or select description, probably. Select description from, and maybe from needs to also be caps locked. So select description from users where username equals James. Let's see if that works. There we go. So select description from users where the username equals James. And so the description for James is a creative artist. And when we run the following search query, what is the full SID of the user with RID 1009? So if we take this full thing, the query, select path, select doesn't need to be caps locked because they don't have it. So select path and key and name from the registry where the key equals HKey users. So let's see. If I just do a copy of this, I can probably do Control V in here. Can I do Control V? Oh, I thought I could. Okay, so I got to type it out. 1 second. All right, there we go. And so the one that we're looking for is RID 1009. And it says, what is the full SID of that person? So if I kind of expand this, it should give me a little bit more. And the SID. So I'm going to say that this is the SID. And from there, we could do Control C. Hopefully it doesn't kick us out. It didn't kick me out, so that should be fine. And there it is. Okay. So that is indeed the SID. So it's basically everything after the HKey users, but there's also a path right here, or a column called name. And so that's what it is. And so for the registry, since we're using the registry table, and name in that case signifies their SID. Now when we run the following search query, what is the Internet Explorer browser extension installed on this machine? So we're going to use this. Well, I can't copy paste, so I have to type it out. So select everything from IE extensions, and it's asking for what is the Internet Explorer browser extension installed on this machine. So we have the Microsoft URL search hook. I'm guessing that's what it is. and then that's the registry path, and then that's the version number, and that's the path itself. So Microsoft URL search hook. Let me see if I can Control C on this and come back out here. Oh no, it's asking, so it's asking for the path, I guess, right? Because it said, what is the Internet Explorer browser extension? What is it? So it's not saying where is it, but based on the response that we got here, it seems that we want the path itself. So it's going to be this right here. And there is that. And after running the following query, what is the full name of the program that has been returned? And it seems like we're looking for Fireshark, but the full name of Fireshark. So let's see what I can do here. And there we go. So Wireshark 3.68 64-bit is the name that we are pulling from this thing. And that's pretty much it for our creating SQL queries. And we can now just go into the challenge and conclusion portion of this and see what else we can find. So first we need to find the table that stores evidence of process execution in the Windows OS. So the which table stores the evidence of process execution in Windows OS? So we're in Windows, and I'm just going to do a search on this thing, process. Let's see what we can find. Execution. That's not a thing, so I can just do execution. And we have a few things. So this is the tracks application execution. Let's see what else I can find. This is for tracks when a user executes an application. This is for artifacts of execution. And what else do we have here? Shows metadata related to file execution. And maybe this thing, is this process execution? The query is scheduled in OSQuery schedule. And what else we got? Discovery execution, current packs, and we got speculative execution and application execution. So we're back to that. So I wonder if it's processes maybe? Would it just be processes? If I click on that, all running processes on the host system. I'm just going to say that because the word execution isn't anywhere in there. So we're just going to do processes as our answer and see what happens here. Oh, that's not it. So evidence of process execution in Windows OS. Okay, so if we replace process with application, then this might be something that might be useful to us, which is the user assist table. And so let's see if that is the answer here, and it is. Okay, so one of the users seems to have executed a program to remove traces from the disk. What is the name of that program? So if we do select everything from user assist, we'll get a bunch of stuff. And from here, we need to kind of just look at what we can potentially find as the, what is it? Removes traces from the disk. So it's, I think it's, it might be disk wipe or something, but so these are all of the stuff in user assist, and it's right here. So it's called disk wipe. So disk wipe would probably be the answer to that. And we got it. So create a search query to identify the VPN installed on this host. What is the name of the software? So we're trying to find the VPN installed on this host. Okay, so we have the name, the version, the install location, install source, publisher, so on and so forth. These are the things that are installed in the table programs. Now, in the table programs, we're looking for something that might be VPN or is like VPN. And I think the query says that we can use like in it. So let's see if we can find that. I saw it earlier. Yeah, so there we go. So This is kind of the previous query that we used down here, where it shows select name install location from programs where the name is like Wireshark. And so what I'm going to do is I'm going to pretty much duplicate that. Name install location from programs where name is like, and we'll do VPN. And we have a few actually. So we have Proton VPN tap, tune, and then another one that's called Proton VPN. So it says what is the name of the software, so it could be Proton VPN probably. There we go. How many services are running on this host? And so let's see if we can get a count of these services running on this host. Select count from services, and that gives us 214. So we did a select count from services. That one was pretty straightforward. And let's see if that's the actual answer though. 214, that is right. Okay, a table called AutoExec contains the list of executables that are automatically executed on the target machine. There seems to be a batch file that runs automatically. What is the name of the batch file with the extension .bat? So similar to the other one. So select name and install location from AutoExec where name is like, and we'll do %.bat and then close that out and then semicolon, and it says name. What do you mean? I didn't do from. Okay, so select name install location from AutoExec where name is like %.bat. No such thing as install location. Okay, so select name from AutoExec where name is like %.bat. All right, so we got bat startup .bat. Those are the only things that showed up, and I'm guessing that's what it is. Bat startup.bat. There we go. And finally, what is the full path of the batch file found in the above question? So what we want is path. So what I'm gonna do, I'm gonna just include path as one of my search parameters, guessing that it is one of the columns where name is like bat and the name is like bat, like that. And let's see if we can get path out of there. All right, we got two of them. So what is the full path of the batch file? Got two paths here. So let's try the first path and see which one. If it's this one. Nope, that's not the right one. So I'm gonna say that it's this one. And that is the one. Okay, so we were able to find it. Pretty intuitive, pretty useful tool. I like it a lot actually. And that's it for this room. We were able to wrap the room for OSQuery, which is actually very helpful. And they even had an instructor video at the very top that we could have used, but I was able to find the information for the most part with a little bit of trial and error. And trial and error typically keeps, like, it helps you learn better instead of just looking up how to do something. So that being said, we have now wrapped the OSQuery room. If you learned anything from this room and if you got any value out of it, I encourage and invite you to please like, subscribe, and turn on the notification bell, and even drop a comment, because it helps the YouTube algorithm find our channel and get us a little bit more exposure so that we can grow the community. But this probably the more important one is that when you subscribe and turn on the notification bell, you'll get notified the next time a video comes out. So if you're studying to become a cybersecurity analyst, or if you're starting to become an ethical hacker, you get a lot of good information out of this channel. and it ends up being a win-win situation for the both of us. So I invite you to like, subscribe, share, turn on the notification bell, drop a comment, all that good stuff, just so we can be in each other's lives, basically. And yeah, that's pretty much it. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite system and network attacker. And that was it for this video. Peace, love, and chicken grease. If no one else loves you, Hank loves you. I will see you in the next room. Peace. All right, hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite system and network attacker. And in today's video, we're going to be going through Wazuh, or Wazuh. I think I like calling it Wazuh better. Wazuh is a free open source enterprise ready security monitoring solution for threat detection and integrity monitoring. This is a part of the Endpoint Security Monitoring pathway for the SOC Level 1 pathway of TryHackMe. So Endpoint Security Monitoring module of SOC Level 1 pathway. And we are on the last step of this, the last room, which is the Wazuh room. And yeah, we are going to jump into it. This is actually a free room, which means anybody can do this through TryHackMe for free without a paid subscription or anything like that. Although their paid subscription is actually very affordable, and if you use the link in the description below, it'll give you an extra $5 off. So that is it. One quick note: if you learn anything from this video, if you learn anything from my channel, if you find it useful at all, or if you're entertained in whatever way, it would mean the world to me if you could like, subscribe, turn on the notification bell, and leave a comment. All of those things help the YouTube algorithm find our channel and help us grow so that we can expand the community and help more people like yourself get information about cybersecurity analysis and ethical hacking. And if you turn on the notification bell, obviously you'll get notified the next time a video comes out. And if you're studying to become a security analyst, or if you're starting to become a ethical hacker, then all of these videos will be very useful to you as well. So it's a win-win situation. And without further ado, let's go into the introduction of the room. The introduction of Wazuh is like this. So we're going to be using the Wazuh EDR software solution. We'll be learning what an EDR is and why they are useful, where an EDR like Wazuh is used, accessing Wazuh, navigating Wazuh, learning about Wazuh rules and alerts, digesting logs to view specific events on devices, including Linux and Windows, and how we can extend Wazuh using plugins and the API. And if we understand what an EDR solutions are exactly, which is endpoint detection and response, which is a series of tools and applications that monitor devices for activity that could indicate a threat or security breach. These tools and applications have features that include auditing for vulnerabilities, proactive monitoring, visualizing complex data, and recording a device's normal operating behavior to help detect anomalies. So to establish that baseline so that you can detect anomalies. In 2015 is when it was created, and it's an open source, free, available EDR. It can be used in a lot of different environments, and it operates on a management and agent module. Simply, a device is dedicated to running Wazuh, which is the manager where Wazuh operates, and the agent where it's responsible to managing agents installed on the device, so that you would want to monitor. So you have the manager, and then you have the individual agents that are going to be on the different endpoints. So that's basically what it kind of looks like, a visual representation of this, right? So our first series of questions for the introduction, usually introductions don't have questions, but the first question is, when was it released? And that is 2015. What is the term that Wazuh calls a device that is being monitored for suspicious activity? That would be the agent. And for the device managing devices, that would be the manager. So we have achieved the introduction, and we're done with the introduction. Let's jump into what's required to deploy the Wazuh server. This is pretty straightforward. In this particular case, all we need to do is just press this start machine button, and it takes about, I would say, a minute to start up here. And when we connect to the network, we can deploy the Wazuh management server that's attached to this. However, typically you would need to actually install this on your own machine. So it is a little bit more complex when you want to install it on your own machine. If you load the management too early, it'll say that Kibana server is not ready yet. So we'll wait a few minutes before we do that. And we're just going to wait until this full thing is done. And it's this piece right here that will actually populate and give us an IP address. And once it's started, these are our login credentials. And we'll be able to get into the Wazuh server, and we're going to select global talent and refer to the animated GIF, whatever. And we're going to be working inside of the global talent portion of Wazuh. The questions in this task in this room will expect data to be stored on this management server, so it's vital that you're able to connect to it before continuing. So I will make sure that we're all good and the IP address is already loaded. So I'll make sure that we're all good before continuing and moving on to the rest of these tasks, so on and so forth. So, all right, while this 5 minutes that we gotta wait kind of continues to load, I'm just gonna read through this portion for Wazuh agents. And so as we've established, these are the devices that record events and the processes of a system. They monitor the processes and events that take place on a device, such as authentication and user management, and agents will offload these logs to a designated collector for processing, such as the Wazuh manager, right? So in order for Wazuh to be populated, agents need to be installed onto the devices to log such events. So Wazuh can guide you through the agent deployment process, provided so you fill out some prerequisites such as the operating system, the address bar of the Wazuh server that the agent should send logs to, and it can either be a DNS or an IP address, and what group the agent will be under, and you can sort this through a lot of different groups. So this is kind of what it looks like. You would click on Wazuh, click on agents, and then deploy a new agent. And then once we navigate to that, we're going to choose the operating system that it's going to be on, the address of its the Wazuh agent specifically. And so it could be wazuh.thm, for example. You can predefine the Wazuh server with the enrollment.dns app setting, and then you can assign the agent to a group and install and enroll the agent. And in order for that to work, we need to run this command on a host with an agent already installed, we need to run this command to enroll the Wazuh agent. If you run it on something that's already installed, then what it's going to do is just going to upgrade the agent package without enrolling the agent. So to enroll, we need to look at the Wazuh documentation, but this is basically the command. And the way that it is written from the very, very top, we can see that it's actually a Windows command, because invoke web request is a PowerShell command. And so if we wanted to do it on Debian or Debian Ubuntu, we would choose the architecture. Same thing for the address and the group assignment, but then the only thing that changes is the command changes from invoke web request to a curl command, and essentially does the same thing. So we just want to make sure that we're on this thing. I feel like it's still not fully ready. I'm going to try it. We'll try it and see if it actually loads. And I feel like it still hasn't been a full 5 minutes yet, but we'll see. And then we're going to go to the agents tab and go to Wazuh agents. How many agents do we have in our server to manage, and what is the status of the agents by this server? So for this, I actually really do need this thing to actually fully load. So now I'm going to just rest here, I guess, and give it a few minutes more so that I can finalize and populate. And then from here, we'll answer the questions and go into the rest of them. Okay, so what I just learned is that you can't actually load it on your own machine unless you are connected to the VPN of TryHackMe. So what I did, I just started the attack box, which is it's like a blue button that shows up at the top of the screen that says Start Attack Box. And then so you click on that, and this takes about 2 minutes to load. And then inside this, there is a browser, so a Firefox browser, and then you just open up the Firefox browser. And from there, we can go into this IP address that is the login for Kibana Wazuh, right? So from here, now I need to actually get the login information one more time and log into this. And then from that, we should be able to run the rest of our exercises. So here we go. All right, we are logged in to our Wazuh application. It is now loading the Elastic for us. And the first thing that we want to do is we want to go to agents. So you click on this thing right here, and we could just go to agents or the overview. And let's see, it says it right on the screen. So I mean, we can literally just see that there are 2 agents right on the screen. So that was going to be our first answer. And then if we click on the agents, it'll load the actual agents themselves. And the status of the agents, if we kind of zoom in here, we can see that they're both disconnected. And then if you scroll down to the bottom of the screen right here, we can see some more details about the agents. So the agent 01, THM domain controller, the IP addresses, and OS systems, so on and so forth. So just to make this a little bit more user-friendly, I'm actually going to open this up in a full screen, and then I'm just going to have my questions be on my second monitor here, and then we'll go through everything basically in the full screen view because it just seems a little bit easier. And then even at the bottom right here, we have that their status is disconnected. So the answer for the status of our agents is going to be that they're disconnected. So the next section is going to be the Wazuh vulnerability assessment and security events. And I'll just shrink this down and we can move on into vulnerability assessment and security events. All right, so vulnerability assessment is a module that is a powerful tool that can be used to periodically scan an agent's operating system for installed applications and their version numbers. Once you have this information, it sends it back to the Wazuh server and compares it against the database of common vulnerabilities and exposures. To discover potential vulnerabilities, for example, the agent in the screenshot below has a version of Vim, which is a text editor inside the command line, that is vulnerable to CVE 2019-12735. And so it shows it right here, and this is the information right here. And it says vulnerability severity. It is a high vulnerability severity, and that's the vulnerability number. And this is just some information about, the vulnerability references, the vulnerability rationale, and so on and so forth, right? So that is useful information to have. And it'll perform a full scan when the Wazuh agent is first installed on a device and must be configured to run at set intervals afterwards. So by default, it's set to run every 5 minutes when enabled, like this. So vulnerability detector, it is not enabled currently, but the interval would be 5 minutes. So you would turn the enabled into yes, and then it will run at every 5 minutes, and so on and so forth. So it's capable of testing an agent configuration against certain rule sets to check for compliance. However, out of the box, it's arguably sensitive. So this Linux host is running the Wazuh agent. There have been a total of 769 events occurring that the system performs as part of its daily maintenance. And these frequent actions, such as removing files, are often detected as a security event. These events and the related severities are determined by the Wazuh rule sets, which is something that we'll come to explore. We can analyze these events individually by clicking on the drop-down, and you can sort events based on various factors such as the timestamp, tactics, so on and so forth. So we are connected to this, so we can move on, and we're going to go to the Agents tab, Wazuh Agents, like so, and then select the agent named Agent 001, and how many security event alerts have been generated by Agent 001. We'll need to make sure that the time range includes the 11th of March 2022. So we are on the Agents tab right here. We're going to go to Agent 001, and it includes March 11, 2022. Last kept alive is March 11, 2022. And so right now it says 113 failed events. And what was the question? The question was it failed events or how many security events? So we're looking for security events altogether. And so event count evolution, the pass fail total checks is 192. So I'm gonna guess that it's 192. Registry date is March 11th. The last kept alive is March 11th. So the thing that we want to do is we want to do I guess I'll just do last year entirely just to see, make sure all the data is all good. So, I mean, it seems that the number is going to be 192. That might be security events in general, but then there's 113 that were failed. So it could be either of those two numbers. So we'll start with 192, and that's not it. So 113 should be it. That's not it either. So, okay, so we're looking for security events. That's interesting. I thought that maybe it would be a little bit more. Oh, you know what? My bad. You see, there's something called security events. So we click on security events first, and security events is going to pop up. It says nothing. There's nothing here. So for the time range that we have, so let's do show dates a year ago until now. All right. So I basically modified the timeline right here. I clicked on the actual time thing and I went to absolute and just went all the way back to March 2022 and clicked on March 4th because we want to include March 11th in there. And then I did from then until now. And then I click refresh and it gave us the number, which is 196 total. And that is indeed the right answer. So we got that part done. So we're all good with this. And now we can move on to the next step, which is going to be the Wazuh policy auditing. And I'm just going to refresh the page just so all of our answers show up, and there it is. And so here we go. Wazuh policy auditing. Wazuh is capable of auditing and monitoring an agent's configuration whilst proactively recording event logs. When the Wazuh agent is installed, an audit is performed where a metric is given using multiple frameworks and legislations, such as NIST and MITRE and general data protection, all that stuff. So for example, agent DC01 scores against MITRE, NIST, and SCA. This is the scores. And this seems to be on the general tab, I guess. Yeah, so it seems to be on the general tab. It has its compliance, right? A MITRE right here, and top tactics, so on and so forth. And then what else do we got? SCA, which is right down here. And that is basically it. I don't know where this is MITRE, SCA, and then it's for NIST. I want to see where the NIST one is. But there's compliance. There's this little drop down right here that allows you to change that, and we'll just test all of that up. So these frameworks are outlined in the pen testing fundamentals, and I think we already did videos on that, so you're more than welcome to search for those and find them. Wazuh presents a board illustrated of the logs where we can get the visualizations to break it down, and we can do this for the same agent that we were just on, which is agent 001. In this example, they're doing DC01, and the benchmark for this domain controller running on a Windows server. This is what it looks like, and so we're going to answer the questions here. So it says navigate to the modules by clicking Wazuh, and then modules, and then policy monitoring. And so we're going to do that. So we're going to go Wazuh, modules, policy monitoring. And that's all we have to do for this task. So let's now move into the second portion of it, which is going to be monitoring logons with Wazuh. Wazuh's security event monitor is capable to actively record both successful and unsuccessful authentication attempts. The rule, with an aid of 5,710, detects attempted connections that are unsuccessful for the SSH protocol. And we could look at this animation for further information right here. So it'll say the MITRE technique was brute force. Tactic, credential access, the full log is right here. The location of it is over there. And it kind of shows us all of the details on it under the table itself, right? So it gives you that information. The alert was created because someone tried to log on to the agent at this IP with the user cmnatic, which does not exist. And we have the alert of it over here. This is kind of just an overview. So you have the agent IP, agent name, the description of the rule, the MITRE technique that was used, the MITRE ID, and the rule ID, and then the location of the log. And so that's kind of basically it, right? Then we have for reference, this is what it would look like if we were to look at it in the command line. So it's stored in a specific file on the Wazuh management server, which is going to be in this place if we're running Linux, which we are actually running Linux. And we can use a command such as grep or nano to search through it. So if we do sudo less this whole thing, which brings us essentially the top of the file, it'll show you what it looks like. And this is, I mean, it's a general log file, so you can kind of see nothing crazy. But login session opened. It's kind of an important thing to notice over here. And then looking at the GIF one more time below, it says Windows logon success is the rule description for this. Valid accounts is the rule, or the MITRE, I think that was the MITRE technique or something. But, you know, we scroll down with this thing, and we have the rule description as it says, and then you have, it goes a little bit further down, and it goes to MITRE technique, which is valid accounts, and it goes even further down, and it's going to show you the location and everything else. This is what it looks like if the number of Windows agents and alerts triggered to show how many times a user has logged on. In this case, it narrows down to the logon events of 285 to 79, right? So it goes from a total of 285 events that had shown, and it brings it down to 89. And so you add filter and then type logon, and it says, what is it? Which one did they choose? With event logon, I guess, and exists. So they said that's event logon exists, and it shows a total of 79 out of the 285. So now that we are here, we're going to go to Wazuh Management Administration to check out the rest of it. So let's actually check ours out, but ours doesn't really seem to have anything. So if we go to the events under this, yeah, there's nothing under here either. So now we're going to go to Wazuh Management and Administration. And did they say what part of administration? No, it just says administration. And I would have to choose a specific thing. So let's do administration rules. And then from here we can see what else that they show us. But it seems that we should be able to click on administration, but I couldn't do that. So anyways, now we are going to move on to collecting Windows logs with Wazuh. All sorts of actions and events are captured and recorded on a Windows OS. This includes authentication attempts, networking connections, files that were accessed, the behaviors of the application, so on and so forth. And it's all stored in the Windows event log using SysMon. And we just did a video on SysMon, the system monitor. We can use the Wazuh agent to aggregate these events recorded by SysMon for processing to the Wazuh manager. So this is kind of like the first experience that we're having with something that can run logs that were generated outside of the event viewer, right? That's available inside of Windows. So we'll need to configure both the Wazuh agent and the SysMon application. The SysMon rules uses rules that are made in XML formatting. For example, in the XML snippet below, we're telling SysMon to monitor for the event of the PowerShell process starting. So SysMon schema version 3.0, whatever, and then you have the process creation. So it contains PowerShell in it in the image, and then the event ID 2, 3, and 4. So file creation, network connection, reserved for SysMon status, and then ID 5, process ended, ID 6, so on and so forth. So all of these things are IDs that are native to SysMon, and it shows a bunch of different things, but the one that we're most interested in is the one that is with PowerShell, right? And so that one is going to, it just says image condition contains PowerShell, and command, the process create includes something that has PowerShell. So basically saying it started PowerShell. That's what all of that says. To instruct SysMon to do this, we need to execute the SysMon application and provide the aforementioned configuration file like so. So sysmon.exe, accept the licensing, and detect PowerShell XML is going to be the specific rule set that it's going to use. And that's available in the file that was on this Windows machine. So this is what it looks like inside the command prompt. And so, you know, they went inside the SysMon directory, and there was nothing in it, it seems. no, excuse me, inside the SysMon directory, they did dir, and it shows you the contents of the SysMon directory. And so we have the actual executable, 64 executable, and then we have the XML file for detecting PowerShell. And so SysMon accept licensing, and I detect PowerShell, and it will now do that. And so this is what it will look like once it actually is using the configuration file. This is what the output looks like. And then it starts, right? So it's loading the configuration file, does all its things that it's got to do, and it starts. So we can verify that it has accepted the config file by navigating to the event viewer and searching for SysMon like so. And so this is another glimpse of the event viewer. We did an entire video on this, so you should be pretty familiar with this. If you have not seen it, definitely go watch the video on event viewer. And so under application service logs, Microsoft, and it will take us to that as we get under SysMon, right? There's a lot of stuff under the Microsoft applications, under Windows, and then it just lists this whole list of things, and then you click on SysMon and then the operational, and it gives you the log itself. And these are the items inside of that log, the events that showed up. We can also launch a PowerShell prompt on the Windows server and return to the event viewer. We can record, we can see a record of this PowerShell prompt being opened within the event viewer. So it's what it's supposed to do. It's supposed to detect PowerShell being open. So when you open PowerShell, there should be a new item that says, hey, process created, right? There was a new thing that was just created. The process has been opened up, and then it gives you the details of that right below it. And we need to configure the Wazuh agent now on this particular Windows server to instruct it to send these events to the management server. So to do so, we need to open Wazuh, the agent file located at program files, OSEC agent, and then OSEC configuration. And this is what it looks like inside a wonderful notepad file. And then we're just going to include the following snippet, which is going to be the operational SysMon location for Windows. And that's it. And you do log format event channel, and then we just add this. It seems to be that we just add it at the bottom, or do we add it at the top? Where is it added specifically? So this is the beginning of it, OSEG configuration, and then it's SysMon analysis. So as long as it's just in there somewhere, it's going to work. I don't think it needs to be beginning, end, or whatever, as long as it's in there somewhere and it has its own section. So you can kind of see the formatting of this, where there's the log analysis, locate file, SysMon analysis, so on and so forth. Once we update the config file, we are going to need to restart the Wazuh agent. And in this instance, we're restarting the operating system just to make sure that everything's all good. So they're just basically restarting the computer altogether. And once this is done, we need to tell the Wazuh management server to add SysMon as a rule to visualize these events. And this can be done by adding an XML file, local rule located inside of this place for OSEC, etc rules, and local rules XML. And this is configuring the Wazuh server to ingress the SysMon events. And so this is what that would look like, group name, so on and so forth. You're more than welcome to pause the screen if you want to break this piece of code down. And so we'll need to restart the Wazuh management server for this to apply. Once done, we can refer back to the management server and notice that data has been retrieved from an agent. So to answer the questions of this section, what is the name of the tool that we can use to monitor system events? And that is called SysMon. And what standard application on Windows do these system events get recorded to? And that is the event viewer. And that, just like that, we have answered all of the questions for this particular task. And it didn't really require us to use the Wazuh application. It's kind of disappointing, but hopefully we'll get some good stuff over there. So now we're gonna talk about collecting Linux logs with Wazuh. Capturing logs from a Linux agent is a simple process similar to capturing events from a Windows agent. So it shouldn't be that crazy. That shouldn't be that different, honestly. In this task, we're going to be monitoring the logs of Apache 2 web server. To begin, we can configure the log collector service on a Linux server running the Wazuh agent. Wazuh comes with many rules that enable Wazuh to analyze log files, and they can be found in var OSEC root rules. So very simple. And some common applications are the Docker, the file transfer protocol, WordPress, SQL Server, Mongo database, firewall, and a lot more. There's about 900 things more. However, you can always do this by making your own rules. And in this task, Wazuh will digest Apache 2 logs using that specific config file. And this rule set can analyze Apache 2 logs for warnings and error messages like this, right? We will need to insert this into the Wazuh agent that is sending logs to the Wazuh management server configuration file located in this location. And this is it. This is the specific piece that says, hey, analyze Apache. And we have the location and the log format. And that's pretty much it, right? So nothing crazy. The question here is, what is the full file path to the rules located on the Wazuh management server? And this is going to be our full file path. That's like, it's a hard phrase to say. Say it fast 3 times. Full file path. Full file path. Blah. Whatever. Okay. Moving on. Now we're going to do some auditing commands on Linux with Wazuh. Since the machine that we're actually on, this machine right here, is a Linux machine, we're going to learn some good things about auditing commands with Linux. Wazuh utilizes the, I really love saying Wazuh. That's kind of, I love this app just because of its name. It's pretty amazing. And I bet you're not going to forget this app ever just because of the way that it's been named. Wazuh utilizes the audit-d package that can be installed on Wazuh agents running on Ubuntu Debian and CentOS. In this task, we're going to be looking at audit-t on an Ubuntu system, which is what we got. And it monitors the system for certain actions and events and will write this to a log file. So we can use the log collector module to read this log file and send it to the management server. First, we'll need to install audit-t package and the audit-t plugin. This may be installed on the system already on the attack box. Probably it's already there. So let's install it to just make sure, and you just do sudo apt-get install yada yada yada, and enable this service to run correctly as well as on boot. So you're going to do enable audit service and start audit service. We will need to configure to create a rule for the commands and events. And in this task, we're going to be telling it to monitor for any commands executed as root, which is probably a good thing to monitor. And you can extend this to monitor commands such as tcp dump and netcat, or catting files such as etc password, which are all hallmarks of a breach, which is very true. If somebody's trying to look at your etc password file, that means they're trying to get a list of all of your users on your machine. And as of course the etc shadow file, all of this is very, very dangerous. So audit-d rules are located in the following directory. We'll be adding our rules manually. For this task, we will need to open this file and append our rule ourselves. First, let's edit the file using sudo nano and appending a exit always yada 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 to the very end of it. So it's going to be, what is that, at the very end of the file, like that. We're going to append it to the very end of the file, and we will now need to inform audits of this new rule. So we're going to run this command and to now read the new rule, and then let's configure the system that is running a Wazuh agent, and we'll monitor these events on, and we're going to be monitoring a Linux host in this case. So in our previous task, we'll need to configure the Wazuh agent to detect the new log file that is generated by audit by doing this thing and adding audit to the log configuration file at the bottom, like so, which is going to be this thing. And we're going to add this to the bottom of our OSEC configuration file. Which application do we use on Linux to monitor events such as command execution? And so that would be audit-d. And what is the full path and file name for where the aforementioned application stores rules? And this is the path file name, right? It's probably this thing actually. The audit rules is where we're going. So that's where it's going to be our path file name. And we're going to paste that in here, and that's all good. So very good. I do want to run the commands of that exercise though, just to kind of get used to this entire environment and make it a little bit more interactive instead of just reading a bunch of things. So the first thing that we want to do is we want to make sure that we have installed the audit D and audis PD plugins. So there we go, and that should be running. And they said that it might already be installed, so this could be the case, but it seems like it's actually doing the installation, so that's always good. And we might need to do this for a later task anyways. So we're gonna run this, and it's almost done reading the database. And then the next step of this is going to be to enable the audit service and then to start the audit service that it can run on boot. So we're going to give this a couple of seconds, and then when that's done, we'll run the rest of the commands. All right, we got that. So now let's do sudo systemctl enable audit d.service, and that's that, and sudo systemctl start audit d.service. There we go. So we got that. And now we need to configure it so that we have that rule added to it. They're located inside the audit rules under etc audit rules, etc. So now we're going to go sudo nano, and nano is our wonderful file editor, audit rules.d/audit.rules. And now we're in here, and we need to add to the bottom of our file the new rule set. And I could probably just copy and paste this real quick just to make life easier for us. Copy and paste. And there's our new rule. And so the way that we save it is Control O, and it's going to ask, yes, do you want to do that? And we Control X, and we're out of there. So now we have modified our rule set, our audit rules. So now we need to inform audits of this new rule. So we're going to run the command to inform that we have this new rule, right? So sudo audit ctl r etc audit rules d and then audit rules. Wow, look at that. Okay, so no rules enabled, failure, so on and so forth, so on and so forth. I feel like that worked. Let me just make sure that I use the right command. Audit ctl r etc audit rules.d audit rules. Yeah, that was the right command. Okay, so we're good with that. And last thing that we were supposed to do is configure the system that is running a Wazuh agent that we want to monitor these events. And we're going to be doing this in Linux. So the specific thing that we're doing is the OSEC configuration file. And we're going to run another sudo nano, but this time we are going to go into the OSEC configuration file, which is going to be in OSEC var OSEC etc and then osec.conf. And then we open this thing up, and I feel like this should already have stuff in it, so maybe I used the wrong thing. So now I'm just going to literally copy paste this command because I want to be in the right place. That's the thing. We're going to do that. Sudo starts with an S, buddy. There we go. Okay, I guess it's an empty file. So we're going to now copy the overall rule, and we're going to paste it in here, and that will be done like so. So now we have it, and there is our new rule. And so Control O to write it out, and Control X to exit out. Saving, but answering no will discard changes. Save, yes, I do want to save this. Error writing, no such file or directory. Okay, well, I mean, write it. What do you mean? Why would you have a problem writing it? So the problem seems to be that there's no such file or directory. So let's go into the var file, and then let's see if we can go into the OSEC file. And there is no such file or directory. Huh. So I guess what we got to do in this case is make one. So I'm just going to make a directory called OSEC, and I'll actually do a sudo command to give ourselves sudo permission. And there's that. And now we are going to go into OSEC, and then we are going to go and create a sudo etc, make directory etc, And now we're going to go into etc, and then we're going to do sudo nano osec.conf. There we go. And so now I'm going to paste this mofo in here and write it, and that should be perfectly fine. Yes. And now we have our OSEC configuration file. And if we go back a few levels, actually we need to go back to this place. And now we have all of that. So, okay, we're good. Okay, so now we have our audit configuration file. And I mean, that's pretty much the last of the series of commands that was there. So from here, we can actually move on to the rest of this stuff, which is the Wazuh API. So let's get into that. Alrighty, so Wazuh API, using our own client. The management server features a rich and extensive API to allow the Wazuh management server to be interacted with using the command line. Because the management server requires authentication, we must first authenticate our client. We're going to be using a Linux machine to curl the installed, to interact with the Wazuh management server API. First, we need to authenticate ourselves by providing a valid set of credentials, which will be done using all of this right here. So once we're authenticated, the Wazuh management server will give us a token similar to a session that we will need to provide for further interaction. We can do this, we can store this token as an environment variable using the snippet below and replacing the Wazuh management server IP with the actual IP address. That is our specific IP at the top, the 124.122. And that's going to be what we're going to do right here. And we're going to save it as a variable called token. And then let's confirm that we have authenticated OK and have been given token by a Wazuh management server. And I need to know what to actually search to get the first authentication though, so that we can get that token. So then we can use the standard HTTP request methods such as get, post, put, and delete by providing the relevant option after an X. The X get would, for example, be the command. And so curl k x get, and then it's going to get this, and then H authorization bearer token, and it's going to get our token variable. For example, we're going to use the API to list some statistics and important information about the management server, including what services are being monitored. So we would run this xget HTTP on the IP, port 55,000, manager, configuration, pretty equals true, meaning we want it to be output in a pretty manner. And then we want the ion global and then authorization bearer token. And so this is what the output is going to look like for us. And it's going to say what's running and what's stopped, basically. And that's it. So perhaps we can also use the management API to interact with an agent. So this is what you would run to interact with the agent. And this is all one line, by the way. There's no spaces or anything between this. It just happens to be a very long line. But so this is the, these commands have a space between them, and then there's a space right here. And then you have that full thing, that's one line, and then space, so on and so forth. So that's what that looks like. And then this is going to give us the information about the agent, which is going to be worker number 2 and version, name, yada, 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 right? So Wazuh agent 1, so on and so forth. And now using the API console could be done through the GUI, through the actual web portal. So we can go to tools category with the heading at the top, of course, and then tools API console. And it'll open this up right here for us. And it looks very similar to a command line, doesn't it? So there you go. And so it's awesome because it seems to be that literally with one click, he was able to load all of the things that he needed into the output, which is super freaking useful. So you'll be greeted with a few sample queries. Simply select the line and press the green run button, and it'll show what is available like the output below. So that was great. So what is the name of the standard Linux tool that we can use to make requests to the Wazuh management server? And that is curl. What HTTP method would we use to retrieve information? That's called get. What method would we use to perform an action on Wazuh management server API? So this is odd. So if it's not get, I mean, it could be post, but it's supposed to be 3 letters. So the only other thing is put, and put is used to update something. And they said perform an action, which I guess could be put, whatever. But that's kind of neither here nor there. So navigate to the API console. So let's go here. We're going to click back onto this thing, click on here, go to tools, and then we're going to go to the API console. So there's that. And then use the API console to find the Wazuh's server version. You'll need to add the V prefix to the number for this answer. For example, V1.23, okay. And so the hint says get manager info. That's what the command is that we look for, and this is the command right here. So we're gonna do that, and it should give us our version, which is version 4.2.5. And so we're gonna copy that, go back here, and paste that, and just like that, we have completed the API task of Wazuh. Very cool. Moving on to generating reports with Wazuh. Wazuh features a reporting module that allows you to view a summarized breakdown of events, and we can go under, so Wazuh modules, and then it's going to be security events, that's where it's going to be, and then it's going to show us, and then we're going to create generate report on the far right. And if it's grayed out, there is no report data, so you can't generate anything. You'll either need to you will either need to change your query or extend the date range. Okay, fair enough. And the report may take a couple of seconds to a few minutes to generate, depending on the amount of data. After allowing some time, we'll navigate to the report overview dashboard within Wazuh, and then we can go into Wazuh management and reporting, and that's where that would be. And the report overview lists all generated reports. To download a report, we can click the save icon, so simple enough. This is going to be, this looks like the security events report. This is kind of what it looks like. And so use the Wazuh reports feature to generate a report of an agent, and navigate to Wazuh report dashboard and analyze the report. What is the name of the agent that has generated the most alerts? So let's go here. We're going to go here, and we're going to go to modules, and we're going to go to security events, and we are going to generate a report. I guess we're going to do it for agent 1. Let's make sure it finishes loading. Okay, very good. So agent 1 generating reports, and that should take a couple of seconds to a minute. Okay, that one finished pretty quickly, and we'll click on this one to see if we can do THMDC01, and then we'll have that run a little bit, and we're going to generate a report. I mean, just from the desktop or from the visual, it seemed that agent 1 had more time, so or it had more items show up right here. So that was the kind of the issue with this particular case, and it said that there was an error that popped up at the bottom right, but it's saying that it's generating the PDF document. So is it working or not? So it says go to the analyze reports, and that's management status and reports reporting. So while this is running, I wonder if I could go to management reporting. This is agent 1 report, and let's go back to see if we can get that second report from THMDC. And we do want this report, so let's click on generate report one more time. Okay, no error message this time. Very good. Now we have both reports created, and so now we can go to management and status reports reporting, and then from here we can look at these things, and it seems like we have to actually download them, so I don't think we can just view them from here. So I'm going to download that report, and it's going to show me right here. And so we have what we have: the top 5 rule groups, which is OSEC and SCA. At the top right here, it doesn't give us the number of stuff generated. We can look further down, And these are the different alerts and the requirements and alert groups and the alerts and so on and so forth. And so what do we have here? The description, level count. So this is the count of this. It seems generic. Doesn't seem a lot. So we have SCA count 73 and an OSEC count number 3. So that's basically it. So this is the one for, what is it? Agent 02. Wazuh Agent 02. Oh, Agent 02 was the DC controller. That's what it is. So if I click on Agent 01, it's going to show us a completely different thing. And if we actually go back to Agent 02 and go to the top of the page, it should say domain controller as the name, right? Yeah, THMDC1. So this is the domain controller report, and now we have actual Agent 001. And so if we go all the way down to look at the numbers here, the numbers for this are significantly higher. And this was already visible on the portal on the desktop. So we can see that obviously this is the one that's generating the most reports. So what's his name again? It's Agent 001. I think that's what his name is. Let's just copy this and do copy. And we're going to go here and we're going to paste this mofo right there, and voila. And that is our answer. So not bad, pretty cool. It's nice that it opened it inside the browser and we didn't have to download it and open it inside a PDF editor and all that stuff. So, okay, moving to the last piece right here, which is loading some sample data so that we can analyze some sample data with Wazuh. And here is the sample data. So the management server came with sample data bundled with the installation that can be loaded. We have not enabled this by default to improve the performance of the server. However, if you wish to import much more data to showcase the extendability, follow these steps. So open Wazuh, click over to settings, click sample data, and add the data. So we can do that. And then once we add it, look at that, 48,000 events. So that's much bigger. And so this is kind of what it would look like. And then we can modify the date. So you need to play with a date range. The absolute minimum required to show the sample will need to be at least 7 days, and refresh the dashboard. And then I've imported the sample data. I've played around with the sample data. Those are really the only things that are available here. So I'm just going to go here and go here, and it's under tools, I think, was it? Or settings? Sample data. There we go. And we're going to sample auditing, sample threat detection. Which one should we do? Let's do security information. Why not? We're going to add the data, and let's see how long this takes to load. All right, that was fairly quick. So now we can go back to the modules, and let's go to security events. And we have THMDC01 that had 79 events previously. And so now it has 3,000 events. Look at that. It's a lot of stuff going on. And so the top 5 alerts have to do with Apache, attempt to access forbidden directory, multiple web server 400 error codes, the web server 400 error code, file added to the system, and Windows service startup was changed. So these are the top 5 alerts that showed up. And then we have down here security alerts as well. So rule ID level 5 would be SSH attempt. Level 10, which seems to be really bad, it's multiple authentication failures on SSH. That's pretty severe. Multiple web server error codes with the same source IP. That's also pretty severe. So that's pretty bad. Oh, there's one at the bottom that says SSH brute forcing, trying to get access to the system. That's pretty bad. So it's that's all pretty bad. This is really cool, honestly. I really like the fact that this thing even exists, and it's nice that it's an open source software that essentially anybody can use and configure so that it can manage and kind of secure their endpoints on their system. It's very, very useful. I think this is actually a very cool tool. Apart from its name being Wazuh, and then so we can click on authentication failures just to see the authentication failures, and then we'll see all of this stuff right here. So now these things change too. So SSHD, attempt to log in using a non-existent user, maximum authentication attempts needed, multiple authentication failures, brute force trying to get access to the system, authentication failed, so all of that stuff, and that shows over here too. And so we have under the severities, level 10, multiple authentication, brute force trying to get access to the system, you got multiple authentication failures again, you got another multiple authentication or brute force failure. This is pretty crazy that these freaking people have been I know it's sample data, but it's like, how dare you try to access the system and try to hack us and all that shit. So that was it. That was it for the sample data. And obviously we could do so much more stuff with the sample data. But for the interest of time, I'm going to wrap the room. But I will remind you that this is a free room with TryHackMe. So you can go in here and do as much of it as you want and play around as much as you want and learn as much as you want, which is all super useful. So that's it. We just wrapped the room for Wazuh. If you found this information useful, if you found any value from this video, I invite you to like, subscribe, turn on the notification bell, and even drop a comment. All of those things helps the YouTube algorithm to find our channel, to help us expand the community. But also, as an extra win for you, when you have the notification turned on after you subscribe, it notifies you when a new video comes out. And if you're studying to be a security analyst, or if you're studying to be an ethical hacker, then all of these videos will actually be very helpful to your path to becoming who you want to be. These are all relevant information and all relevant tools that you're going to end up using in your journey as a security analyst or an ethical hacker. So I invite you to like, subscribe, turn on the notification bell, and even drop a comment, just so you can, number one, you'll be helping us grow and you'll be helping the YouTube algorithm, but more importantly, you'll be getting notified the next time a video comes out. And that's a win-win for everybody. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite system and network attacker. And if no one else loves you, Hank loves you. Peace, love, and chicken grease. I will see you in the next room. Later.